Hey there, welcome to this advanced generative AI course by Simplilearn. If you've ever wanted to dive into the world of generative AI and see what all the buzz is about, you are at the right place. Whether you're looking to level up your AI skills or get into AI engineering or simply explore how these tools are changing the world, this course has got you covered. We are going to explore how generative AI works, how it's shaking up industries, and how you can apply problems. Here in this course on business, Otter.ai, Video, Descript, and Sora. These tools are making a real difference in various industries. Second, we will explore the heart of generative AI models, diving into LLM concept and how generative AI differs from traditional AI. Plus, we'll also look into agentic AI, a fascinating subfield of generative models. Next, we'll cover generative AI and Hugging Face along with deep learning architectures, two essential topics for mastering AI tools and platforms. After that, we will explore encoder-decoder architecture, the attention mechanism and transformers, which are the secret sauce behind large language models. Then, we'll dive into practical aspect with OpenAI APIs, prompting techniques, and understanding how embeddings and semantic similarity like cosine similarity work. We'll also touch on advanced generative AI concept, including GANs, RAGs, and VAEs. And finally, we will wrap things up with a discussion on LLM hallucinations, RAG fundamentals, and how to build a solid RAG pipeline. Also, guys, if you're interested in mastering the future of technology, then the professional certificate course in generative AI and machine learning is the perfect opportunity for you. This is offered in collaboration with ENICE Academy, IIT Kanpur, and it's an 11-month live online course providing you hand-on expertise in cutting-edge areas like generative AI, machine learning, and tools like ChatGPT, DALL-E 2, and Hugging Face. You'll be gaining practical experience to 15 plus projects, integrated labs, and live masterclasses delivered by esteemed IIT Kanpur faculty. Alongside, you'll earn a prestigious certificate from IIT Kanpur, where you will receive official Microsoft badges for Azure AI courses and career support through Simplilearn's Job Assist program. So what are you waiting for? Hurry up and enroll. You can find the course link below. Now to get started, here's a quick quiz question for you. The question is, what sets generative AI apart from traditional AI? Your options are using existing data to generate responses, creating new original content from data, cannot generate creative content, or none of the above. Let me know your answers in the comment section below. So now that you're warmed up, let's dive straight into the world of generative AI. Without any further ado, let's get started.
Now, the first thing is about impact of Gen AI, right? So even before we dive in, this is just a quick thought experiment on the slide. Well, see, we have already seen AI creeping into our daily workflows. Maybe either through tools like ChatGPT or Copilot, or even sometimes it is embedded into our CRM or ERP, like ChatGPT for writing the emails. Or some of your team might be using Copilot in the VS Code, like I use it every time. I'm sure you have also seen the automation in the customer service or the reports. So, what you are experiencing over there is nothing but the impact of generative AI. And it is not just in isolated tools, but across the entire business value chain. So Gen AI is no longer confined to research bias, but I would say it is transforming how organizations work, decide, and innovate. Now, this is the first and the most visible impact area. See, what is Gen AI mainly helpful for? It is mainly helpful for automating the repetitive task. So you can think of marketing report generation or customer onboarding emails, or even any kind of internal documentation. Companies over here are using tools like Bardeen or Zapier to automate. Automate in the sense, if this, then that kind of workflows. It's like extracting the meeting summaries from the Zoom and generating a follow-up email automatically, or even updating your CRM records instantly. Then the next one is the Sales and marketing. So in sales and marketing, Gen AI has proven to be a complete game changer because you can easily generate the product copy, campaigns. You can even generate customer insights based on the real time data. So if you look at tools like Jasper, copy.ai, they are good for creating hyper personalized products. So if I just take you through Jasper, it is built for marketing only, right? Is a AI platform that unifies brand experience and accelerates content velocity and automates the marketing process at a scale. You can see over here, web page optimization possible, organic traffic 67%, bulk create 5,000 plus retail product pages, 22% e-commerce revenue, 6,000 hyper personalized email within minutes, scale a launch campaign in within 8 days, into 8 days, within days. That is the kind of power that you are getting with the help of this. So therefore, world-class marketing team leaders, they trust Jasper. Okay. Of course, you can explore through it, but I'm just giving you a heads up of this. So this is one thing as I told you. The another one is, you can also go for copy.ai. Introducing first ever go-to market AI platform. Automate hundreds of tedious, repetitive tasks and empower your team to scale like never before. Free AI writing generators, chat, content creation, and if I click on that, see Hello GTM agent platform. Create content, generate pipeline, execute campaigns, close the deal. They are nice, they are good. Use cases also they have mentioned over here, what all you can use it for. Cold emails, lead account, CRM intelligence, content creation, translation and localization, and whatnot. Resources by team, learn more. Let's say if I open one of it, Juniper increases OpenX rates by 9%, and some more use cases. Look into the categories where this can be useful. You can explore it out of curiosity if you are a marketing guy. So in e-commerce, as I told you, companies are using Gen AI to test 100 different ad variations within minutes. Something that used to take marketing team not one day but several days, 10 to 15 days were easily required. Now it can be done in minutes. Software engineering. So developers are among the biggest beneficiaries, I would say. Just yesterday only I read at one of the blog which was saying the uh, I'll I'll show you. Let me see if I can actually find it. It should be there in my I had saved it just a moment. This one. The very interesting blog which I was looking into. So not to scare you, but just to make you aware of this is how AI bubble will pop. In fact, it's not only about this. Have a look at this blog as well. This is actually said by OpenAI's Sam Altman, who sees AI bubble. So he reported that AI could be a bubble, comparing the market conditions to the dot-com boom in 1990s. And all of a sudden, in 2000, we faced the Y2K problem. So are we in the phase where investors are, as a whole, overexcited about AI? My opinion is yes. Is AI most important thing to happen in a very long time? My opinion is yes. Alibaba co-founder Joe Tsai right? They also have raised the similar warnings. So they think that AI is bubble and it can burst anytime. And the reason for that is I researched a little bit and I found this nice blog. October 2nd, right? It's very fresh. Today is 11th. Some people think AI will mostly be the technology of 21st century. Others think it is an obvious economic bubble. I believe both the sides are right. AI will rise, then crash, and eventually stabilize. Look over here. You understand, right? CapEx, capital investment. So, how much companies are investing in AI? So, hyperscalers' annual CapEx has more than doubled since ChatGPT's release. As you can see, 2018. Look at the overall investment, less than 100 million USDs. And as of today, it's rising like anything. But the thing is, 90% of the AI projects are failing. They say AI will be able to replace, but if that is the case, then I think 90% of the developers should have lost their job. Even if you take any, take any company, take any service company, even if you take TCS, right? They have around 3 lakh employees, but they have not fired 90% of their employees. So you can read through this. This is very good blog. Another one, yes, I think I found that report which I was actually talking about. 95% of generative AI pilots are companies, AI pilots at companies are failing. Report by MIT. So, despite the crash, about 5% of the AI programs achieve rapid acceleration and most of them fail. And that is the reason. You can read through this. This is again a very good blog. It is not only confined to this, there was one more similar link over here. Anthropic CEO says that in 3 to 6 months, AI will be changing 90% of the 90% of the code software developers were in charge of. Has that happened? No, it has not happened. That has not happened. This is what he said in where? I guess, where is this blog date? Somewhere in August only, right? March. AI could be writing essentially all of the code in 12 months. MOD, the CEO and co-founder of Anthropic said AI could be writing coding most of the software soon. He said have similar impact in the industry. Has that happened? No. We are almost in the end of 2025. This is certainly not, right? I think there will be 3 to 6 months where AI is writing 90% of the code. And then in 12 months, we may be in the world where AI is writing essentially all the code. ऐसा नहीं हुआ. This has not happened. So you are studying AI, right? Should you study or not? Continue your study. Obviously, there is going to be a dip for sure, and there will be stability. Every time that happens, right? You start a new startup, a lot of money comes in, and then people get used to it. Then you get a stabilization. So expect. So I would say when it comes to software engineering, coming back to our deck, are among the biggest beneficiary. I find this to be very helpful. Gen AI tools like GitHub Copilot, Tab 9, Amazon Code Whisperer, all of these are helping the engineers generate the boilerplate code. You can write the test cases and you can debug it more efficiently. In large DevOps setup, developers are using Copilot not just to write the code, but also to review the Copilot quality. Review the code quality written by Copilot, and they can also generate documentation. They can improve the sprint velocity by up to 30 to 40%. Yes. So that is the advantage of going for it. The fourth one is your customer service operations. So your chatbots and your digital assistant, they are no longer rule based, right? They are conversational, they are empathetic, and they are context aware. So if you look at companies like OpenAI Assistant, companies are using OpenAI Assistant or Vertex AI. So let me show you, right? So they say OpenAI migration guide. And no, actually not this one. But yeah, I think they launched something new. They also launched Agent Builder today. So now you can actually create a workflow in the OpenAI platform. When we start with the GenAI side, I'm gonna talk about all these things. But this is paid. Everything in OpenAI is paid. As you can see, this is my personal account. If I get into my profile and API keys, I have to create my API key and then only I can do that. And creation of API key is free. But for inferring using API key, you need a balance. And for that, you need to recharge your account with minimum of $5. That's more than sufficient. I think in the past also I might have made multiple recharges like this. Yeah, you can see there are three recharges which are made by me in the past since October 2023. I have multiple API keys because I am associated with so many vendors. So during the training, I get it and then it gets deactivated. So I have kept my own as well. But coming to the topic, you have over here the agent mode also, which has been recently introduced. So without writing code, you can create nice workflows. Well, let's look at a customer workflow resolving the customer queries with custom policies. It's a already created workflow.
Hey everyone, this is Christina from OpenAI. Welcome to Agent Builder 101.
I'll be explaining you all of this when we go ahead. It's not a part of the course, but I think this is state of art thing that you should know.
Agent Builder is a new visual tool for building AI workflows. You connect your own drop down and IT flows.
So it's
Next,
all
you'll connect.
it's basically everything is drag and drop over here. So from the start, then when I'm adding an agent, you just have to drag it and add it. It automatically gets connected. Then you can give the name, instructions, and these all things I'll explain you. It's easy. Basically, I can explain you right now also, but that's not a part of this course. But yes, right. Then I can add an if-else condition, right? So if the input pass classification is equal to flight info, then what to do? So the loop goes over here to the flight agent to book the flight ticket, let's say, and there will be web search for the flight ticket. So see, you can create nice workflows. It's super easy, super easy. And this is what we do it in Python code as well. And see, this is the backend, the code which is written. I can also upload the data set if I have anything. And I'm just quickly skimming through it. And when I publish it, what are the workflow before publishing? Well, you can see this is a simple workflow which I created. And I publish it at the name travel agent. And now agent SDK, this is the code for it. So without writing any code, you have written so much of code. This is the chat kit. So I can actually copy this workflow ID and use it for inferencing. I can also add my own domain if I wish to. Okay, that was it. Okay, they didn't show the execution of the workflow. But that's okay. I was expecting that also to be a part of this. But this is where, I have this. And in this way, you can have multiple other workflow. This is for document comparison. As you can see, start, tries, request, if else, what to do. You want to provide reconciliation or provide explanation or retry. And then at the end, it is approved or it is rejected. And select this. I can publish it by any name. So let's say this is the agent SDK code written. I can clone the sample app, simple. And this is where I have the GitHub repository of it. And then I can use it in the Python code, right? So that is the advantage. Domain ID, I think this is newly added. I'm not sure, but maybe it is for using our public key. Okay. Not very sure about it. I need to figure it out what it is. Okay. So this is what we did. Delete the workflow. Yes. So coming back to this. So that's exactly what I was saying. In the customer service operations, companies are using the OpenAI assistant or even the Google Vertex AI agents to resolve the queries that require human escalation by creating the workflows. So the difference is that the models understand the intent and not just the keywords, and thereby improving the customer satisfaction score significantly. Then you have the data analytics. So in data analytics, traditionally we know data analysts they had to spend huge amount of time in cleaning the data, right? You have we have learned pandas, right? We have spent a huge amount of time in cleaning the data, creating new columns, transforming, interpreting the data, getting the insights from the data. But today, Gen AI agents are doing the storytelling. They are generating insights in a natural language. So with ChatGPT's advanced data analysis platform, analysts can now upload a CSV file and quickly get summaries. So here only, I can actually go to GitHub, Titanic dataset, which we already worked upon. Let's say I'm saving it into this and I drag it over here, and I can ask ChatGPT to act as a data analyst and go through the attached file. Explain every column of the dataset in a single line. I don't think so that's even required. It has done the thing. Oh my God. You see, missing value analysis, all these things done, first 5 rows shown to you. And it is asking, do you want me to proceed with EDA? For example, this is, I can run the full EDA. So I can say, okay, then, I mean, if it is being so polite, then let me take the complete advantage of it. Internally, it starts writing the code, which we are already aware about. You see, it has written the code for survived value counts, survival by gender, survival by passenger class count plot, age distribution histogram, fare distribution histogram, survival rate by embarkation correlation plot, and you get nice plots over here. Survival by passenger class, age distribution, fare distribution, and survival by embarkation port. And the correlation, all of this is what we have seen. In fact, I remember we had invested almost 6 hours on this EDA and insights. You get everything. Now, GPT is awesome at all of these things, fair distribution and everything it has helped us out with. That is good. Yes, so that's exactly what I was saying. That today with ChatGPT, because we have the code interpreter integrated inside the ChatGPT, analysts can upload the CSV file and instantly get the visual summaries, correlation insights, and even the executive level recommendations. So this is something which is bridging the gap between the data and the decision making. And the last one, which is nothing but the product release, a product research and the development. This is exactly where innovation happens. So as we understand Gen AI can brainstorm product ideas. They can analyze market gaps. They can even simulate the user feedback. So if you look at pharma companies, they use Gen AI to generate potential molecular structure for drugs. In consumer tech, teams use it for prototyping, rapid prototyping, and even generating the product concepts. wireframes, basically the handwritten diagram of how the website is going to look like, and even marketing materials within the same day. So overall in this wheel, we understand that it is not just about automation, it is all about augmentation as well. Gen AI is not about replacing the human capability. It is about multiplying it. So every department, be it sales, R&D, it is now becoming AI powered function. And the key differentiator for the organization will be exactly on how fast and responsibly they are adopting these tools. So now this is where we talk about the tools. We have to see a small demo of these tools. Uh, so starting with it, the first one is the sorry, the first one is the Zapier. Now, see, I'm sure at times if I ask you a very simple question, how many of you feel you spend at least 30% of your time every week doing repetitive tasks, maybe like downloading the files, copying the data, or sending up follow-up emails, depending on your use case? I'm sure, depending on your use case, somewhere you will be following, right? Ideally for repetitive tasks, or maybe for copying the data, or emails, or could be anything simple. So we all end up investing a lot of time on all of this, and it's kind of a part of every role, to be very honest. It's a part of every role. Everyone has to go through it. And this is exactly what is the problem. Whether you are in marketing, HR, finance, IT, we all waste time in routine actions that do not add strategic value. And this is where Gen AI and automation steps in to free up the human time. So if you look into the powerful business use cases for workflow automation, we have two tools over here. These are the two who have become leaders in the space. One is Bardin and one is Zapier. And you know, let's try to get into this. So what is workflow automation, right? I gave you one example using the OpenAI's agentic workflow, right? So traditionally, automation basically meant that there will be very traditional rule-based systems. Like if I receive an email with subject matter X, then move it to folder Y. Simple. But because now we have Gen AI powered automation, the system actually understands the context and performs the intelligent actions. Like it can read the email, it can summarize it, it can classify the request, or it can even be getting into the replying mode or logging it into the CRM system automatically. Imagine there is a customer support team at some logistics company. When a client email is saying my parcel hasn't arrived, then the AI system can extract the tracking number. It can check the delivery status and generate a response and even raise a ticket. All of this will happen without human involvement. Now coming on to Bardin. Bardin is basically the no-code automation assistant. Bardin is the no-code automation assistant. So it's like your personal assistant that is going to automate the browser-based workflows without needing a single line of code. Just a few use cases of that. You can set up Bardin to automatically pull the data from your LinkedIn profiles and summarize it and push it into a Google Sheet or a CRM. Possible. Recruiters use it to shortlist the candidates. Marketers use it to scrape the competitors' data. And the salespeople will be using it to follow up the leads automatically, right? So it is, basically all this is happening because of the natural language understanding and the browser actions. So we need not write a script. We can just say Bardin, summarize all unread emails with keyword invoice and log them into Notion. Notion is another tool. Similarly, you have Zapier. Now, Zapier is more powerful. Zapier is more powerful. It is kind of like a bridge in between 6,000 plus applications. Yes, you heard it right, 6,000 plus. It will allow you to link the tools like Gmail, Slack, HubSpot, Airtable, Asana, and thousands more. So, a marketing manager can connect a type form for customer feedback to the Google Sheets for data logging. Then take it to the Slack for Insta alerts. Or uh, let's say when a new order is placed on Shopify, Zapier can trigger an invoice generation in the QuickBooks and send confirmation via email. All of this is going to happen automatically. All of this happens automatically. So Zapier is the backbone of the cross-platform automation. And now with the Zapier in action, you can literally chat with the workflows, like you can say summarize all the customer or summarize all the support tickets which are received this week and post them to the Slack. So if you look at both of these tools, Bardin is what it's kind of it's brilliant for personalized browser level intelligent automation, and Zapier is good for system level app to app integration, just like I showed you on OpenAI, right? So together, this is exactly what we call as the AI native automation, where the human workflows are intelligently replicated, not just programmed. And this shift is what take the organizations from doing repetitive work to the process of orchestrating the intelligent systems, right? This is something like before. Then after that, you can see over here, we have a short demo for creating a Zapier account and create a basic Zap over here. And all of these things are there in our this only. I I had used this Zapier long time back, and there are I will let me try. It was giving some issues, but I think I should be able to cope it up impromptu. In this demo, we'll be going through the Zapier account. We'll be creating that. We'll be creating your first Zap to streamline and automate the marketing workflows, efficiency, and productivity. There was some issue in this very first exercise only, but no worries. Let's get into this. So it's all about creating our very first Zap. First is we have to go to zapier.com, and I have already signed up. You are signing in back and you have it over here. Create a Zap. So set up the Zapier, sign up on Zapier, which is already done by us. Coming down, sign up, everything is done. Enter email ID, password is all good. This was not even required today. Then they say, yeah, select the apps that you want to use. So choose an option that best reflects how familiar you are with automation. Select company size, job level. Yeah, finally, this is the step 2. We are already done with this. These things are already automated. We get into creation of the very first Zap. You see over here, we can see it here only. Enter the idea or the app name to get started. There are also some popular templates available. AI workflows now. This is for new leads and this is for receiving automatic updates in the Google Sheets with the Chat GPT insights. This is good. This is also for instantly respond to the new emails with the AI powered replies via Gmail. So I'll try to click on this. So step 1, new email. Step 2, send prompt to Google AI. And step 3, send email. Let's try it. This is just like the Copilot mode. Now you can see over here, I'll just put it to the side. This is the workflow which I created, right? So you can see over here, Gmail receives a new email. It is going to send a prompt to the Google AI Studio. and we are going to send an email. So I can actually click on this, and double clicking on this opens this, double clicking on this open this. So I'm just double clicking on this. You can see over here setup email. I'm changing it. It is asking, you want to set up email? I say yes. I can, so many are available. Gmail only. Right. So when a new email comes in, what to do, or a new attachment comes in, what is the thing that you are looking for, right? So I say whenever a new email comes in, not a new conversation, not anything else. When a new email comes in, I want to sign in. I'll check which account. Let's say here, I sign in. I give it accesses, continue. So you can see over here, I have used it in the Zap. I can now have the option configure, and here is where you must select a label or a mailbox, or Zap will trigger on all the emails. So which emails? Let's say I'm specifically looking for emails in the inbox. Then I go into test. I can trigger, right, this to this. I can test the trigger whether it is working. Well, it is pulling up some emails from my mailbox, and these are the ones that it has pulled up. This is from this one more. These are all the contents of the email. This is one more. Aditya Birla, congratulations, your application has been approved. Did I get anything like that? Somewhere over here. See here. So let's say, okay, I will, this is coming on 11th October. Find new records. Once again, running it. And let's say I am continuing with the selected one ahead. Now, what to do after that? So we are going to give a call to Gemini AI Studio or anything else. Now we can choose among over here. So many are available. I can also give a call to ChatGPT, OpenAI. So I say consider AI by Zapier for this step. You can select a popular AI model from this. With AI by Zapier, you'll be able to use our prompt generator and improve the testing. Though it's not required, but I'm just putting it. Or let's say I'll skip it, not required. So I'd like to undo it. ChatGPT action event. Analyze email, analyze text, summarize, classify, analyze text. Connect with ChatGPT account. Let me connect with my ChatGPT account. So create an API key to access your this. When something is stuck up, let me first. Is it asking if you get an API key? Create an API key, that's done. And organization ID, yes, continue with this. Okay, it's done. Finally. Continue. Enter the text to be analyzed. So we can use the model which I want to use. So let's say if I'm using, yeah, GPT-4o mini, it will not charge me. And text for analyzing. So let's say I look for an article on Diwali, randomly copying it. What I want to do, classify into category or summarize it. Let's say classify, analyze the sentiment. That would be good. Text is here. Temperature and all we will study in our GenAI course. And this is good. We get into testing. Anything here? Yeah, now it came continue. I get into testing step. Sentiment is neutral. So I can say, go to ChatGPT. Let's say, create a 10-line paragraph on Diwali with negative sentiment. Negative. Done. I say continue. Sending the emails. Right. And BCC to no one from obviously me, and reply to, I can add a field mapping, or or let's say no, reply to no one. Let's say subject in the email is hi Manu, body type plain, body Here is the sentiment. I can add my signature, whatever I want, whatever I want, I can add it, and let me just test it. Okay, I think I took the first one, Raj and Pritam. I'll just go on this and let me, please, no problem. So now, chalo, it is working for sure. We have tested it in parts. And now I'm publishing the workflow. And see over here, this is the problem. You have included the advanced features like multi-zaps to unlock this, or start pro trial. So what? So I don't want to start my pro trial, or if I start it, then 7 days. But before that, you won't be charged today, but after that you would be. So I don't want to get into that. But I think when you do that, when you run this as a workflow, then whatever new mail comes in, that email will be analyzed over here and this. So if I go on, let's say to YouTube, basic Zapier demo, and business automation tutorials. So at least, there will be workflow which will be ready. Gmail matching. Then I guess sending to Slack. So this is the overall workflow created by him. God is showing a lot of advertisements more than that. Finally came back to his one. Is going to show something or not? Waste of time. Automatically post content on multiple platforms. Or quickly making a zap. Copilot is also there. Yes, Copilot 365 is doing analysis and summary. But see, Copilot is there inside your Microsoft, what do you call? Microsoft suite in the ecosystem, right? But Zapier is integrated everywhere, right? It has actions to connect outside the Zapier as well, which is the power of Zapier. So if I get into this, so it cannot do multiple things. So only a single workflow. So let me say, if I kind of just delete it. Yes, really delete. And email received and send email. Publish. Single workflow. Whatever email I receive, it will be sent to Manu, diverting. And I'll run it. Why was it not successful? Receiving, that we already tested. This is fine, tested, and setup is good. Event is new email, configuring the inbox. And okay, it needs something compulsorily. Send it to Manu. Yeah, this is all good. It needs something in between. I think that's compulsory. But that's okay. I think we understand it. So I'm going to delete this Zap. Let us see quickly what is there in the demo over here. So they had searched for Google Sheets in the search bar. Let's try to do this. Anything can be done. So if I come over here in the Zapier. So they say in the search bar, in the change trigger, you search for this. So here I'm searching for Google Sheets. And the next thing, after searching for Google Sheets, what are we saying? Under the event, select a new spreadsheet row. So under the event, I'm selecting a new spreadsheet. Connect to Google Sheets. That account will be selected. Then after that, now you go to Google Drive, make a sheet and name it as lead data sample. So this is done. Continue. Spreadsheet value. So I'm going to create a new untitled spreadsheet. Let us call it, let's say, by the name template1. Trigger the column. Let's say column A. Continue. Testing the trigger. So I don't know where it created the spreadsheet. So go to drive and resend. Yes, it created a spreadsheet. I should have ideally created and added that, but you see over here, it has, and wait a minute, is it created just now? Yeah. Course setting, name Darshan, name Divyanka, email address. I'm not sure. Let me just check in. Course rating is pulled up. Suggestions. And this, okay. And then after doing that, what action we have to select? So they asked us to create a lead data sample, and let's connect with that only then. So, oh no, this is a different one, 100%. Yes. I'll go and create a new one. I don't need the OpenAI API key. Inside this, configure, which is the spreadsheet, lead data sample, worksheet value. So I say new, trigger column. Let's say column A. Continue. So it basically gave the name here only because I added it that way. Okay. Now that it is working, the next thing that we have to do is, once the account is selected, say continue, that's okay. Under this lead data sample, you will be seeing Google Sheet, which is linked to a Google Drive. That's fine. In the sheet 1, fill up the lead data, something like this. Now, this data would be there somewhere, or I can just copy this quickly. Okay, I have this data. I pulled it over here. Then, after that, test trigger button. You can see this information is being pulled out. Ankita 889, which was there here, right? Ankita, Shabnam, and everything. Then after that, okay. So here, this is done. After that, click on the action. So here in the next one, we get into the action. This is okay. I get into action. Now, what action do they want us to take? Action. Send an email. Chalo, theek hai. So connect to my Gmail. Choose an action. So anything specific that they are looking for over here in the action. So action is the name, which has email ID. Okay. So add label to email. Okay, let's click on send email. And this is okay. This is already configured. Continue. And send it to whom? Let's say I'm copying Pritam's ID as CC. BCC, I'm copying the Raj ID. And one more CC as Manu's ID. And then from whom? So I can put my name Darshan. And rest all things are good. And then in the to section from the sheet name this, select further button. Okay, so all these 3 emails are there for configuring. To whom is already done. CC is done. We have added this from whom, from me. So here it will be Darshan English. Subject is hi. Body is hello. Default signature, and I can skip it. Attachments, let's say trying to attach. No, I need not attach anything. That's okay. I'll click on continue then. Just testing it. And yes, it was successful. So see, this is the friendly introduction to the Zap, right? Zap is something which can be continued for at least 15 hours. 15 hours of story on Zap is easily possible. That's why I prefer to keep it at the last. Yes, Manu also, it's sent to you, Raj also. And okay, hi, hello from this is, and did you receive one more? Because I published it as well. I published it. So after publishing, have you received one more email? Hmm. Yeah, this was the testing part. I get it. But after publishing, did you receive one more email where it is taking from the Google Sheet and sending it? Only one? In Google Sheet, email was different. Did I did I receive it? No, I didn't receive it. So let me put the email ID. So if I'm putting this email ID, are you getting it now? And I edit and it's already published, right? Uh, okay, fine. Fine, fine, fine. I'll just delete the zap. Hello? I'll account. This takes a lot of time. That's why I prefer to keep it at the last only. But anyways, I think this is okay. At least the next tools won't take a lot of time because after this, when we get into the next, creating video, well, it's just 1 minute story, but video creation takes a lot of time. So all these tools are fast. Only this is the one which is time consuming. We'll see that. Right. Now, the next thing that you see is the sales and the marketing folks, right? Generative AI have enhanced sales and marketing efforts as well through personalized content, right? So, see, think about it. Whenever you think about marketing, what is important to drive success? Creativity, speed, personalization, any one of it, some of it, or all of it? Ideally, all of it? Yes, all of it, right? Personalization is the key, no doubt about it, but all are important, right? Campaigns need to be going out fast. Therefore, in the business environment, marketing success depends on the ability to create personalized content quickly and consistently without losing on the creativity. So here, this slide, this is showing how generative AI has revolutionized the sales and the marketing by empowering the teams to generate campaign videos, visuals, and insights in fraction of time. The first one is in video. I think we have the same demonstration later on. Stable diffusion is one thing which anyways we'll be doing it later in our Pythonic world in our next course. So in video, what is in video? Well, in simple words, you want video creation in minutes. In video is for you. It is a video creation platform that converts text into ready to publish videos. So you can give it just a simple type, create a 30-second promotional video on our new eco-friendly water bottle guard targeting Gen Zs. And in video, we'll be generating personalized, high quality professional video. This will take around 4 to 5 minutes. But yes, this video will be completely aligned with the brand's image based on how good prompt we give. There will be video having visuals as well as voiceover. So a travel agency, he can use in video to create short destination highlights reel for an Instagram or LinkedIn, which can be automatically pulled from their blogs. So that's one thing. Writer, RYTR. It is personalized AI copywriter. So it is an AI tool for generating the written content. right from ad copy to emails, blog post, or product description. Writer can generate content that is aligned with the brand. So imagine if you're launching a Diwali campaign, then you can ask it, write a social media post for electronic brand offering 25% discount. The tone must be celebratory and warm. Or companies like Zomato and Swiggy can use such AI tools to create location specific or event specific ad contents, like saving, helping them to save hundreds of hours per month. And next is stable diffusion. Well, stable diffusion is for text to image, right? Text to image model that can generate hyper realistic visuals. That's one thing. So in simple words, I can say in video takes care of storytelling. A writer is going to be handling the copywriting and personalization, and stable diffusion unlocks the visual creativity. So we see a lot of AI generated videos on YouTube nowadays. Is that created by the same InVideo? Well, see, InVideo is no doubt providing us text to video engine. So you can put in the text and it will generate a video. And yes, many YouTube creators or even digital marketers, they use it. But there are other tools also. You have tools like Pictory, you have Runway ML, you have Synthesia. All of these are available. The reason tools like InVideo are popular for YouTube is because they are simple and the speed and consistency is also good, right? So you will see many faceless YouTube channels. So, those, just with narration and stock footage, they are often powered by InVideo, or even there is HeyGen is there, Pictory is there. So all of these tools are available over here. So if you're thinking of experimenting, then you can try InVideo's AI script, right? But there are other tools in the market available as well, creating video using AI. Now, this demonstration is going to be always incomplete because, not incomplete, time consuming, I can say. Go to invideo.com over here. And I say, you have to sign up. I have already signed up. Give me a topic. So I say, create a 30-second promotional video for new eco-friendly water bottle targeting Gen Zs. Then here, you have the options. Recording to avatar, choose, if I want to clone my voice, I can actually give it. I can upload a 30-second audio of my own. So for that, I need to have it. So drag and drop and I can upload my voice. I don't have it, so I'm not doing it. YouTube to avatar, that is also possible. You can upload a 60 seconds of video. You can upload multiple clips where you are actually talking with the camera without subtitles, and it can help you to use that. But for that, you need the paid one. So do I have anything on YouTube? I think long time back I had posted something. Now I don't get that much time, but in case, let me put this small video and paste your YouTube link. Oh, this is short URL. Oh, shorts URL is not supported. So lengthy video, any shorter one, right? Upload consent. And what is this? Say I give permissions to use my author in your. I give InVideo AI permission to use my avatar in this workspace. That also have to, recording. I'm not doing that. I don't have that much time, else I'll just be inside this. I'm crossing it, but you understand, right? And I straight away click on generate my video. Done, done, done. Nothing else. Now it will take 5 to 10 minutes time for the video to be created. I'll just duplicate this tab, opening this, and I go to my media library for my older video. I think I don't know what is this. This is my media. How Gen AI will supercharge your marketing in 2024. That was older created video. When time comes over here or not? Created it some time back. I don't remember, but like,
If you don't like falling behind, but still want to connect with customers, Gen AI is your new best friend. Today's buyers expect experiences tailored just for them. Gen AI delivers. With AI, marketers can personalize campaigns at scale. With AI, marketers can optimize ad copy in seconds. With AI, marketers can unlock deep customer insights that used to take weeks. Picture this: Gen AI instantly drafts high converting emails. Gen AI segments your audience with laser precision. The result? Smarter strategies, better engagement, measurable ROI. Gen AI isn't just a trend, it's your competitive edge. Embrace AI now to future-proof your team and stay ahead in a rapidly changing market. Embrace AI now to stay competitive.
yes, this is how the video is going to look like. In our case, it is getting created. It is asking, you want it of 30 seconds? Yes, you want it for TikTok, FDP, YouTube ads, let's say YouTube basic, pro or ultra. I say basic. Then it will take 1 credit, and then it will keep on doing it. We will come back to it after some time. It will take time, but we saw how the output looks like. So here also they had given the same thing. Maybe the prompt would be different. Yeah, this was the prompt, importance of Gen AI, and this time what I have given is different. That's okay. Similarly, here, when you're talking about the coding aspect, right? So here we have Copilot. So here, Copilot is what we have already used. I think Copilot we didn't use it, but GitHub Copilot we have used. Uizard is there, and Amazon Code Whisperer is also there, right? So obviously you have seen me using in action, so I need not talk mostly about it, right? It is mainly used for debugging. Uh, it can, where we spend 50% of the time in reading, reviewing, and fixing the edited code, this is going to be faster, right? So you have GitHub Copilot, which we already know, so I'll not get into it. Uizard, we are going to have a demonstration of that on the next slide, mostly. So this is mainly a AI-powered tool for UI UX design. This is for the UI UX design. So, see what actually is the main job of UI designer. So for example, if I look into this question, right, what makes Uizard special is that it converts simple handwritten sketch or screenshot into a fully functional digital prototype. So it's like, if I go over here, or why go over here? On the next slide only, Uizard demo is there. If I upload something like this and give it the context, this is called as a wireframe, you get the output. Simple. You get the output. That is what is Uizard, right? So if you're having a mobile app layout on a paper with boxes for buttons, text, and images, the more better you draw that, even with a free hand, and you upload it to Uizard, and within seconds it will convert it into an editable Figma style interface. So this is going to be a huge advantage for the developers who are working with the technical teams, because it is going to bridge the gap between the business ideas and the functional design, right? So client says something, but he gets altogether different UI. So this helps. So there was a startup which used Uizard to translate whiteboard sketches from brainstorming sessions into clickable apps prototypes during the same meeting. Yes. So, idea to design time went from 2 days to just 2 hours. And Amazon Code Whisperer is nothing but like GitHub Copilot, right? So when developers are building the applications, let's say Python, Java, JavaScript, Code Whisperer suggests the context-aware code snippets. So it will show you the things which are tailored for AWS services. That's something which is special about it. It is designed for working in the AWS ecosystem for S3, Lambda, DynamoDB. It can do it. For example, if you are typing a comment, upload a file to AWS, Code Whisperer will automatically complete the secure function with all the exception handling taken care of using the AWS SDK. So it flags vulnerabilities in real time and it provides the code reference tracing, showing where AI suggestion came from. And this is something which is critical for compliance. This is extremely powerful in regulated industries. Then we get into demonstration of Uizard now. So this is already open. Right. What they say is very simple. Go to uizard.io. See, 31% video completed. It takes time. I'll log in. I'm already signed up. So it signed me in. And then I can generate with Auto Designer. I can generate it from a screenshot. So if I say generate it from a screenshot, then upload a screenshot. Or I can upload an image using the phone by scanning the QR code. So I'd like to upload it. I'll just save it. Oh, it went off. In software engineering, what is boilerplate code? A boilerplate is nothing but generating a template. Boilerplate is nothing but generating a template. So, and then you can do the editing in that. For example, let's say if I go to HTML page, right? So if I say boilerplate for HTML. See, whenever you create a web page, the web page will be having a title like here this has ChatGPT. Then there will be some header. And then after that, there will be a body. So if I say boilerplate code for HTML, so your structure becomes ready. What is wrong with ChatGPT? Sleeping or what today? So yes. So this is called as a boilerplate code. So anytime you are writing a code, Raj, this is what you have to compulsorily type. And then after that, the main thing goes in the body part. So except this, the things written above and below are something which you have to always type or copy paste. So boilerplate is going to get this thing ready and you can start typing the main content. So that's it, right? Yes. So I can upload from a screenshot, but why is it not allowing me? I tried to save the screenshot. I'll do one thing. Save image as wireframe.png. I saved it. Now not a problem. I uploaded that wireframe image. This one. I uploaded. If you want, I can share that with you as well. You want it for mobile? Yeah, it looks good for mobile, not a tablet or this. So I say, okay, import. And then I can put in and command over here. Are you ready to move into this? Yes. How can I help you out with? Modify selection, generate screens, generate images, generate screens. What's the choice of your input? Upload a screenshot for a mobile. Upload an image. Yes, it's a wireframe. Vision captured. You have to explore much more about it, but this is quickly to help you out how these things are getting created. Done. Put it on your canvas. Place. I'm happy. it will be on my canvas. You want to do anything, you can do over here in this. I can ask it to style it to make it rounded. I can ask it to style it to make circular, you see. So here this text, you want to suggest the color choice. So everything is going to be easy over here when it comes to do that. And then you can also preview it. In fact, you can also go over here and I can generate completely with AI as well, just like I showed you. Whatever you want to do, you have to just put in your inputs and Uizard will be helping you to create a nice website. In fact, if you look into what are we instructed, that was impromptu, but if you see, if you are instructed to go to generate screen prompt, and the prompt was an e-commerce product showcase page. So if I say, let's say this time for a desktop, an e-commerce product showcase page, high precision or creative exploration. I say creative exploration. And then later on, I can export it. It will be available with the HTML code. See here, you have the option to export as well. So that will be coming down with the code as well. And 4 of them are here. I'll try to click on that. This looks good. And if you want, I can click on download. I can export it as a PNG, JPG, save it as an image. And of course, if you go to the Pro, you will be getting it into the HTML file as well for download. Here it is just showing you, you can do this, you can do that, but it is not allowing you to download. So yes, these are the capabilities of the Uizard. In video, yeah, in video is ready.
I spent $847 on bottled water last year while posting about climate change. Yeah, the math wasn't mathing. So I switched to this eco-friendly water bottle that actually matches my values and my vibe. It's made from recycled materials, saves me over 60 kilograms of CO2 annually, and honestly, it looks way better in my photos than those plastic bottles ever did. Plus, I'm saving hundreds of dollars a year that I can spend on literally anything else. Stop funding your own climate anxiety. Get yours now.
Next. The next we get into Otter.ai. See, Otter.ai and Zenbird. Okay. So what are these? These are mainly the tools which can help you to convert speech to text. I can integrate it in my Zoom, I can integrate it in one of the Google Meet, and it will be hearing to whatever I say. It will be saving the captions, or I can say whatever I speak in the form of a text file, and then allowing me later on to summarize to get the minutes of the meeting or any action points, anything I missed out. So it's like entire meeting transcripts are ready. So if you talk about Sendbird, it is again an AI-powered communication platform, and it is built by the companies to build intelligent chat and messaging system inside their applications or websites. So it's if you look at Zomato, Paytm, or Byju's, if you think of their apps, when you chat with their support teams, those smooth chat interfaces are powered by tools like Sendbird. So they basically provide the underlying framework for the live chat, push notifications, and AI-driven messaging, making the customer interactions instant and contextual. So that's an advantage that you get over here. So, if you are a fintech company, you can use the Sendword to provide instant loan status updates or even balance the inquiries directly within their mobile application. Or, the AI can also detect the customer sentiment. If the user is frustrated, it will automatically escalate the case to the human agent. So essentially, Sendbird comes with real-time communication with AI intelligence, thereby allowing the brands to be responsive 24/7 without overloading their teams. And Otter.ai is, as I told you, that your conversations can be turned into text and then into actionable insights. So let me show you Otter.ai transcribing audio calls. Imagine you are a dentist working on a chair, talking to your patient. You want everything to be noted down, any prescriptions that you're suggesting to the patient, or any important notes or medicines based on the current situation. But you cannot write it because you're actually performing action. So whatever you speak is converted to text, and later on, you can analyze that. So if I go to Otter.ai, you have to sign up again. And these are my earlier recordings. So if I start with the new one, let's say I go to Google Meet. I'm creating a Google Meet invite, create a new one, start an instant meeting, copying it and sharing the live meeting link here. And I say record. Now it will ask me to admit. Your note taker is working on taking it, but why is it not working? It actually gets added. See here. Admit. Darshan's note taker. And now it has started completely recording whatever I have asked it for. So if I say I'm sharing a Chrome tab, let's say over here. So now whatever I speak, it will be recording. So the key action points will also be recorded. So the MacBook, Apple's icon innovation. This will also be recorded, right? It's getting recorded. The MacBook is Apple Inc.'s line of the laptop computers that has a symbol of sleek design, powerful performance, and technological innovation. Since its introduction in 2006, the MacBook has evolved through numerous generations, shaping the modern concept of the portable computing. Rohan says, good morning, everyone. Let's start with today's meeting. I hope you have had a chance to review the agenda I sent earlier. Sham says, yes, I went through it. Looks like we'll be focusing on a project update and the next steps for the week. Danny, same here. I have made a few notes on my progress that I'll share in a moment. Rohan says, perfect. Let's begin with the updates. Rohan says to Sham, you can start. Sham says, sure. This week I completed an initial research and compiled the data we needed. The report is almost drafted. I need some feedback from Danny on the design layout before I finalize. Danny says, sounds good, Sham. I can review it today afternoon and send my comments. On my side, I have been working on presentation slides. Most of them are ready. I just need the final figures from your report to complete them. Rohan says, great teamwork, both of you. Once that's done, we can review everything together before sending it to the management. Regarding my part, I have been coordinating with the client for feedback on the last week's submission. They were happy overall, but requested a few adjustments, mainly around the timeline. Sham says, understood. Do we need any changes to our internal deadlines because of that? Rohan says, possibly. They have asked an earlier delivery of the demo version, so we might need to move it up by 2 days. Can everyone manage it? Danny says, I think it's doable. I need to adjust some design elements, but it shouldn't be any big issue. Sham says, same here. I can reorganize my task to fit the new timeline. Rohan says, excellent. I'll update the schedule accordingly and send out the revised plan after the meeting. Before we wrap up, are there any concerns or issues we need to discuss? Sham says, none from my side. Danny says, all good here. Rohan says, great. Thanks, everyone. Let's stay on the track and aim to have the next review meeting by Thursday. Have a productive week. Sham says, thanks, Rohan. See you then. Danny says, bye, everyone. You can see everything is recorded. I go to this, stop presenting, and I end this meeting. And you can see over here, this is over. Live slide update every 10 seconds. And I can now stop it. Now that we are here, I open this. It is processing the audio. Everything is there. Meanwhile, can I go into Otter chat? No, Otter chat won't help here. Done. First, you have the summary. Action items automatically populated. You can see the outline. Dr. Ingley discusses about MacBooks innovation and projects. Action items are this. Rohan to update on this and this and this. Then transcript is over here. So if I say, where is my chat mode? Here, not comment. It will be recording. It was there inside every meeting. I don't know. Can you summarize the key takeaways from my last meeting? I think yes, this has. And you see over here what all happened. So ideally, it will be recording a live meeting. This is just a quick insight on how Otter.ai can help. And then I can ask follow-up question. Any key concerns? There were no key concerns. Was the discussion fruitful? Yes, the last meeting was fruitful. The team completed this. Is Danny lazy? There is no evidence or mention of a meeting that suggests Danny is lazy. In fact, the meeting summary indicated that Danny was actively working on the presentation slides, agreeing to adjust his work to meet the new timeline. Isn't that awesome? Of course, yes. And that's Otter.ai. Right. Then for data analytics, you have Julius.ai. You already know this. You don't know Julius, but you know what I mean. So I want to click on try Julius free, as you see over here. And then I can upload anything. So let's say I'm connecting it to upload a file, giving it the Titanic data set. Any tools, if you want, I can give it scientific, etc., etc. As of now, I'm not giving it, and I'm asking it to generate insights about this data set after explaining what is the data set about. So this is nothing but ChatGPT's code interpreter through the tool Julius. What is the data set about? So it's about Titanic passengers who did this. Quick peek into the data, summary of the data, final insights. You see that over here, right? Age distribution, key insights at a glance. Finish. You can ask n number of questions over there. There is absolute nothing to be extended on that. Now the next one, Miro and Notion. It's been a long time I have not used them. So content generated by InVideo, like eco-friendly bottle we just saw, must be inspired from existing videos and visuals across the web. Is it safe to use it from the copyright perspective? See, the question that you are asking is already a solved question. See, InVideo is not scraping or copying the content from the internet, else anyone can put a copyright infringement case on it. It is relying on two safe sources. Number one is licensed stock libraries. So NVIDIA has already partnered with licensed stock libraries like you have Shutterstock, iStock, Storyblocks. So you'll see that with a commercial license. And also it has AI template generation. So whenever you are using AI text to video feature, it will turn that script into a video. So it does not download or reuse the copyrighted image. It is directly generating it or pulling the internal library. So you can use your own media or upload the content and you have the rights. You are the owner. So the video that is generated is safe, but do not export or redistribute someone else copyrighted footage that you imported illegally. Also, you can follow the platform's usage policies. So over there, they have written it more clearly. See, if you upload your own background music or the clips that were downloaded from YouTube or any other unlicensed sources, then that can trigger copyright issues. So the safety is not lying in the AI model. The safety lies in that case in your choice of assets. So there is no risk from the AI model about the copyright infringement or anything else. Clear, Shanu? Great. Perfect. Then the next one, what we see on the screen. Generative AI have transformed the product research and development by enabling rapid prototyping, data-driven insights, and accelerated iteration. So, see, whenever our team are brainstorming a new product or an idea, the most time-consuming part of that process is the ideation or creating wireframes or prototypes. So therefore, I say the initial stage of the product research and the development, they are incredibly iterative. You can brainstorm the sketches, test, fails, redesign, and so on. So GenAI can also help in accelerating this entire cycle. If we talk about uh, Miro is collaborative AI for ideation and rapid prototyping. So it is no longer just a digital whiteboard. It is now an AI-powered co-creator. So Miro Assistant can summarize brainstorming notes. It can generate flowcharts and it can even create sprint plans automatically. It will also convert the messy brainstorming sessions into structured frameworks. Maybe you have your user journey maps or product workflows that can help, right? So if your R&D team discusses a smart bottle that tracks water intake, Miro AI can instantly map out the user flow from user onboarding to sensor data collection to the mobile app integration. That is something that earlier took the multiple whiteboard sessions, but today it's fast. Similarly, Notion, right? It's AI for knowledge management and documentation. So it will go beyond note taking. It will help in product documentation, research synthesis, and even the team alignment. So it goes far beyond the note taking, as I told you. And in your case, let's say your R&D team has collaborated uh, and collected 50 pages of competitor analysis and survey feedback. Then this Notion AI can summarize the patterns, generate the product requirement documents, and can even suggest the feature prioritization based on the frequency of the keywords. Coming down, using Miro. Coming over here. This is just like Zapier. Not same like Zapier, but something which needs a little bit more efforts. So I'll follow it step by step and only do the limited thing which they have asked. So we'll go to Miro.com. We'll be choosing the product template and create your account. Go to Miro Assist and describe the product or resources. Then I'll be getting into creating a map based on the resources. Then enter generated plans in the respective fields, convert map into presentations, planning into presentation, and download or share the mappings. So this is the product description. where we say, create a product roadmap for mobile phone company that involves coordinating across multiple teams, such as the product design, development, marketing, and the sales to bring an idea to market. So we go to Miro, we sign up, and we go for product roadmap basic. So I'm yet to log in. Oh, so this was one of the initial flowchart which I created. Start to process to some other process. Decision, if yes, do this. If no, do this, and so on. So there are a lot of other templates available. So I'm going for what are the product roadmap or roadmap basic. Basic one. Let's say I'm using this basic one. Let me preview it first. Use the pre-fill template. In the Miro Assist, they're asking us to create a roadmap for phone company. So let's say, and where is that Miro Assist? Maybe I go over here. A new one would be created. It is using the same style as the template which we imported, and see the huge lengthy document is being created. Once you have it, I can save it or I can lock it anywhere. So what are they saying is once you have this, Miro Assist has changed. That's okay. I'll get back to you on this. There has been some changes. I think this is the older one. A lot of changes. I'll get back to you on this. I can link this to a board. I'll come back to you on this. I think there is some problem in this. Gemini, I don't think so. I need to explain. This slide is self-explanatory. Coming on to demonstration of Gemini. Marketing strategy using Gemini. So see, there is nothing over here. It's like just like how we have been using the ChatGPT, we have been asked to use Gemini. This is the prompt. You go to Gemini, paste it, done. I wanted to act as a chief sales and marketing officer for cutting edge company launching a new product called as App X on our this. And then you have this. That's it. There is nothing in this demo. It's just ChatGPT like Gemini. Descript is going to be new. So Descript can write, record, or transcribe, edit, and share your videos. Let me take you to Descript. That's also good. Huh? Let me show you some of my earlier ones. Okay, let it be there. Let's keep it audio. I think this. Okay. So let's talk about Descript. So what is Descript mainly for? Write, record, transcribe, edit, collaborate, and share your videos and podcast. So if I go on to the second last tool, very simple and straightforward. There's nothing great about this. Go to web.descript.com. We are already over here. I can edit a video. I can create an avatar, edit a podcast, create a social clip, and all these things. Okay, what are they asking us to do? They are asking us to create a new video project, and from the projects on the left hand side, create an video project. So projects, I'll delete the older one. Yeah, I think this is my older one.
Share a relatable message. Think about your target audience and what they are passionate about. Capture emotions, whether it's laughter, awe, or inspiration. Use high quality.
One more was there. I don't know what I did over here earlier.
And first time. Hi guys, my name is Dr. Darshan. I think we are meeting for the very first.
Projects, delete. creating a new project, video project. Then after that, in the video project, media icon, choose any video. So create with AI speaker, upload from mobile, record or import from Zoom. Let's say create with AI avatar. Alex,
Life is like a camera. Life is like a camera.
I'll
Just
take this.
focus on what
Avatar done. Whom do you want to speak? Avatar. I can even upload my own avatar, by the way. And then after that, I can write or paste the script you want the one to speak. So I say, so that was a question asked by Shanu and I just randomly copy pasted it. And I'll be getting some output. Print purely in the form of text, no tables. There it goes.
AI content is inspired by and statistically shaped by what already exists online, but it doesn't necessarily reuse or directly copy that content. 2, why copyright becomes complicated. Here it gets tricky. If an AI tool was trained on copyrighted material without permission, and your output happens to be very similar to a copyrighted work, it could raise legal questions. Different countries are still debating whether this kind of AI training counts as fair use or text and data mining, which is allowed in some laws. Courts in the US, UK, and EU are all handling such cases right now, so the rules are still evolving. For now, the main concern is, does your
Generate as a last step, this process temporarily disables editing and this for any changes.
learn from the patterns? If it's transformative and not a direct copy, it's generally considered safer, but not guaranteed to be completely risk-free. 3, who owns AI-generated content? Most countries, including India and the US, currently require human authorship for something to be protected by copyright. That means if something is 100% machine-generated with no meaningful human input, you technically
Create with AI speaker, let's say Alexa. Again, this is going to take some time. Why don't I see it? 16 credits remaining and 60 minutes remaining. That's fine. Looks good. Generate the video. Meanwhile, this is happening. Let me take to the last one, which is Claude. So what is Claude? Claude is again like ChatGPT and Perplexity. Nothing new to explain. 4.5 came. That's nice. Yes, this is Claude, right? But Claude is good. There are a lot of nice MCP servers over here, but that's okay. We'll take it later. But yes, this is Claude. Just go to claude.com and get it signed up. Owned by Anthropic. Okay. So in order to get a very good story, what am I doing is I go to ChatGPT and I say, you are a storyteller with 20 years of experience working in the Indian market. You are known for your expert storytelling. Your stories carry a natural tone with varied sentiments depending upon the context of the story. Your story has hooks at regular intervals, making a user think what is likely to happen next. You are known for drafting all of this step by step in a logical and intuitive order. Problem scenario. Now let me share with you the problem scenario and the objective. Your job is to just understand it for now. And when done, just reply me with a yes. And now I'm going to put it in triple quotes. It's actually generating a story, but I don't want that. Now let me share with you the problem statement and the scenario in which I am mainly interested. And it said yes. Once it is done, I said, send me a yes. It said yes. Now I say, this story is going to be like a real time small ebook which I have to write. And I'm going to tell you the steps upon which I want the story to be written. Just understand the steps. And then I'll tell you what next has to be done. Below are the steps. I pasted it and I said, enter. So what I did, I tell it to just understand this. What is the context? It said yes. Now I say, now I'm going to give you the content which I want to be generated at every step, and your job will be to ensure that you are writing a nice connected story in a right logical order, which looks very interesting for my readers to read. Step 1, I say, choose a theme of, let's say, Kashmir, and genre of horror for storytelling adventure, having, yeah, for storytelling adventure. That's okay. Now, this is going to be your answer. The Whispers of the Valley. The story will be unfolding into the hauntingly beautiful yet mysterious cursed valleys of the Kashmir, a place where serenity hides something unsettling beneath the mist. Genre is horror, psychological, and supernatural. Folkloric theme. When the land remembers what people choose to forget. Hmm. The story of the Kashmiri folk for myths of this echoing shrines and the snow buried secrets that, and then the atmosphere, right? Step 2, I say introduce the main characters, and let's say, I'll say, what was that movie? Bhedia. It just came to my mind. And Bhedia cast. And Varun Dhawan, Amar Kaushik, and let's say this. So we're going to take this, right? So we'll take Varun Dhawan. Then we will take Parikshit Khurana. And we will take, introduce the main characters named this, create the character description there. So create a character description, right? So I'll not say create a character description. Give a unique character description to each of them, including their names, personalities, and backgrounds. And now, Varun Dhawan, the skeptic historian, he never believed in ghosts, only in the history that people twist into legends. He's a 35-year archaeologist and travel documentarist. Aparikshit Khurana is the believer and the storyteller. You see over here, do in a structured way, ChatGPT will go to any leaps and bounds for you. Palin, he's the outsider and the protector. Okay. Then I said, begin the story, set the scene, and introduce the starting point. Continuing, beginning the story. The story opens on cold November morning in Srinagar, where the city is half asleep beneath a fragile wheel of mist. The chinars burn red against the sky. Scene 1 arrival. Varun steps out of rusted gypsy near the Nishant Bagh. See the context. Cluttering weather beat, leather journal, and then this. So the journey ends abruptly. The snow remembers their names, never travels beyond the Guris after the first. And this. Then the warning, and then the first omen. The participant input. Post questions or describe actions about their chosen characters. Now, we have already done that. Then utilize ChatGPT to provide narrative responses based on this. Expand your story. Prompt to make the decisions to pose the choices. Use ChatGPT response to guide and refine your inputs based on clarity. We have already done that. Now I say participant input, and this way the reader begins interacting. I can just say yes, flow with it. Now we move to the interactive phase. By late evening, these guys do this. Now the reader's interactions. You, the participant, must decide what happens next. Varun, rational curiosity, he decides to follow up, or a Parikshit who suggests protective fire, or Palin's choice, which is tactical survival. So let's go with Varun, right? Varun's choice. So we want more and more curiosity in the story, and this goes ahead with Varun's choice. And you have to read it up. Without reading, you won't be able to get good answers, right? Now, step 6, or I want to continue. Now, I can continue adding one more thing. Now, decision making, branching parts, and trio. When we decide to investigate this, flee back to this, or seek local help at nearest settlement. So I say that let the story have multiple, let these characters have multiple options, and they think on the multiple options, and they decide upon the best option before going ahead. Having a very rational thinking and practical approach without being aware of any horror. I'll just skip it and let it flow quickly. It will come, it will come. It takes some time, right? The camp at Hapatkesh edge. The night is still on, and this. And then we have 3 routes. Let's be sensible before we commit. Option 1. It's like the tree of thoughts, right? Reasoning, advantages, risks. Option 2 and option 3. Decision after long silence, Varun summarizes like a field commander. Option 2 is good, and so on. Now you do the remaining thing. I think that is enough to give you the right context. I can even post it on LinkedIn now. That's interesting. Okay, then next one. Again, virtual management consultant. Develop a series of prompts to enable ChatGPT to act as a virtual project management consultant, providing advice on project planning, risk management, and this. Objective is to design and refine prompts. Refer my prompt engineering notebook, not notebook, the text file. To develop proficiency in prompt engineering and the steps. Choose a specific domain of project management. Research common project tasks about the project planning, risk management. Identify the key scenarios, outline the type of queries, initial prompt design, testing environments, do the iterative prompting, evaluate criteria, feedback collection, final optimization, documentation and present future suggestions. Now I'll be giving you a doc file, and your job is to understand the doc file and tell me what is the right option that you would like to go ahead step by step to solve that business problem. And then I go and attach my doc file, which is nothing but the virtual project management. It went to my drive because I had given it the drive access and document generation, which is completely wrong. I have attached it again for reference. Now let's proceed to the solution step by step. Whenever I mention the step number, your job is to generate the detailed, professional content on that step as per the problem statement. And then I say step 1. And then you can see over here. Now it will just go on and on. Step 2 will be generating the step 2. You can follow any approach. This was just one of it. This converts your research from step 1 into practical interaction blueprints. You have been given scenario of project planning, risk management, team collaboration. You can choose any one of this and go ahead with it. End of the story from my side. Let's have a quick recap of the thing. See. One moment, it's just the pen tool is connecting. Yeah. So far, what have we studied? See, we started our journey with Python. Then, after that, we looked into advanced Python, where we looked into NumPy, Pandas, Matplotlib, and Seaborn. Then the next topic that we went into was machine learning. Then the next topic that we went into was deep learning. And then last time we had got into essentials of Gen AI. Now this course is all about deep dive into Gen AI. And the topics are exactly what I discussed with you earlier. So let's take it ahead. This is just a standard deck. So we understood from our earlier understanding that AI is all about hardware and software combined. We also understood machine learning is all about working with structured data. So you have a CSV file, Excel file, etc. ML is for that. And here we need to do manual feature engineering. And deep learning, we also understood it's all about using unstructured data. And here we have automatic feature engineering. Then, by the way, in your course, I didn't see agentic AI. And that is one thing which I didn't see in your course. But anyways, not a problem. Then we get into generative AI, and this is all about generating content, right? So when you want to generate text, audio, images, video, code, simulation, we talk about generative AI. And so, basically here you have large language models, which are nothing but we can call it as supercharged brain. The next thing which we don't have, but it comes as agentic AI. So what is agentic AI? Well, these are where agents can take actions with tools and LLM. So basically, if I am asking the ChatGPT that go and book the flight tickets for me, it can't do that. If I ask it, okay, then this is the large language model. Now the thing is, this is supercharged brain. It can think to any extent, but it cannot perform any action. So if you say that, hey, can you book a flight ticket for me by going to make my trip? It says it can't. It can search for you the right flight ticket, but it cannot book it for you. It can search, but it cannot book it for you. In the same way, if you ask it that, hey, can you generate the QR code for booking this flight payment? It says, no, I cannot do that. If you ask the large language model that, hey, can you do my Ola booking? It says it cannot do that. If you say that, okay, you have booked my flight ticket and everything, now please mail me the itinerary on my mailbox. It cannot do that. But with agents, you are incorporating the LLM with hands. All of these can be considered as tools. So now the LLM can use these tools to actually check or actually take actions in real time. And that is exactly what is agentic AI. We are not having it in the syllabus, at least when I looked at it, I see that. But yes, this is what is agentic AI. I will check into this once again if agentic AI is there, but for now, at least at a higher level, I could not see that. Okay. So now, coming on to this. Agentic AI is another model we need to understand. Uh, my company has taken initiative from Google Cloud to take certifications in ADK. That's good. That's good. Yes. Okay. Now, let us get started with this. Quickly tell me, when you think about generative AI, which popular tool comes to your mind first? As expected. ChatGPT, 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 Copilot, Copilot, ChatGPT. It all started from ChatGPT only. Right. So these all tools, that you just named, Sonnet, Claude. So whatever are these tools which you just named, these are just the flag bearers of the generative AI. Perplexity, right? Each of this is representing kind of a creative or a productive capability, from generating conversations to generating code, text, or even images. Let's dive a little deeper into this. Now, if you see, the first one that we have in over here are the consumer chatbots. ChatGPT by OpenAI. You have Gemini by Google. Both are paid. Second comes text to image, where you again have DALL-E by OpenAI. It is paid. You have Midjourney by Midjourney Inc., which is also paid. Third, here you have GitHub Copilot by OpenAI and GitHub in collaboration. It is limited free 2000 completions, but mostly it is paid. And Replit is also paid. Then on the enterprise LLMs, you have Pathway Language Model, which is an enterprise language model by Google. This is also paid. And Cohere is also paid. It is an independent research company. So, just to talk a little bit more about it. So, as I discussed, ChatGPT and Gemini, they are great examples because they can draft emails, summarize documents, write poems, or even they can brainstorm marketing ideas. If you talk about DALL-E and Midjourney, these mainly take a text prompt and generate an image or artistic image. For instance, if you say a robot serving coffee in a Parisian cafe, it will generate a very nice image. So digital and marketing teams can use such tools for ad mockups. GitHub Copilot and Replit, these help the developers to write and debug code. So Copilot, which is powered by OpenAI Codex, it suggests the code completions or the code snippets or functions inside the IDE. And Replit Ghostwriter does the same but in browser-based environments. In enterprise software development, Copilot can suggest Python or C++ logic, helping the developers focus on logic rather than syntax. Then coming on to the enterprise LLMs. So these are the ones which are designed for scalability and domain-specific use cases. So Palm 2 from the Google powers the Gemini, and several Google Workspace features like Cohere offers customizable models for enterprises to integrate into their ecosystem. Then after that, see, when we hear about generative AI, most of us instantly think of the tools like ChatGPT or Midjourney. But what about the large companies, large enterprises? How do companies like Morgan Stanley or Adobe actually use generative AI in their daily operations? Yes, so let us get into this. So here we talk about the very first one is Khanmigo. Khanmigo is a chatbot by Khan Academy, and you ask it any question, it will not answer it, but it will ask you to solve it with me. Like for example, tutor me by Khanmigo. If I say solve 7x minus 7 is equal to 7. 7x minus 7 is equal to 7. And if you see, it says, let's walk through it together. Can you tell me what would be the first step to get x all by itself? Think what you could do to get rid of that minus 7. I say, I'm in an urgency to submit by assignment in next 2 minutes and I just need the solution. I will sit and solve with you later. I really hear you. Deadlines are tough, but I can't give you the answers without you trying first. That's how I help you learn even under pressure. So what does that give that when you add 7 on both the sides? So I say it gives me 7x is equal to 14. Then the next one is 7x is equal to 14. Now what would you do on both the sides? I say multiply by 7. Ideally I should divide, but I say multiply by 7. I'm giving wrong input. Almost there, but let's pause and think. What operation undoes multiply by 7? I say division. Yes, that's perfect. So what do you get over here? So yes, you got it. Even under pressure, you were able to learn. But I missed the deadline, and now it is of no use. Right? So what is Khanmigo? We understand it is not just to give you the answers, but it will guide you on this. Imagine, these things can be easily deployed in schools. right? Because students can use ChatGPT, they can ask questions, offer hints, get personalized feedback, and help the students learn how to think and not just what to think. So if a student says, I don't get fraction, it will teach it. The next one is by Morgan Stanley, information retrieval, which organizes vast amount of knowledge base, market research, analysis strategy. So Morgan Stanley uses generative AI to organize its mass internal knowledge. So basically, they have thousands of research reports, analyst notes, and strategy documents. The AI system helps the financial advisors instantly retrieve the insights. For example, summarize the recent trends in the renewable energy stocks. And it pulls the information from the approved internal data and not just the web data. Right? So a financial advisor can now literally ask, what is our stance on Tesla for long-term investors? And the model instantly provides summarized company insights, market analysis, and recommendations. And all of this is going to happen in a secure environment. Then the next one is Adobe Firefly, right? So this is mainly an AI image and video creation, text to video. So when I give it dog in a sweater with primary colors, big smile, it should be able to do that. So if I come over and I search for Adobe Firefly. So let's say I click on a dog in a red sweater with a big smile, text to image. Try now? No, I don't want to try it. What I did, I clicked on generate video by mistake. Oh, I pasted the link by chance. For the first time, I have seen a photo like this. Manu might feel offended now. What kind of photos is they generating, Manu? The nation wants to know. It every time generates very good photo, but see, I will today this was bad. See, this is really good, but the one which it gave earlier, that was definitely not good for sure. Here, beautiful photo. Every time it generates very good. But only this time, I saw it a very bad photo. But I think, see, overall, it's good. Very good. And look at the background and all. It's really awesome. Except this. God knows what happened over here. So over here, right? So Adobe Firefly is again a generative AI suite for image and video creation. And using just simple text prompts, as we saw, right, it can generate high quality visuals that integrate seamlessly into the Photoshop and the Premiere Pro. And what is powerful over here is Firefly is actually trained on licensed and copyright safe datasets, making it enterprise friendly for the commercial use. Right. So a marketing team at PepsiCo can actually generate 10 ad variations within minutes. Each of these will be tailored to their region and language. So overall, we understood these 3 pointers. Now, let's talk about two more products over here. The first one is the Bloomberg GPT. See, it is a 500 billion parameter large language model. You can understand we have trained neural network with just 1 or 2 lakh parameters. This is 50 billion parameter, not 550 billion. And they trained it not on the entire web data like ChatGPT, but only and only on finance data, right? So it can do question answering, sentiment analysis, everything on the finance data. So you can ask it, what is the market sentiment on Tesla this quarter? Or you can, in sentiment analysis, it will help the analyst to gauge the tone from the earnings reports from the CEO statement. And in the information summarization, it can condense lengthy financial documents into digestible insights. Yes. And then the next one is the Salesforce Einstein GPT. Now, this is an really awesome product, I would say. I think if I go to my profile, I should be able to find it, provided I find something. Yeah, see, this was his Trailblazer, but no, I wanted to get into one more. This I went twice at Salesforce. Yes, this one. This is their mascot for Einstein GPT, right? So I'll tell you what it is. But it is at the Salesforce Hyderabad office. And these are another two mascots for Trailblazer for the CRM. See how big it is, right? I am myself 6 feet 3 inches tall. It is even taller than me. If you look into the Einstein GPT, see Salesforce launched Einstein GPT to integrate generative AI directly into the CRM platform, where all the customer sales and the marketing interactions already live. This means that the AI is available inside the Salesforce itself, composing emails, creating market copies, summarizing customer cases, and even generating code snippets for automation. So this can help in a lot of tasks, automating sales, auto-generating personalized email content, and this all is happening right in the Salesforce platform, right? This makes it the world's first powerful, intelligent, generative CRM, making every employee more productive and every customer's experience better. So precisely the way it can automate the sales is it can schedule meetings, summarize calls, and draft personalized follow-up emails right in their CRM. It can also generate personalized content for marketing. It can support message variations for different audiences, all from their CRM data. So imagine a sales manager who is opening Salesforce and asking, draft a follow-up email for the clients in the healthcare sector about our new product launch. And within seconds, Einstein GPT will auto-generate the context-aware, personalized email content, saving hours of manual effort, right? So this gives us an idea, right, where Gen AI is heading from creative tools to deeply embedded enterprise systems. So from this, we kind of understand that when I have to define Gen AI, it describes algorithms such as ChatGPT that can be used to create new content. And that new content can be text, images, videos, audio, code, and simulation. So you have ChatGPT, it's paid. DALL-E, it's paid. You have Gemini, it's paid. GitHub Copilot, it's paid. Midjourney is paid. Replit is paid. Palm 2 by Google is paid. Stability AI, it is for text to image by Stable Diffusion, and this is free. Hugging Face. Hugging Face holds or hosts around more than 20 lakh LLMs. More than 20 lakh large language models are available on the Hugging Face website. We saw this in our outline as well. I had written it down. So this all models are open source, so they are free to use. You don't need any API key. DALL-E is by Databricks, and DALL-E is also Falcon is by Abu Dhabi, made in UAE, and it's also free. Now, if you are considering the concept of retrieval augmented generation, let's say where you have a PDF and there is a large language model which sits in between, and this is you ask a question, LLM uses the PDF ka data and gets you the answer. But LLM doesn't use the PDF ka data as it is. It stores this PDF data into a vector form. Word embedding we understood, right? So this entire PDF, which is in the natural language, is converted to vectors. And then after that, it is stored into a database, which is specialized for storing vectors, which we call as vector DB. And LangChain is a vector database. Pinecone is a vector database. Oh, so sorry, not LangChain is a vector database. The Chroma is a vector database. Pinecone is a vector database. And LangChain, you remember I said you have large language model and we want it to connect it to various tools, right? The large language model has to be connected to various tools. So LangChain is the framework for creating these agents, right? So it makes the things easy. So basically you can have n number of tools and you can easily just replace the LLM. You don't want to go for OpenAI, you go for Hugging Face. You want to go for Cohere, you want to go for Anthropic, everything. So you can also incorporate a Cohere LLM over there. So that is what is the biggest advantage that you are getting because of generative al replaced a generative AI. Just excuse for that. All right. Now, see, now it is the time to answer the question. If you were to build a generative AI product, your own AI product, say an assistant, what layers or tools do we all need? Right? So let us try to demystify that. Number one, look at the tech stack over here. You have the closed LLMs. Closed LLMs are like this OpenAI. Basically, closed LLMs are paid LLMs. You have open LLM. So you can use open source LLM as well, which are going to be free, like DALL-E. Another LLM that you can use is text to image LLM, right? These are paid as well as free. At least Midjourney is paid. You also have music LLMs by Meta called as Meta Music Gen AI. These are also paid. So we need the large language models, and that is nothing but the first part of it. The second is you need the database to store vectors, and this applies in the concept of RAG. Pinecone is one of it. Chroma is another. Chroma comes by default in LangChain. Therefore, in the earlier slide, they were written together. VV8 is there, Qdrant is there, Redis is there, and many, many more are there. Then we need the framework. So framework is important for orchestration, or I can say to connect LLM with tools and prompt. LangChain is, as of today, the most popular in the industry. But you have Llama Index and Anarchy as well. And when it comes to deployment, you have Hugging Face, you can go for Docker, you have Azure OpenAI, and you have the Google's Vertex AI. All of these things are available when it comes to deployment. Just to get into details of it, which all closed LLMs are there? All of these are paid. ChatGPT, Palm, Llama, latest versions of Llama, Cohere, and Claude 3. Now to Claude 4.5 came. In the open source LLM, Hugging Face always free, DALL-E free, and Abu Dhabi's Falcon 180V is free, 180 billion parameters. In the image model, Midjourney is paid, DALL-E is paid, Runway ML is paid, and Stable Diffusion is free. For music, both of these are paid. We have the Meta Music Gen AI and the Google's Music LM. You want to research a little bit more about it? See, these are the links. This is for Palm, for Llama, for Cohere, for Anthropic. For Hugging Face, DALL-E, Stable Diffusion, and the Open Llama. These are for the music long language models. So this is for music and this is for image. For vector databases, you can refer this link, and for the frameworks, you can refer this link. As simple as that. Now, let me ask you a question where I expect your answer. When you look at ChatGPT or Midjourney, does it feel like generative AI suddenly appeared out of nowhere? No. So if I ask you to kind of tell me how many years old is this technology? How many years old is this technology then? This evolution went on for how many years as per you? Today we are at ChatGPT, which started with basics, even a basic computer. So this is how many years old as per you? Just a guess. 25 years old means it started from the year 2000. Anyone else? More than 40 years old. Okay. Sanket also says 40 after Rahul. Okay. Pritam says 60 years old. Ramani says 1960 to 1970. Started with the Turing machine. Shanu also says 70 years old. What if I say this is 400-year-old? Look into this timeline. It all started from the year 1642 and this is till 2018. Yes. This is a very common impression, but the truth is Gen AI is the result of 400 years of evolution, friends. If you look into 1642, where the first mechanical calculator came, Charles Babbage, he's called as the father of computing. He built the first mechanical calculator where a machine could perform arithmetic automatically. That was the seed idea. Machines could follow logic and rules, not just human instructions. Then in 1842, we got our world's first programmer. And by the way, it was not he, it was she. She was Ada Lovelace. Right. So she wrote the world's first ever algorithm for Babbage Analytical Engine. She was the first to realize that machines can go beyond calculation. They could create patterns, music, and art if programmed correctly. That is why I told you she was the first person to imagine creativity through computation. Then in 1943, our journey of deep learning started. The McCulloch and the Pitts model, where a perceptron model was developed, where we started our journey of deep learning, right? Where in 1950, then Alan Turing, as one of you said, he introduced the Turing test, which asked a fundamental question: can machines think? ChatGPT also has to bypass this test, not bypass, has to undergo this test. And that is what we are still exploring with ChatGPT and similar systems today. Then in 1955 to 1965, in 1955, artificial intelligence. So people started calling this domain. The term AI was coined in 1955. Okay, artificial intelligence. And then came Eliza. Eliza was created. It is the first chatbot that simulated human conversation by pattern matching text. In fact, in many ways, you can actually say that Eliza was the great grandmother of ChatGPT. Yes. Eliza was the great grandmother of ChatGPT. Then in 1980s, expert systems came into picture, right? So they were not learning from data yet, but they were automating the reasoning. So they basically captured the decision logic of the human expert. Then in 1997, miracle happened. Gary Kasparov, world's chess champion, he was beaten by IBM's Deep Blue. So the machine could win over him. That was symbolic, right? Machine has outperformed a human in strategy. Then in 2000, iRobot Roomba, just like today's MI vacuum cleaner robot, right? So Roomba was launched, autonomous vacuum cleaner that avoids obstacles. Then in 2009, what Tesla has built today, Google built in 2009 the first self-driving car to handle urban conditions. Then in 2011, IBM launched its Watson, right? And it also won the game show of Jeopardy, which was considered to be more difficult than chess. And then our 2011 to 14, Hey Siri, Google Now, Cortana, etc., things came into picture.
I'm Siri, but I offer no resistance to helpful assistance.
My Siri started speaking. Then, after that, in 2014, Ian Goodfellow launches GANs. Did I take you through the website this person does not exist earlier? I think I should have. Did I take you through the website this person does not exist? No? Okay. Then, yes. So this person does not exist. They are generated by GANs. If I refresh it, this person also does not exist. Try to find out flaws in the image. Try to find out flaws. You can also execute it at your end and try to find out flaws. And if you find any flaws, send that image. If you find any flaw, send that image. I to see very natural and beautiful images. See, beautiful girl, handsome boy. Good, very natural. Very good. Very good. Good photo. Very good. You exactly got I was looking for. Look at what Sanket has shared. Look at what Sanket has shared. No, that background is not a problem. It could be natural, Sandeep. You know what, friends? You will not be able to find out any flaw in the images. Most of the times, I'm not giving any guarantee, but most of the times you will not be able to find flaws in the single person images. But when it comes to generate multiple faces, it is failing. And by the way, the architecture behind this is the generative adversarial networks. And see, you know what? They trained with millions of images, and then the model captured how does a human face looks like, nose looks like, ears looks like. And when you ask it to generate new images, it is combining any random feature with any random feature and creating a altogether new face. And that is what is GAN. And in 2016, AlphaGo beats the professional Go chess player Lee Sedol. And from 2018, most of the universities introduced the course of generative AI or AI, right? Most of them introduced the course of AI. Now, after this, we get into the latest one. So 2014 was nothing but considered as the birth of the GANs. right? So generative adversarial networks introduced by Ian Goodfellow. So the idea of this, over here, there were two neural networks. One is the generator, one is the descriptor, and both of them are fighting with each other to generate realistic data. We'll be looking into this architecture later on. But yes, just remember this. And then in 2017, transformers came into picture, right? Google introduced transformers paper introducing the attention mechanism. So that was the core idea. So core idea is, instead of processing the text like sequentially like RLLs, transformers are known to look at the relationship between all the words simultaneously. So it's like if you're reading a whole paragraph at once, one word at a time. That is how transformer works. So it will read the entire paragraph at once, not like us reading one word at a time. Then in 2018 came the GPT paper by OpenAI, right? The first generative pre-trained transformer paper. And they basically trained a large language model on huge text data using the unsupervised pre-training. So this proved that language models could learn the context and semantics without explicit labeling, setting the stage for general purpose AI text generation. And for the first time, AI could now write sentences that felt coherent and context aware. Then in 2019, GPT-2 was launched. It was a 1.5 billion parameter model where now it could write articles, poems, stories from the short prompts. And it actually showed early signs of reasoning and summarization. In fact, it was so good. It was so good that OpenAI initially refused to release it publicly, fearing the misuse. The first hint of AI safety concerns started in the year 2019. Then, in 2020, GPT-3 came, 175 billion parameter model. You saw over here, it was almost a 10 times bigger jump in scale as compared to GPT-2. So it introduced few short learning. AI could perform unseen tasks from the minimal examples, became the backbone for applications like ChatGPT, Copilot, and early enterprise prototypes. So developers actually started using the GPT-3 through the APIs to build almost everything, right from resume to even the marketing assistant. Then in 2021, OpenAI introduced DALL-E, the first time text to image generation. So basically, it combines the language understanding with the visual generation. All this happens using the same transformer principle. So AI was no longer just talking, it was drawing, painting, and even imagining. Then in 2022 was the generative AI explosion. DALL-E second version came, Stable Diffusion came, Mid Journey came, Chat GPT's next version came. Chat GPT, see in 2022, it was publicly released, November 2022. And it reached 1 million users in just 5 days. And this was the tipping point. Generative AI became the mainstream. ChatGPT became the fastest growing product in the tech history. Then, after that, in 2023, GPT-4, multimodality, and open source momentum started. So GPT-4 was launched, and GPT-4 supported text, image, and reasoning. Then Google launched their Bard, which they later renamed as Gemini. Meta released Llama 2 as an open source alternative. OpenAI added function calling, code interpretation, and the custom GPTs. So basically, generative AI matured into the ecosystem, not just ChatGPT, but also as a platform for creation, automation, and enterprise integration. Then, in 2024, democratization and RAG came into picture, which became a dominant architecture for combining vector databases like Pinecone, Chroma with the LLMs for domain-specific knowledge. Agentic AI framework started coming over here. So various frameworks came into picture: LangChain, LangGraph, AutoGen, CrewAI. All of these are very popular, of which the most popular is the LangChain. Then Hugging Face came into picture in 2024. Then also in 2024, Anthropic launched its Claude 3. Also in 2024, you will see Grok also came into picture, introducing its LLM for specialized chip. And what happened in 2025 then came the era of agentic and multimodal era. So basically, LLMs became multimodal. They can handle text, image, audio, and code in the same session. GPT-5 was launched recently. Gemini 2.0 was launched. Claude Next was launched. Then Mistral 8 crossed 22 billion was launched. Llama 3 came into picture. And all of these had seamless integrations now into the enterprise ecosystem: CRM, ERP, BI tools, everything was there. Software engineering workflows were there, right? So there were a lot of new benchmarks like groundedness, hallucination resistance, reasoning accuracy, agent collaboration. So all of this came over here. Yes. So I can definitely say that right from GANs to GPT, from text prediction to autonomous reasoning, Gen AI has evolved faster a decade than electricity as it was adopted in 50 years. But Gen AI was adopted in just 5 days, just in 5 days. Right. So that is what we can say. But still, we are very, very far away from AGI. We are very far away from AGI. That is for sure. So this completes it. Now we say, I want you to self-read this slide. Now, after this, now this is an important one. Have a look at the share of industry employment in each of the domains, and then I will discuss a little bit on this. See, when we talk about AI automation, we always think about, which jobs are most at risk of replacement and which ones are the safest. Let's understand this chart, right? So the bar over here shows how much each industry workforce is being exposed to risk, right, of the category that you see in over here. So if you see over here, the dark blue, which is 0 to 10%, it shows no automation. That means the role that AI cannot touch, mainly manual, physical, or the interpersonal tasks. If you look into the medium blue, 10 to 49%, these are the ones where AI can complement, where the AI assistant, which are nothing but the human, AI is basically going to assist humans in that place. This is what we can say. So you can think of it as the co-pilot mode. And the light blue that you see over here is the likely replacement. So jobs that are highly automable, where AI can independently perform much of the function. So see, If you look into the least exposed ones are the ones where low automation is possible, like building maintenance, cleaning, installation, repair, and extraction. So these are nothing but the hands-on physical roles that require mobility, dexterity, and adaptability. So these are the areas where robots and AI still struggle. So if you think of a plumber, electrician, or even a field technician, right? They deal with unpredictable environments. AI can definitely help diagnose. It can diagnose the issues, but not physically fix a leak or wire a panel. At least not yet. Then we get into the moderately exposed ones. So consider manufacturing, food preparation, transportation. You consider the healthcare support. See, in this sector's area is in this sector, AI will be acting as a productive amplifier. It can assist the humans rather than replacing them. Like AI can guide the factory line optimization, but the humans will still oversee the quality control. In hospitals, AI helps with diagnosis and record summarization, while nurses and doctors make decisions. This is where most of the job evolution will happen, where roles will shift, not vanish. And the next is the highly exposed one, which is likely replacement or AI driven transformation, where you have office administration, legal, business or finance, education, IT. So these are cognitive and digital jobs, the ones which are most impacted by generative AI. So when your work involves producing text, code, analysis, or even design, AI is learning to do those tasks. So office assistants are replaced by tools like Microsoft Copilot because they can schedule meetings, summarize emails, or even draft the reports. If you look at paralegals, they also use AI to scan legal documents for precedent research. Software engineers, we are relying on Copilot or ChatGPT for entire code modules. Yes, so that is what we understand. I personally think automation is not a villain here. It is nothing but reallocation of human intelligence. It is away from repetition towards innovation. When washing machines came, is it like all the jobs went off? No, new jobs got created. Manufacturing washing machine, repairing washing machine, right? When calculator came, right, or when computers came, jobs went away, but new jobs created. Computer engineers came into picture. A lot of evolvement happened in the software engineering industry. So basically, the one who is adaptable is the one who succeeds. The one who is very rigid on learning anything new will be away and will just keep on cribbing. AI is bad or AI is this. That's obviously how the things are going to be. Now let's look into something interesting. We are looking into the generative AI use cases. So here, the first one is Persado AI, which uses Gen AI to create language that personalizes, customizes customers' digital experience. Then rephrase.ai, right? This is again something very interesting. So rephrase.ai is basically a Gen AI video platform that generates digital avatars, realistic human-like versions of actors or presenters. In the Cadbury campaign, AI took Shah Rukh Khan's face and voice data and then generated thousands of localized ads, each of this one promoting a small shop by name. So basically, how it worked, Cadbury wanted to support the local retailers post-pandemic. So they recorded Shah Rukh Khan's bass performance once, right? Very bass performance. And they used a generative AI, his speech, his lip movement, all of them were digitally resynthesized for each store. So basically, you can see now Shah Rukh Khan actually speaking, visit Anand Sweets in Lucknow or buy from Kirana Electronics in Pune. So every business owner got a personalized celebrity ad without ever meeting the actor. Right? Of course, with permission of the actor. So this campaign was impossible before generative AI, but it democratized advertising, giving even a corner shop access to Bollywood level marketing. And therefore, over 1,000 small businesses were featured and millions of personalized ad impressions generated automatically. So it was kind of 10 times higher engagement because audience felt celebrity personally endorsed their store. So Refresh.ai basically combines the text to speech plus face synthesis GANs to map the actor's face expressions to the new scripts. Also, on the workflow side, you basically have text input to the speech generation, then they go to the lip sync and then the video composing. And thereby you get a fully realistic video message that can be mass customized at a scale. So it's like ChatGPT for video, where you type a script and AI avatar performs it for you. So if a small business can afford a personalized ad with a top celebrity, what does this mean for creative agencies? Will they lose work, or will they have to evolve to design AI-driven storytelling ecosystem? Right? They have to evolve. They will have to focus on strategy and concept than the production. Right? That's something which is very, very important. How many of you use Mintra? How many of you use Mintra? I had seen this right during the COVID time. Yes, right. I think I'm the only one who doesn't use it. Yes. So whenever we shop online on Amazon or Myntra, and the site is suggesting us exact outfits or accessories that you were thinking about, that's not a coincidence. So what happens behind is now Gen AI is going beyond the recommendation. So we entered into the retail now, where Gen AI or AI doesn't just suggest, but it actually creates, curates, and converses. And one of the brilliant example is the Mintra's My Fashion GPT. So India's first AI-powered fashion assistant, which is integrated directly into the e-commerce application. So this was powered by again OpenAI GPT to make the fashion discovery as natural as chatting with a stylist. So instead of typing the product names that men's black blazer, users can actually now describe how they want to feel or how they want to look. So you can just say, show me the show me the outfits that I can wear this Diwali party under rupees 3,000. Or what would Tom Cruise wear on a vacation? And then the AI instantly generates the outfit recommendations, mixing the products, styles, and the accessories, all from the Mintra's live catalog, right? So this was awesome thing over here. So this kind of helped them to boost their productivity almost 2 to 3 times longer. Their conversion rate also increased because AI removes the search fatigue, and they were also able to enhance the retention and the loyalty as the customers feel seen and understood. So retail is shifting basically towards basically from buying what is available to getting what you imagine, right? So user, that's the advantage thing, right? I can just go to Myntra and say casual dinner outfit for monsoon. AI interprets the intent and emotion, and it returns contextual stylized looks. So you get a very high personalization and a conversational experience. That is something which is good over here. Then GitHub Copilot, we already know automated code completion, code generation, intelligent suggestions, bug detection, correction, and code summarization. In BFSI, I talked about Bloomberg GPT, which is a 50 billion parameter model for financial domain, text generation, conversational systems, sentiment analysis, answering financial questions, and providing title suggestions for newsletters. Then when it comes to customer operations, now this is again an interesting use case. Make My Trip. They collaborated with Microsoft to make travel planning more inclusive and accessible by introducing voice assisted booking in Indian languages. So basically, see, what does that mean? You can book your trip just by talking naturally in Hindi, Tamil, Bengali, or any other Indian language, and the system handled everything right from the flights to hotels through an intelligent AI assistant. So India's internet users are not just urban professionals anymore. Today we know millions of tier 2 and tier 3 users are online, but they prefer interacting with the local languages and via voice and not text. So traditional travel platforms assumed everyone is comfortable typing in English. So that's what I was saying, that the older platforms always prefer typing in English. That is exactly where, what we call digitally divide existed. And Make My Trip decided to solve this. So they basically integrated with Microsoft to integrate the Azure OpenAI services, enabling AI-powered voice assistant. Right. So now, as a user, I can just say, मुझे आगरा के लिए कल सुबह का फ्लाइट और एक अच्छा होटल चाहिए. I want a morning flight to Agra and a good hotel. And that's it. The AI will instantly understand your intent, search for the flight, filter the hotel, and then respond back to you in Hindi, guiding the users step by step through the guiding process. Right. So that's something which is interesting. Then you want to look for a job in Gen AI. These are the skills that you should look for. You have to read up, just highlight few of the skills that you should ideally have. Don't read each and every line. And then now comes the last slide over here. Right, this is the last slide of this deck. And what do we understand from this? See here, if you see, so see, you can be a software engineer or AI engineer. You can be a data scientist or AI researcher. You may be a technical leader like product manager, IT consultant. You may be a business function, marketing, finance, law, HR, or you may be a business leader. who are you? Based on that, how much foundational model research you need to do, how much prompt engineering you need to have, how much you should have knowledge of developing AI based application and the generative AI production solutioning, right? So based on your domains, you have to look into this vertically. So I want you to just understand this, right? So depending on your job, we need to understand that, see, Gen AI is used across the industries, but how much of Gen AI do you really need to learn on your role today? See, Gen AI, it's role dependent, and that is what this matrix is helping you to see, right? How deep or how wide your learning curve should be. So according to me, there are four key generative AI skills that are coming across the five professional roles, and each of them is going to tell you the intensity of the learning required: high, medium, low, depending on how the roles interact with the AI. So as you can see, if you look at the foundation model research, where you need to understand the architecture of GPT, Llama, architecture of diffusion models, how the models are trained, tokenized, and fine-tuned, exactly what we are going to study. So over there, you need a very high skill if you are a data scientist and AI researcher, because you are actually going to deal with model training and optimization. You need it on a medium level if you are a software or an AI engineer, because you implement it through the APIs. So you don't necessarily build the models. And as a leader, as a business team, you just need you just need a conceptual clarity of them, right? So you can think of this as an understanding of how the engine of a car works under the hood. It is critical for the AI builders. It is optional for the AI users. Then coming on to the second skill, which is prompt engineering and Gen AI tools. Now, when I say prompt engineering and Gen AI tools, I'm talking about, see, everyone needs hands-on exposure. You are interacting with the LLM, you are crafting prompts, you are using AI tools like Copilot, Gemini, Claude, DALL-E. So who needs this skill on a high level? If you are an engineer, data scientist, product manager, and business function, all of them use AI for productivity and ideation. You need it on a medium level if you are a business leader, because your focus is more on the strategy and the governance rather than day-to-day prompting. In short, if you can write a good prompt, you can lead a Gen AI conversation. The third one is developing AI-based applications. So basically, when I say developing AI-based applications, it's all about integrating your AI models into the applications, like you're building a chatbot or a rack system or workflow automation. So this skill is very highly required for engineer or data scientists, because they build and deploy. On a medium level for product managers, because they just need to understand the integration and the feasibility. And you need it at a low level, because business functions and leaders, right? So they are the users, they are not the builders. That is what is important thing. So it's like, if generative AI is the car, then this skill is going to teach how to install the engine and connect it to the wheels. And the last one is Gen AI product solutioning. So it's basically about translating the AI capabilities into business values. How? By identifying the use cases, a return on investment, and your customer impact. This is required in high demand for data scientists, engineers, and product leaders, because they shape the AI features into the real products. Business leaders need this on a medium level, because they just sponsor or scale those solutions. And functional teams, they are least bothered about it because they mainly consume the AI solutions. From this all slide, we understand that Gen AI is not a single skill. It's kind of like a journey, right? And your journey depends on your role in the ecosystem. But see, you know what? One truth remains constant. Everyone must speak the language of AI. And even if not everyone codes, you should know the language of AI. That is certainly for sure. And then from the encoder-decoder architecture, we get into the encoder-decoder architecture with attention mechanism, which will make your network to remember past 1000 words. And then comes the transformer architecture. And then after that, we get into the hugging phase. Now, the thing is, without understanding this architecture as well, you can still understand hugging phase because the transformer architecture is all about using the pre-trained large language model directly for inference. Now, I can assure you what you study will be used many times in your day-to-day life. So what you have to do is, let me explain you hugging face. Friends, first and foremost thing, what you have to do is you have to go to hugging face. You have to sign up with your personal ID. And after signing up, you have to confirm your email address on your mailbox. First, you sign up. After sign up, you have to confirm your email address on the mailbox. Listen to me, don't do it instantly. I'll give you time to do that. And after confirming, here, if you see here in the profile photo, if you get into access tokens, then you get the option to create new access token. This option will be frozen if you forget to confirm your email address. And if you confirm your email address, then this becomes unfrozen. Then you click on create new token. You give the name over here as HF underscore token. And then do not tick anywhere. Straight away go to the bottom and say create token. Straight away say create token. Do not tick anywhere. This will generate the API key for Hugging Face. I have already generated mine. So if I just go over here and I create a folder number 2, Hugging Face API. So let me just call it as Hugging Face only. You will also be implementing it. Here I'm going and I'm creating a Google Collaboratory, a new notebook. I'll give you time to do it. Just let me explain you. Sign up, confirm your address, then go to create new tokens, which comes over here in the profile photo, access tokens, and that token will be called as HF underscore token. That will give you an API key. And if you look into the secret key section, so here I have so many API keys. One of the API key, you have to click on add new secret key and you have to add your HF token, the same name, and your API key over here. Then you can go to file and say save. This is what I want you all to do right now. Because what are we doing? We are going to use the state of the art pre-trained large language models for inference. Why? Because we cannot train a large language model on your system. You know, ChatGPT 3.5 was trained using how many GPUs? Anyone knows? Without Googling, can you tell me, just a wild guess, ChatGPT 3.5 was trained using how many GPUs? 3000. Good one. The ideal answer is 6000 GPUs. Let me ask you one more question. How much time did OpenAI take to create ChatGPT 3.5? Any idea? I mean, training time. Training time. Just like for training a neural network, we need a lot of time. So, how much time might OpenAI have taken for training the neural network? 3 months. That's absolutely correct. So, we cannot think of, forget about you and me, most of the biggest giants in the industry cannot think of training a large language model because it is not just about GPU and time, it is also about data, right? It is also about data. So you need a huge amount of data. And after that, data privacy issues, copyright issues. No one wants to get into all that thing. OpenAI, Anthropic, Meta, they are already doing this perplexity. So we will end up consuming them because consuming them is far more cheaper. Because if any new information has to be updated, you have to again retrain. That is going very costly. And therefore, we use these models. But all of this, OpenAI mod, GPT models, Meta's models, all of these are paid. But the models available on Hugging Face, if you come into model section, have a look over here, friends. How many models are available? 2 crore? 2 lakhs? How many are available? How many models are available? A rough overall figure. 21 lakh. Yes, I wanted you all to read that. 21 lakh open source LLMs are available. And these are available for so many tasks. You have computer vision models available. So today, whatever you studied in deep learning, you don't need that. Natural language processing models are available. We are exactly going to explore these sections. Audio models are available, tabular data is available, reinforcement, others are available. Multimodal, audio and text both as input and text as output, or image and text as input and text as output. All of these are available. So we don't train from the scratch is what I wanted to tell you. And it's not only about you, n number of organizations. Have you ever heard about Salesforce training their own large language model? No. Oracle using their own large language model? No. Walmart having its own large language model? No. You take any big company. Hey, in fact, I guess Microsoft also doesn't have their own large language model. Am I correct? Is Microsoft having its own large language model anywhere? Have you heard of? Okay, let's go ahead. Now let me go to Hugging Face, friends. Hugging Face will be exploring every section of it. Number one, models, which I'll take at the last. Number two, you remember just like Seaborn was having built-in data sets like TIPS data set, Titanic data set. They are preloaded in Seaborn. In the same way, Hugging Face also has a lot of data sets which we can end up using for practice. Now, at this point of time, I don't need it, but depending on the task, which task am I doing? Let's say I'm doing image classification. You have so many data sets available. Like ImageNet is one of the data set, right? I can go through this, but right now we don't need it. Documents is nothing but the help documentation. Pricing part is the pricing part. You can boost your Hugging Face by going for a pro account where you will be getting 10 times private storage capacity, 20 times included inference credit, GPU quota issues, and many other things. But you don't need it ideally. And the spaces. Spaces is where you directly have models to try upon. Just like how you try ChatGPT by going to the website and playing around with it. How you try Perplexity. How do you try the DALL-E, Mid Journey, Copilot. in the same way. So let's say I'm going for text generation. I click on this. So many are available. This model, I can also sort it out. This is by relevance. I can sort it based on anything. Let's say I'm looking for this emoji generator and prompt lab. Emoji generator is for translating text to emoji using the Gemma 3 model, and prompt lab is for enhancing your prompt. So if I come over here and say emoji generator, so the model is loading. Now type any phrases and suggestions. I am feeling really awesome because I am getting the delivery of my new car. Fail to generate response. I'll try it once again. I don't know why. Okay. So you can see it got the emojis, right? That's really sad. And you see, you get the emojis playing around. That's it. This is for prompt lab, right? Choose a prompt and you will be getting a proficient level 1. So I say, generate an image of a smiling dog in a red sweater. And I said, generate enhanced prompt. Error, you exceeded the quota limit. Oh my God, I might have used it earlier. So I'll go ahead and use some other one. So anything will fast, whisper, and so many. You can try it out. Wait a minute. Why am I struggling with it? I have given you the prompt. Could you try it out in this link and send me the screenshot of how your enhanced prompt look like? And I'm also sending the emoji one. So I wanted to try out this prompt lab. I have also given you the prompt of a smiling dog in a red sweater. And quickly send me how does the enhanced prompt look like. Quickly, don't take more than 15 seconds. Same error. Ha ha ha. Okay, no problem. Ignore it then. Ignore it. All the models don't work with the subscription. So this is what we understand. Text to image prompt enhancer. I'm using this one. And I'm copying the same prompt over here. Text to image, this. And oh, this is in Chinese. God knows what is it going to do. So that's going to be challenging. Oh, you got it, Sandeep. Wow. A golden retriever wearing a chunky knit, bright red sweater sits in sunny park with autumn ... That's good. Now, that was for text generation. If you want image generation, see, all models don't work because see, these models are either hosted on Hugging Face by big companies like Google, Microsoft, or you yourself can also host your own large language model if you have created. So if you don't maintain it, then maybe it goes obsolete as well. So I'm going to go on the basis of most recently updated. And this is for the generating images from the text. And there is one more. Okay, let's go ahead with this only. This is a Chinese one, so it doesn't excite me. Let me go for trending. I can directly also search for it. Stable diffusion. So this is generate images from text prompt. Stable diffusion 2.1 also available. And I go ahead. So here I say a corporate meeting of a manager delivering in front of 5 team members. This negative prompt. See, negative prompt is what do you don't want to be seen in a meeting. So I don't want to see a garden in the meeting. I don't want to see deformed human fingers in that image. I don't want deformed faces. I don't want ugly faces. I don't want cartoon or pixel characters. And I say generate. So what I want and what I don't want in the image. So by any chance, I don't want these kind of things to be there in the image. This is what I'm doing in. And you see over here, after doing that, you see, this is the kind of result which is generated. So stable diffusion is not good at generating images. I was aware of that. Not images, I would say human faces. And this is still, because I said deform faces and all, it is still managing to do it better. Still managing to do it better. If I say over here, a Mickey Mouse riding a Santa Claus sledge in the snow, deformed faces and fingers. So I'm asking it to generate an image once again. Now it will be good with this kind of image generation, huh? But with faces, it is not really good. See, I told you, nice image. Look at his hand. So you can play around. See, this is stable diffusion 2.1. This is stable diffusion 3. So I click on run. There are some advanced settings also available. I didn't explore it, but you can use it. Negative prompting and all these things available. But see, this is better. 2 Mickey Mouses. Okay. Multiple Mickey Mouses. And what I don't want, this. And height, width, everything I can give. And I can run it. So obviously this is expected to be better, na? And it did. Look at the quality of the image. Right? This is better. There are also some predefined astronaut in the jungle. Cold. Color palette, muted colors, detailed 8K. And wow, this is better. You can't complain about it for sure. Okay. Not all the models work. You can try out many more over here. So that is the spaces part. Now I get into the models part. So here, whenever I click on models, I see there are 21 lakh models. Tasks. So what all types of models are available? Multimodal, computer vision models, natural language processing models, audio, tabular, reinforcement learning, and other. I have not tried this RL and other wala part ever. Not really relevant to my work. I'm starting with the summarization one. So first, you don't need any great knowledge of the architecture for doing that. The first thing that you need to do is Control V. From transformers, import pipeline. Just like from sklearn, import train test split. From sklearn.model selection, import this. In the same way, I want to import the pipeline class. This is exactly where the LLMs are available. But one important thing I forgot to tell you, please, because these LLMs are used in memory and you need good amount of compute, click on runtime, change runtime and T4. Connect to T4. And I once again run it. Then I say, the next line which I do is, I am saying this pipeline class I imported, transformers is not installed by default in Colab. Sandeep, you are telling or you are asking? I'm asking for time. It is installed. You can see over here, I got a tick as well for the first cell. If there was a need to install Sandeep, don't you think I would have been the very first person to say pip install? Yes. So, but yes, around 4 months back, I actually had to do pip install transformers. I had to do pip install transformers. I'll show you my earlier notebook. I'll just share a screenshot of this from where I'm copying the code, right? So yeah, I just shared a screenshot. So there was a time when installation was mandatory. Now it's not. As you can see, we got the output. That's why, something which is not required, why will I unnecessary discuss and waste the time of the class? That's why I skipped it. So now, next one. We create an instance of the pipeline class. You can give any name to this. This is just like creating an object, just like we say LR is equal to linear regression, right? Or DT is equal to decision tree classifier, or R is equal to model dot fit. In the same way, summarizer is equal to pipeline. This is the place where you submit the task. Task is summarization. And this is the model. Darshan, from where did you get the model name? Best way to find it out is copy this highlighted portion, go to Google, paste it, and press enter. Then by default, the first link which you will see will be Schiffler Distill Bart. Now here also they have given some examples. You can read about the models over here, what they trained it on, what is the accuracy they got, everything. I will straight away click on this deployment part. I can click on example and then I can click on generate. It will generate a summary. So some text is given and you see, this is how it is working. But I want to use it in code. You click on use this model transformer. Every time you will not find so great resources, right? But see over here. You can also click on collab. It will show you a direct collab notebook, but you don't need it. Click on transformers. Now if you see, oh, you are copying from here, Darshan. Yes, I was. From transformers import pipeline. Then pipe is equal to pipeline summarization and the model name is this. Going forward, after we come back from our Diwali mood, we will also be looking into the architecture where I will explain you that if you have to load this model, tokenize by yourself and do everything, how do you do that while doing the fine tuning job? As of now, this highlighted code is just not important. That is only required for a developer if he is doing fine tuning or RAG, which is required at the end of our course, so that you need not worry about. So I say, so this name of the model is taken from here. In fact, you can straight away go over here and say copy. It will by default copy this name only. Copy. So when I do that, now see what happens. The large language model is getting downloaded from the Hugging Face because of the API key. It's very important that this toggle button is turned on. Even if it is not turned on, it will give you a pop-up box to access the API key. You have to say yes over there. You can see it is 1.22 GB right now, which is getting downloaded. 1.22 GB. Therefore, in one notebook, it is advisable if you load only one model. And we need a huge amount of memory. Now, Hugging Face models are temporarily downloaded. Once you restart the kernel, they are gone. They are temporarily downloaded. If you want to permanently download a model, that we will study in next to next class. How do we do it via Olama? For now, the model is downloaded. Then I need to summarize the text. So what do you want to summarize, Darshan? I say, this is an article, which is nothing but a string. Just a string, right? So I want to summarize it. So I just saved it into a variable by the name article. And then over here, the name of the object was summarizer. So I come over here and I say, summarizer, take this article, which is this one, and summarize it into minimum and maximum length as you see. Do sample, I'll explain you in a couple of minutes. So if you see, it has created a summary. So do you need the architecture understanding over here? Answer is no. But do you don't need it ever? No, you always need it going forward for advanced tasks. So employers are starting to use time clock machines that fingerprint employees. Machines are tied to their unique characteristics, such as your face, finger, how you talk, and even how you walk. The Center for Disease Control says that coronavirus can remain on the surface for hours. Okay. Now, what is this? You know what? The length of the output must be minimum 30 characters and maximum 130 characters, which is wrong. This is wrong. The large language models do not understand characters. I'll show you. The large language models only understand tokens. This is one of the best resource to understand the tokens. So here, see what they say. OpenAI's large language models process the text using tokens. Every LLM process it using token only, but everyone has a different way of tokenization. So I might use a different tokenizer. OpenAI will be using a different one. Google will be using different one. Meta will be using different one. Our aim is to understand what do we mean by tokenization. Because in simple words, you know what is tokenization? From our NLP understanding, what do we understand what is tokenization? If you look into this image, I am dividing a sentence into words. This is tokenization? Of course, yes. This is also tokenization, 100% yes. Is this tokenization? Yes, this is word level tokenization. This is also word level tokenization. But it can even be a character level tokenization. So here you can see character token machine learning or pure character level tokenization. There are n number of tokenizers. LLMs use their own way. What is that? Let's try to understand. OpenAI's large language models process the text using tokens, which are common sequences of the characters found in the set of text. The models learns to understand the statistical relationship between the tokens and excel at producing the next token in the sequence of tokens. You can use the below tool to understand how a piece of text might be tokenized by the LLM. Might be कोई guarantee नहीं है. There is no guarantee. Might be. So if I say my name is Dr. Darshan Ingle and I am a data scientist. There are 56 characters and 17 tokens. So your OpenAI models, they will be charging you on the basis of tokens. You can see my name Darshan is divided into two. My surname is also divided into two. So every word is not necessarily a token. Now you might be thinking that on what basis it is doing it. If I take anything, for example, if I'm taking this drone, for example, if I keep on breaking it, any particle, I take any particle and if I keep on breaking it, the smallest thing that I will find from this will be an atom. Correct. The smallest thing which I'll find from this will be nothing but an atom. In the same way, as per a LLM, the smallest thing which it understands is a token. Now, why token? The reason for token is because if I go to Google Translate and if I copy this sentence and convert it, let's say to, and I duplicate this. Let's understand. Now see here, 56 characters were 17 tokens in English. 56 characters, 17 tokens. Here see, 56 increased by just 4 characters, but the token count increased from 17 to 26, which means Kannada is more expensive to process as compared to English because you are charged on the basis of tokens. So what is exactly a character is very difficult to figure out. So they divide it into something which is called as tokens. In fact, if I go over here and I say, I want it into German. See now this German, or let's say Polish. Now see here, this is what? Is this a E in, is this E? Tell me, is this E? Is this the E that we talk about in English? No. It has there some special meaning. We don't know that, but it has some special meaning. So now, do you think OpenAI should charge same for processing E versus this wala E? No. That is the reason they charge it differently. So a standard conversion factor which they have come up with is nothing but this here. 70 characters, 23 tokens. So they charge you on the basis of tokens. So friends, now you can see, you can also play around with it, by the way. I'll just share the link with you. So max length 130 tokens, min length 30 tokens. It is not characters, friend, it is tokens. And what is this do sample equal to false? See, if you try executing this notebook again, you will still see the same output. If I run it again, you will again see the same output. But if I say do sample equal to true, you will see different outputs. They will not be the same. You can actually try to compare it. They will not be exactly identical. Please confirm. Are the three outputs that you see on the screen exactly identical? If I say, what is the first word which comes to your mind? We have probably seen this sentence millions of times, much more than what other words. But if I say, hey, no, ignore green, tell me some other words which can take this place. When you were saying do sample equal to false, LLMs are probabilistic classifiers. If you look into the transformers architecture, which is nothing but this, at the end there is a softmax. You remember na softmax that we studied in deep learning? So it predicts not one probability, but it predicts, let's say, n number of probabilities. The grass is dash. So in the sentence, the grass is dash, let's say it predicted around possible words. The grass is dash, 30 possible words can come, and all of these words are printed in the descending order of their probability. All of these are in the descending order of probability. So that is the reason, I guess, the green word would have been there with around 0.87 probability, and this might be the highest. That's why it predicted. And this is what was happening when I was saying dense is equal to, sorry, do sample is equal to false. It was always picking up the next word with the highest probability. But when I say do sample equal to false, it is going to pick up from the remaining 25 possibilities, remaining 29 possibilities. And that is exactly why you are getting a different output. So every time it is picking up the challenging words. Are you all clear with do sample equal to true and false? NLP, summarization. See here, summarization. I click on this. There are almost 2,500 models available for text summarization. Which one do you want to use? Google. Google looks impressive. Google का नाम है तो कैसे छोड़ेंगे? So Google has its own model. Let me see. अरे Google. Hey Google. Are you going to work? Failed. No problem. I don't want to try here 1 second. No, this is the name of the model to copy, right? See how easy it is. I go, I comment out this, and I paste it again, and I go and copy this name. By the way, see, don't use anything anywhere, friends. See what is they, what are they, what have they written? This is the CNN Daily Mail. Read about it. One moment. So I was saying that these models, friends, don't blindly use it. You have 2,500 models, but you have to read also. Are Google has trained this model on what data? It is an expert in what? Can you come to me and say that Darshan sir, my heart is paining. Could you please treat me? I am not a doctor, right? Or so I say I'm an engineer. Okay, Darshan sir, you are an engineer, na? Okay. I am having this problem. This production conveyor belt is having some issues. Please help me. I am a computer engineer. In the same way, this is for what? It is trained on CNN's Daily Mail. So you need to read this documentation. They have trained it on what? That will be the proficiency of the model. It is not a general purpose summarization model. So before you use, understanding this is also equally important. So deleting, pasting, do not run it directly. You know why? You have a limited RAM. Half of the RAM is already occupied, 6.25 GB, because you have already loaded this model. So what will I do is I'll say runtime, restart session. And then I can go to runtime and say before. So it will load it again. Without restarting also, it will work, but sometimes it will lead to memory overflow. Why do you want to get into that? Or you go for Collab Pro. So that will be awesome. This is the article which was taken. So I'll take the same thing and ask it to summarize. The model is getting downloaded. See, it is 2.28 GB. Are you finding it easy? You just have to change the model like this. Are others sleeping and only Pritham is attending my class? If that is the case, then we can get into music direction work. We have many other jobs. Only teaching is not our job. The benefits for your boss may come at a cost to you. With the global outbreak of COVID-19, your personal health could be at risk. Biometric devices pose massive personal security issues. Cool. In this way, friends, you can use any other model. Let's say for a change, I want to park this model and go for Facebook model. Copy this name. See, this is trained on CNN Daily Mail. I am blindly doing it, but in real life, I actually read through the documentation, then I do it. So I say restart and run all. So it will 1 second download and do the needful. And by the time this is happening, we know it is going to work. I'm creating one more notebook. And this time, this is on Stable Diffusion, where we are looking into text to image generation. Image generation notebook. Now I cannot connect this to GPU because already one notebook is connected. Unless until I disconnect it, because we are using a free version, right? So you cannot connect it. So we got the output. Fine. We are happy with it. I don't want to discuss more on the output. You have to evaluate it. Disconnect and delete runtime. And now here I go to runtime, change runtime, T4 and connect. Okay. Now for this notebook, I need to install libraries. First is the diffusers library. So the diffusers library is developed by Hugging Face. And this library is mainly for working with the diffusion models. So those models, which are responsible for generating text to image, they are called as the diffusion models. So they are a type of machine learning models which are often used for generating images. So then I would say, then pip install accelerate. Now accelerate is optional, but it is used for accelerating the performance, right? As you can see, it is designed to simplify the process of training and running ML models, especially deep learning with multiple GPU and TPU. It helps in managing resources efficiently, distribute training across the devices, and optimize the performance. So two libraries installed, and then I say from diffusers, import stable diffusion pipeline, import torch. You know why torch? Because I forgot to give the access. So it will ask me for this, and then it will start downloading. I forgot to toggle on my API key. So this framework is designed not using TensorFlow architecture, but using PyTorch. And hence you have to do that. And then I say pipe is equal to stable diffusion dot from pre-trained model. Model ID, which is this stable diffusion version 5. Then this is saying that I'll be using all the variables of the float 16 type. You don't have to change it. Now, one optional step on line number 6. This pipe object which I created on line 5, I'm moving it to CUDA. CUDA is basically the GPU memory. So if you skip this, it will be very slow. By the way, you can see at the bottom 1 minute 38 seconds are already over and it is still running. If I would have not shifted to CUDA, then your code would have literally gone into CUDA. CUDA means kachra. So here I give it a prompt. A photo of an astronaut riding a horse on Mars planet. Image is equal to pipe of the prompt, image of 0. The generated image friend would be available here because I only asked it to save it by the name astronaut rides horse.png. What all formats can it save? You can definitely Google about it. So it is still downloading. So many things. This takes time. I'm already aware of it. This takes time. And still doing. I'll give one more prompt by that time. New.png. But this is done or not? No, it's still in the process of doing it. How many? 3 minutes, 16 seconds on over. It is loading the model only. And if your net is bad, what you get would be bad. What get in this, what you time to load would be bad, not get. Still in the process. It will happen. It won't take a lot of time. It should happen now. Once it is loaded, then for inferencing, it is going to be good. Then there is no problem. By that time, done? No, it's still doing. It is very close to be done. Looks like it is stuck up somewhere or what? It should not take so long for sure. So long it should not take for sure. Something went wrong. What is it saying? Nah. Runtime, restart and run on. It takes around 1-2 minutes. I know that, but it doesn't take so long. Meanwhile, because the notebook is already saved, you can also try executing it. It's there in our drive folder. And by the time it is doing it, Yes, running from VS Code is where you will purely be depending on your own GPU speed. Sometimes it is fast as well. I will give you some tasks as a part of homework. I'll be taking that, but what you can do is, as a part of homework, sentiment analysis is what one thing you can try. You can try out table question answering. So basically in table question answering, you will be reading a data set and you will directly ask questions and it will be answering from that. And sentence similarity is one more I'm giving you. So checking how similar are the sentences. Oh, again it gave an error. No, there is no error in the notebook for sure. What is it saying? There is no way of error. I don't know if something changed all of a sudden last night. I don't know, but there cannot be any error for sure. Okay, torch D type is deprecated. So instead of torch D type, they say use only D type. But this code runs fine. There is no problem with the code for sure. I can actually show you. I have it in my stable diffusion notebook. This runs fine for sure. I'll try to figure out what is the error. I mean, model is also loaded correctly. So it works fine for sure, right? Horse.png, but not sure why today it gave an error. We can figure it out later. You can also take it down as a part of exercise. So this is again your take home task. Runtime, disconnect and delete runtime. First, for the summarization, just a 1 minute overview so that we are back into the track. So from transformers, we are importing pipeline. Then I create an instance of the summarization pipeline. The model used was, let's say this one. How do we know about this model? I paste the name of the model on Google. The first link which comes up is for this model, obviously. And then for using it, I said you click on use this models, click on transformer, and this was the code. We will also be looking into this type of code when we get into the fine tuning part, not at the moment. So we loaded the model, and after the model is loaded, I did write a lengthy article and I gave that article to the summarizer object, which we created here. And we asked it to summarize it into maximum 130 tokens, minimum 30 tokens. Do sample equal to false will generate the same output again and again. Equal to true will make it different every time. This was the first thing that we did. Then the next thing that we did was we imported necessary libraries, import torch, and then we loaded this model from the stable diffusion. And this is fine. And then we asked it to generate the image of what? An astronaut riding a horse on Mars planet. That was the thing that we generated. And meanwhile, it is actually generating more. The first one is the vision transformer. This is for image classification. I'll just create the notebook so far. Meanwhile, let me see what is the status over here. In the process, it's working. I didn't do any changes. In fact, the changes which I did earlier, I actually commented it out. and I'm going with the older implementation. Absolute no changes to the code. And I'm a little optimistic about this to run because everything is happening as expected. It's downloading the things as well. So this is the model, right? 2.23 GB. It is just loading the necessary things. Most of the things are done except this. See, this is progressing. Yeah, almost done, looks like that. Till the time it is downloading the right packages, there is no issue. I guess it's done. Great. We got an image. Absolute no changes to the code. And you can see this was the image of an astronaut riding a horse on planet Mars. Not really great, right? Yes, because it is an open source model, but that's fine. And because it ran successfully, I'm just getting rid of unnecessary code so that we only have the necessary things. Okay. Then to make the image little bit better, what did I do is I say masterpiece, better prompt, best quality, ultra detailed photo of astronaut riding a horse on the surface of Mars, cinematic lighting, dramatic sky, red dust cloud, depth of field, high resolution, 8K, realistic picture, sharp focus. And this is what I'm planning to save. Let's say by astronaut riding horse 2. Now it will be fast. It won't take a lot of time because the model is already ready. It is just going to create the image. So that day it was a problem with the hugging face only. It never happens, but yeah, it's fine. We were just unlucky. Let's see. Yeah, this is ready. If it doesn't see, refresh it. And because of a better prompt, what are we getting? Yeah, that's better output, but looks like still the horse is suspended in the air if you look at his toes. And I don't know, 1, 2, 3, 4, 5 legs to this horse. And see, the tail looks very much artificial. I tried once again, and this time the prompt was masterpiece, ultra detailed cyberpunk samurai standing under the neon lights in a rainy Tokyo street, glowing katana, holographic signs, cinematic lighting, reflections on the wet asphalt, 8K in the style of Blade Runner. Many things are missing, not only katana, many things are missing. So I didn't even see this, what do you call, holographic sign. I don't know if I see anything, but I don't see any holographic signs as such. But anyways, see, we are using the runway ML model. I'll directly Google out for some nice prompts which can be given. Prompts for stable diffusion. And it's very good with the cartoonish images. All right. So copied this and let's try it. A young man sitting quietly with headphones on, deep in focus, soft blue gold lighting, calm atmosphere. Meanwhile, the second one is a Chinese prompt. I don't want to get into that. This is also Chinese. Okay, make Adolf Hitler very funny. Chinese prom. Okay. Woven bangs and ponytails in wine red t-shirt. By the way, let's see the new one so far. Yeah, that's good. Not bad. Let's look into new two. See, deformed. But that completes the Hugging Face. Now, as I told you, we are starting with the next one, and this is about the image classification. So I will have to go to runtime, connect this. It may not allow me because I didn't disconnect the earlier one. Let's see. Or maybe I did. I don't remember. All good. Now, what are we doing? See, we are basically doing the image classification notebook. And when I say image classification notebook, the model which I'm going to use will be responsible for classifying all of these categories. So, total 1000 classes, it can be used for classifying total 1000 classes. It can classify tench, goldfish, great white shark, tiger shark, and stingray, ostrich, gray whale, killer whale, dugong, sea lion. You can see boxer, bull mastiff, many such things. Marmoset. What is marmoset? Oh, that's a marmoset. Let me right click and save this image. Right click, save image as, and I'm going to create a folder for today. Image dot so yes, this marmoset image is saved successfully. Now, let's get started with the work. First, see, I remember we covered the convolutional neural network. So what was happening in convolutional neural network? There were total two stages. One stage was automatic feature extraction, which was taken care of by the convolutional pooling. And then there was an artificial neural network, which was responsible for doing the job of classification. In the same way, now everything is pre-trained. So what I say is from transformers, import the vision transformer feature extractor. What is that? This is the one which is responsible for given an image. So if I'm giving the image of a marmoset, it is going to extract as many number of features as possible from that. As many number of features possible from that it will be extracting. And then these extracted features by this VIT feature extractor will be given to the next transformer model, which is the image classification one. So this happens in two stages. One is extraction done by one model, and then the same model will be doing the classification. How? Let's see that. For displaying the image inside the Jupyter notebook, we require this ipython.display, import image, import display, etc. And over here for resizing the image, cropping the image, enhancing the image, anything, we need this pillow library, which is also known as Python imaging library. So I just did all the necessary installs. I'm going to copy the path of this, just 3 dots and copy. And then this is the path which I put in over here. Let this marmoset sit to the right hand side. Okay. Now, if you want to display this image right inside the Jupyter notebook, I can give the file name to the image class inside the display. So it will display this with the following width and height. So I think I gave a very big height. So instead of 700, let me give 300. And instead of 400, let me give 200. Over here is using the Pillow Python imaging library. I want to open this file mms.jpg, not jpeg, jpg. So this image.open reads this image and converts it into a Python imaging object, not a NumPy array or a tensor. Even though the variable is called as an image array, it is still a Python imaging library, not a raw pixel array yet. The model will later use this to process the image before making predictions. And I'll just check the type of the image. So it's a WebP image file. But I have saved it as .jpg, but when I right-clicked and saved, it was saving .webp extension. That's why it is saying it is a WebP image file. But I have saved it as JPG. Let's see in case if it gives any issues, I'll see. Now, what to do from this image? I want to extract as many features as possible. So I say vision transformer for feature extractor dot from pre-trained. So it will be downloading the pre-trained model. Which one? This one. It is a model by Google, Vision Transformer Base PAT 16224. This is the one. It is a pre-trained model on ImageNet 21,000. It consists of 21,000 different classes, which had total 14 million images. And all these images were trained at this resolution. Then what the Google did, Google took this model and then it fine-tuned it on ImageNet 2012 dataset, which only consists of 1 million images belonging to 1,000 classes, which I did show you here, right? So more on that you can read over here, right? I can in fact try it from here as well. This marmoset, right? If I upload it here, let's see what output comes. See, marmoset with 78% score. The score is always in the range 0 to 1. TT or TT monkey is also 0.21. So it is more confident that this is about marmoset. So obviously, if it is doing it from here, then definitely the same result is what we expect. It belongs to the class 377, by the way. Let's look into this. So I am calling this model. This is the instance of it. And the same model I am calling from the image classification. So this is responsible. Feature extractor is responsible for extracting features. And this model for vision transform for image classification is responsible for classifying the images. So time for us to extract the features. So see from this image, how many features can be extracted? 100, 200, 1,000. It depends. It depends. From any image, the number of features that can be extracted purely depends. So I say that take that image array, which we created above, and return PT. PT is nothing but the framework uses PyTorch, right? That's why you have PT. Feature extractor, images is equal to image array, and return tensors is equal to PyTorch. If it is TensorFlow, now you cannot change that, by the way. The creator, Google, used the PyTorch framework for creating this. So you cannot change this. If it is TensorFlow, if it was TensorFlow, which was used for this model, then you would write return tensors is equal to TF. So this is responsible for extracting features and it will be saved into inputs. But how many features? It depends. Let's say from this image of a coffee cup, it is extracting 500 features. But let's say from the image of this pen, it is extracting only 100 features. So features can really depend. Therefore, I don't know if you remember, but now you will realize how much things are needed from the past. When we studied Python, do you remember? Give me a heads up give me a thumbs up if you remember the star KWARGS, which is the keyword arguments that we studied during our Python class. So basically the number of features that can be extracted can vary. Therefore, we use this star. So any number of features are there, they will be passed on to the model class. Who is the model class? The model class is this, na? Right? Which is responsible for taking the features from the marmoset, right open-ended argument. And then I say output dot logits is what I am saving inside logits. So you know what is there inside the logits? Inside logits, there are total 1000 scores which are predicted. I have to basically, you know what is it? 1000 scores. It is telling what is the probability of it being gibbon, what is the probability of it being a Siaming, so on and so forth. What I have to do, I have to find the highest probability. Instead of logits, you can see shape of the logits, one row of 1000 columns, which means there are total 1000 probabilities that it has predicted. So now here, print predicted class. Did you see the predicted class is 377? And what is 377? Marmoset. But we don't have time to do this mapping. So there exists a function ID to label. There exists a function ID to label. So when I run this, it clearly says that the predicted class is a marmoset. Simple. So essentially, see, we did only one thing. Just to summarize all, we took an image, and this is the image of an Egyptian cat. Egyptian cat. We loaded the necessary things. This is the URL where the image is loaded, right? So we are opening that image because it is there on the internet. We are using the request, creating an instance of this, passing the image, features extracted, passed into model, and then we are asking it to predict. So this should predict Egyptian cat, and yes, that is absolutely. Now we are getting into sentiment analysis. Change runtime P4. Now there are many models available for the image classification that we saw. We use one of it. From transformers import pipeline, very standard code that we have been doing. What am I saying? I'm creating an instance of the sentiment analysis, but I didn't pass the model. See, let's see what happens. I never pass which model I want to use. It says no model was passed, defaulted to Distilbert, and this is the link of that. So it used by default this model. This is for the sentiment analysis. I can try one example over here. I like you, I love you. This model responds with only two outputs, either positive or negative. Positive means yes, all positive, negative means all negative. Right? So this is 100% positive is what we realize. For using this model, if you click on the transformers, you see imported, create an instance of it, and pass model is equal to. It's just that we didn't pass the model. Rest of the things are same, which means if you had to pass the model, this is the way you would have to write if I want to use the same model. And this device is equal to 0. Now, what does that device is equal to 0 means? See, device is equal to 0 means I want to use the 0th GPU. Imagine to my system, there are 5 GPUs connected. They are numbered as GPU 0, 1, 2, 3, 4. So which GPU I want to use for this operation? So obviously we are going ahead with the T4 GPU, and that's the only one GPU connected. So I just say device is equal to 0. That will ensure it uses the GPU, but I don't know why is it saying the device is set to CPU. Mm, here device is equal to 0. It should have, maybe it should ideally use, because just let you know, I'll add a cell over here as I told you. So device is equal to 0 means GPU 0. Device is equal to 1, 2 means use specific GPU if multiple are connected. And device is equal to -1 is CPU. And this is correct. Basically, looks like Google Colab doesn't have the GPU set. Are we connected to the T4? Yeah, it is. I don't know why then. Early also, we used to set it shows CPU in the logs. So it is not accessing it. So, Dhoka. Do we need to check first and tell which notebook to check if the GPU is available? Ideally, it should properly go. uh, all good. Let me try. False and no GPU detected. I was expecting it to. It should have, I'm clearly asking it, if the GPU is detected, so it is saying GPU detected is equal to false. होना तो चाहिए था, I don't know why. Possibly that. I'll do one thing. Maybe let me restart it once. You never know. I am just trying to execute this code cell. False. If I use some other GPU, if I'm using T4 or I'll just a moment before that. Command not found. So let me. It does not matter, but I'm just trying to figure out the issue. Without that also it works. That's not a problem. It does not matter, but it should ideally select the GPU. Two versions. Let me try this in case. That's the last hope. If it works, it works. If it doesn't, no issues. Leave it. We anyways have our model, so that's not a problem. And if I try to use any other model, many are available, right? So this is for emotion English distill Roberta base. So what does that do? Oh wow, I didn't know that. It can, okay, it will be classified into following emojis. That's nice. So let's try to use this. So what will I do is, I'll go up and I'll just try to copy the model. Rest of the things are anyways well aligned. And then we'll try some sentences. Oh wow, I didn't know that. Label is surprise. And this movie always makes me cry. It's sadness. Let's check it out. sadness 0.86, and this is also 0.86, and one more is there. Oh, happy dates, joy. It's joy with 0.76. Here also the same thing. This is the way we can try more. Okay, I want to take this one level ahead. So what am I doing is, I'll go up and I'll call it as notebook 1. And then comes the notebook 2. So for this notebook 2, I'm going to restart the runtime. I'm doing this. The model used is this Distill Roberta. This is fine-tuned on financial news sentiment analysis. That is not important. You know what am I interested in showing you is, I'll show you what am I interested in. So yes, if you look over here, if I click on use this model and transformers, you see this was the one which I was using consistently, right? This was the one which we were using consistently. Now, this time, if I have to do it this way, now you might be thinking that why are you, or why do we even need this way? The reason we need this way is when we are actually doing fine tuning, which is one of the topic that we'll be studying very soon. Over there, if you are fine tuning a model which is open source, then this kind of things have to be loaded. So basically, see, in NLP, we understood tokenization. So the large language models tokenize in a certain style. For example, OpenAI might be tokenizing in a style. Your Gemini might be tokenizing in some other style. Your Hugging Face models might be having a different tokenization style. Who decides that? The creator of the LLM. So if you have to use my large language model for fine tuning it for some of your tasks, then you will have to use the same tokenization technique which I used. So the way to simplify this process is, rather than you as a user learning the new tokenization technique, they have directly given the tokenizer used dumped into the auto tokenizer class. Import the tokenizer and simply fit transform over it. That is the advantage. So this may not be very relevant here, but in a long run, this is important. So I do it this way. And then we have everything all set, all loaded. So actually, no, that was a mistake. Let me restart the session. We don't need this. I say from transformers, import auto tokenizer and auto model for sequence classification, which is coming right from here. Copied the same line. And you can see, warning, it needs the TPU runtime shutdown should be significantly improved. That's okay. Just a warning. It's not a problem as such. Then I am going to import PyTorch, because that is a framework which these guys have used. Then the government must increase the taxes on wealthy to fund universal healthcare and education for all the citizens. This is the text that I want to analyze. Now we imported the tokenizer, right? How to use it? First of all, this text that you have, right? This text has to be tokenized using the same LLM. So I am using this model. If I go to Google and paste it, this is the model which I'm using. So how does it tokenize? Well, Paris is the dash of France. And it is going to fill the mask. Right. So auto tokenizer dot from pre-train. So what will this do? The tokenizer would be loaded. Auto tokenizer not defined. I ran it here. What? Oh, I didn't get a tick over here. I don't know why. I should have got a tick here. Now I got it. Now this will run. Right. So it downloaded the tokenizer. Then the model, right? So I'm going to load the fine-tuned model for the political bias classification. So the model is trained to output three things: left, center, and right. What is that? I'll make you understand in a couple of moments. This is the model. If I give it a sentence, I like you, I love you. Right, left, and center. Right? These are the three things that will always be outputted. So what is that? We'll understand in a couple of moments. But yes, this is the model which we are loading. Now, the tokenizer instance which we created is going to take the text and tokenize it. Framework is the PyTorch. Done. Then if I say torch, which is the framework use, the tensor of 0. What am I doing is, see, I'm creating a dummy ground truth label, which is not used during the inference, but required by the model for the forward method. Label is set to 0, which means left, just to complete the expected output. So obviously, at this point of time, if you say labels, it will be just tensors of 0. Now, what am I going to do is I'm going to pass the tokenized input and the label into the model. You can see passed. Tokenizer can convert it into any number of inputs. So therefore I say star inputs. Then the outputs is what I'm unpacking. So over here, this output gives two things: loss and logits. Loss is the loss value, which is not useful because we are not training. And logits is the raw score for each class. And then I'm saying from the logits, what I want it to choose the value with the highest probability. Let's understand. If you see, what was the sentence? The government must increase taxes on the wealthy to fund universal health care and education for all the citizens. So the probability which I got, I printed, this is the left, right, and center. So what does that mean? Left leaning means it is liberal or progressive. It's given on the Hugging Face. I have not taken it from my mind. Center means it is moderate or neutral, and right means it is conservative or libertarian. So the highest probability is this, right? 0.50. This means that the input sentence is most likely right-leaning in the political tone or content. There is still some influence from left and center, but they are weaker. And that's what we understand. That's it. You can straight away do this using the earlier style, but the end goal for giving you this insight was only and only to make you understand how to do it using the, how do we usually do it when we fine tune a large language model? Like, for example, I had ran this notebook long time back. In fact, if you see the creation date is 3rd March 2024. Of course, we are not going to use this, but I don't even know whether it runs today. It was running perfectly, but this is the SMS classification dataset on which the model was fine-tuned. I just want to show you the little bit important things. Install transformers. Then you see the tokenizer I told you, same style. Then tokenizer loaded. Well, creating the dataset in the right format. These are the hyperparameters while fine-tuning. You can see sequence classification, TF trainer. All of this is coming from that only. Training arguments, tokenizer, everything passed here. Then the fine-tuning happens. All done. Or, so you need a tokenizer. That's okay. Yeah, I think this is also more aligned with that. So this is analyzing the disaster tweets. Classification and auto tokenizer, as you can see, it's used later on. That's what I'm saying. Then I'm loading the data set. Then tokenizing. Then comes the trailing, which is nothing but the fine-tuning step. The below cell takes 40 minutes to execute when T4 of GPU is enabled. Fine-tuning is costly, it's time-consuming as well. These are the results. Okay. But yes, it is used. That's exactly what I wanted to make you all realize. And this is what we understand. One more notebook. Actually, there are 3 more notebooks, but I'll take one more and get started with the theory. This is about generating Instagram captions. The model which I'm using is the GPT-2 LM head model. And the GPT-2 tokenizer. So tokenizer is going to be responsible for breaking the text and breaking it into model readable tokens. Basically, one of the basic example of tokenization can be this machine learning archive. So machine learning archive exclamation. So basically tokenizing. This is word level tokenization. In fact, this also. I love machine learning. Word level tokenization. Every word is one token. There are also techniques which are like character level tokenization, like machine learning is this. And there are some techniques like, subword level tokenization. Ma, shin, lur, ing. These are 4 tokens. Anything is possible. So we are just getting the imports, and then I'm loading the GPT-2 large model. It is again coming from Hugging Face. If you want, you can go to Google and search. This is the model. Endpoint is not available, but the model is here. You can see over here, this is a large 774 million parameter model of the GPT-2 transformer released by OpenAI. The model is pre-trained on English using the causal language modeling. That's not important at the moment. And wow, they have the entire code. From this, generate this. Okay, model loader. Hello, I'm a language model. And maximum length and this, and it is going to tell us let's use in our job. So I say load the model and pat token ID is equal to tokenizer dot end of string token ID. So in case if the things are not of the same length, then padding has to be done. Then this is the sentence which I want to be completed. Instagram caption colon road trip to, and then this sentence has to be tokenized first of all. So I'm going to say tokenizer dot encode this sentence as per the PyTorch framework. Yes, you can see how the tokens are looking like. Okay. Now, finally, I say model.generate, and I'm going to give these tokens over here. So whatever other tokens which are generated, I'm giving it over here. Max length is equal to 50, which tells the model when to stop. So 50 is 50 tokens. Then number of beams equal to 5. Now, this is something which is new. So what is number of beams? It enables the beam search decoding, which means keep the top number of beams, most likely sequences at each decoding step, which will improve the coherence and the quality, especially in the tasks like summarization or captioning. Basically, if there are 5 possible words which can be predicted, Instagram caption road trip to. So road trip to Goa, road trip to Jim Corbett, road trip to Kurg, road trip to Kanha, road trip to Mahabaleshwar, and so on. We are going to say that keep the 5 most highly probable things. So if there are 100 suggestions, always keep the first 5. So if it selects road trip to Goa, then after that for the next word will be again selected on the basis of the top 5 probabilities. So 5 is a good starting point. Higher values give better quality but are slower. Then no repeat n-gram size is equal to true. So this is going to prevent the model from repeating any 2-word phrase, right? So basically single words, 2-word phrases are like happy birthday, good morning. So 2-word phrases. So it will avoid repeating I am happy, I am happy. 2-word phrases will be avoided. You can increase this to 3 or 4 for even more diversity. And early stopping is equal to true. You know that very well. What is early stopping? So I do that and the output is saved into output. The attention mask is not set and cannot be inferred from this. As a consequence, you may observe unexpected behavior. Please use the input attention to obtain more reliable result. I don't know why is it showing that, but it never showed this earlier. Something new keeps on changing. You know that well, right? Let's go ahead with this and see if we face any such issues. These are the outputs which we don't understand. So road trip to Goa, it started something like this, right? 63106713 till 284. And then after that, it has predicted the words. Do you understand this? No. But you understood the concept. What we have to do, we have to convert it to numbers. Sorry, English. So dot decode. Road trip to New York City, NYC, NY, USA. This is the first time I ever had been on a road trip, and I'm also so glad I did it. It was so much fun. I got to 50 tokens over, friends. 50 tokens over. So the notebook is also over. 50 tokens over. The notebook is also over. So the things which are pending are these. These are the ones which are pending. When we will do it after we complete the theory. I think this continuation was needed to make you comfortable that without understanding the architecture as well, you are able to do that. A few things from what we have learned in the past. See our journey, whatever we have done so far, we started from Python, right? And After Python, we did move into advanced Python. Then we did learn machine learning. Then we went on deep learning. Inside deep learning, we started with perceptron. Then we understood artificial neural network, which is nothing but multi-layer perceptron model. Once that was over, we understood a special type of neural network, which is convolutional neural network, which consists of convolution, pool, followed by ANN. And this was mainly for image. Then we also looked into transfer learning. Then inside this deep learning only, we started looking into the text part of it, where the first thing that we looked into the text part was your yes, recurrent neural network. And this was a neural network with a loop. We know that it takes the input, it gives the output, and this is the final prediction. So, for example, if I have the input as Rahul is a good boy, or maybe let's take a input like what time it is. So initially, what goes over here is x0, which is nothing but what, and that gives over, right? Initially, what goes is x0, and it gives, or let's say x1 instead of saying 0 for convenience. Initially, what goes is x1. x1 goes, it gives O1. This O1 goes inside again with x2. So x2 and O1 goes, and you get O2. Then this x3 goes. x3 and O2 combined gives you O3. Then x4 goes. x4 and O3 combined gives you O4. Then x5 goes. x5 and O4 combined gives you O5, but that O5 will not be sent again in this link because the input is over. So that O5 goes over here, and this O5 gives the output. How? Obviously, there will be weights, no doubt about that. In the sense, there will be some weight and bias over here, right? There will be some weight and bias over here, and there will be some weight and bias over here. So this is W into X1 plus B. This is W dash into O1 plus B dash. And when this goes, it is W double dash into O5 plus B double dash, and that is how it goes. So why did we need all of these? All of these things were needed only and only for one thing, so that we are able to achieve what is called as persistence. This loop is needed to achieve persistence. That means we should be able to remember the older interactions. That is for what these things are needed. So if we are trying to summarize a movie, how does that work? How did the transformer architecture for Hugging Face worked over there? Because it is able to remember the past. So this loop was needed for that. And for your kind information, in spite of doing all these things, RNN can only and only remember previous 7 to 10 words. Right. And then they started to forget. So the issue with RNN technically was vanishing gradient problem. They cannot remember longer things. So to solve this problem, the solution which was proposed in 1997 was long short term memory. Now this architecture was something like this. There were two things over here. One is the cell state and one is the history state. I remember these are the two internal states. So cell state is like the long-term memory and history is like a short-term memory. I repeat, history, it is the short-term memory, and cell state is like the long-term memory. And that is how, after using this architecture, LSTM can remember previous 70 to 100 words. Okay. Then after that, then came the gated recurrent unit. Gated recurrent unit came somewhere in the year 2014. And just like LSTM has two internal states, this had only one internal state. And what is that? That is HI. There is no CI over here. Right. So if you look at the processing speed, GRU are relatively faster than LSTM. And if you look at performance, sometimes or in some cases, LSTM is better, and sometimes the vice versa is true. So ideally, both of them are good. You cannot really say that LSTM is bad, therefore we went for GRU. No, that is for sure. But again, this one also can remember previous 70 to 100 words. Now the ask or need is to remember even more previous words. And one of the solution which was proposed is the encoder-decoder architecture. And that is exactly what we are going to study now. This was the background of it. So now we are going to study the encoder-decoder architecture. Right. So how the things are going to be. The table of content over here, we'll start from introduction, which I have already given. Then I have prerequisites. Then we look at the bird's eye view of encoder-decoder architecture. Then we'll be looking into encoder-decoder detail architecture. Then we'll be looking into implementation, which according to me is not important. Why? Why is it not important? Because if the same thing can be done by you and me in 3 lines of code using the Hugging Face model, or maybe even using the OpenAI model, Gemini models, any models, then why the hell will I get into such a detailed implementation of classes, objects, and TensorFlow, PyTorch, all these things getting used, creation of the neural networks? Am I crazy? No one does that. Yes, you heard it right. No one does that. But we will be looking into one such implementation for sure. So that will give you a good idea about the things. All right. By the way, I forgot one important thing over here, and that is after encoder-decoder architecture, there will be also, I would say, rather drawbacks of encoder-decoder architecture. Then the solution is the attention mechanism. Then drawbacks of attention mechanism. Then the solution, which is the transformer architecture. And then going for implementation makes sense. So this is how the overall thing is going to be. Okay. Let's discuss a few things over here, and then we'll go on a break, and then we'll continue with the details. So today I intend to finish off this. In case if something remains, then tomorrow. But at least an implementation won't be done, but at least till point number 8, I think we should be able to do that. Not sure. Let's see. Depends. So now we have looked into RNNs, we have looked into encoder-decoder architecture, and we have realized one thing for sure. RNNs were found to be very effective in solving complex sequence related problems. Given a large amount of data, they have real-time applications in natural language processing problems, time series forecasting. So I'm talking specifically about the sequence to sequence models. Now, don't forget this name ever. Sequence to sequence is the best example I can say is machine translation. Sequence is what? Sequence is nothing but a sentence. Don't open. Right over here. This is French translated to English. sequence to sequence, or another sequence, lengthy text summarized to short, or chatbot, how are you doing today? And it is responding over here. So sequence to sequence are special class of the RNNs typically used but not restricted to solve complex language related problems like machine translation, question answering, creation of the chatbots, text summarization, etc. So the purpose of this deck is to give you a detailed explanation on how these sequence to sequence models are built and to give you intuitive understanding of how they can solve the complex task. So today, for making our job simple, we will be looking into the problem of machine translation, translating one language to another. I repeat, I'm specifically looking into machine translation, and the example would be to translate English to Marathi. You don't know Marathi, that's my lookout. You don't have to worry about it, and you don't really need to know it. See, even if I take English to Chinese, you would be in that much mystery only, right? So some of them don't understand Hindi, so English to Hindi is also a problem. So that you leave to me, right? That's my job. Right. So, yes. So we are going to do this with the help of a simple running example of English to Marathi. And I repeat, even if you do not understand anything in the architecture, it is 100% completely fine, because without that also you understood everything from Hugging Face. What is left out then? Understanding. There is nothing left out. But yes, I assure you, you will understand the architecture as well. See, it's not that in the interviews they don't ask about architecture at all. Of course, they will ask. And whatever they will ask, that much I will cover it for you. What they won't ask, we will also not get into that. In fact, your Simplilearn deck is going only up to a depth of level 3 on 10. I'll be going to a depth of 7 on 10. Should be more than sufficient for you. You know, whatever I teach, then you go and compare with the available deck. You will yourself realize what I mean. Okay. Then, coming on to the prerequisites. Prerequisites over here, I assume that you know the fundamentals of machine learning, the fundamentals of neural network. It is also assumed that you have high school level knowledge of linear algebra and probability. It is also expected that you have working knowledge of LSTM and GRU. These are the only prerequisites that we have. Right. Now with this, we are good to get started with our encoder-decoder architecture. And this is the bird's eye view of it. I'll not get into the details of it right now. We will better go on a break, but I want to definitely tell you one thing for sure. You know, don't take these to be something landing from the space. This is not new to you. That means, do you already know encoder-decoder architecture? Yes. You already know what is an encoder and a decoder. You know why? Because who is an encoder? An encoder is nothing but LSTM. And who is a decoder? You know, do you recall one thing? See, using neural networks, recurrent neural networks were built. Using RNN architecture, LSTM was built. Using RNN's architecture only, GRU was built. Using them, encoder-decoder was built. Using encoder-decoder, the encoder-decoder with attention mechanism is built. And using this, the transformer architecture is built. Yes, this is very important. Using neural networks, RNN is built. Using RNN, these are built. Using this, you build this. Using this, you build this. Using this, you build this. So, I would like to say over here that the encoder decoder is nothing but an LSTM. Hey, by the way, if both of them are LSTMs, it's fine. Or both of them can be GRUs. One LSTM, one GRU, no. Either both will be LSTMs or both will be GRUs. Either both will be LSTMs or both will be GRUs. For my example, as of now, I'm assuming as LSTM, and later on I'll be changing that with GRU as well to give you a feel of that. But for now, it is LSTM only. Why this is important? What both of them have to be same. This is what I call as vision. You know, Sandeep, you have a very good vision. But I know I should not conclude it, but I should also say that you have less patience because the answer to your question is there in the architecture only, which I'll be discussing very soon. Right. So your question will be by default answered when we complete with the architecture. Okay. So who is the encoder? The encoder is nothing but the LSTM. And decoder is also LSTM. Or both of them are GRUs. Okay. Now, as I told you, we are considering the problem to convert English to Marathi. So recall the good old machine learning days. What we used to have, see, this English is the independent variable and Marathi is the dependent variable. Let's say I have sentence 1, 2, 3, 4 up to 1000 sentences. I divide it into two parts. The first is the train. The next is the test. Our job is very simple to understand the relationship between English and Marathi. And then to predict on this. So this is where you get the prediction. This is the actual. Compare the actual and predicted and find out the accuracy. Similarly, I can also predict on this, right? This is the actual and I can predict on this. I can compare this and calculate the accuracy. This is going to be the accuracy on the train. This will be the accuracy on the test. So you will be having an English sentence. Tell me over here, friends, have we discussed count vectorizer, DF, IDF, word embedding model? All of these are used for converting your text to numbers or vectors. Did we discuss these techniques in the past? I think we covered notebooks also on that. So as far as I remember, the answer is yes, but I'm still confirming because I'm aligned with so many cohorts. So I don't want the confusion to override. So did we cover count vectorizer, TF-IDF, word embeddings earlier in our previous classes? Yes or no? They are used to convert text to numbers. I think when I covered LSTM as well, at that time we covered the word embeddings. This is what I remember. Count vectorizer also, I might have definitely explained you. As per me, I think I'm 99.9% sure, but I want to hear it from you as well. No worries. Some of them are not, most of them are not able to recall, and some of them can. No problem. Chalo, let's get started. So here I say, okay, encoder. This is the English sentence and this is the Marathi sentence. We are talking about training part. And for training, I'm going to use this red ink. So your input English sentence goes as input. See this lines, I've maintained the same thing. It goes over here and there is a technique like word embedding whose job is to convert text to vector. There is a technique like word embedding whose job is to convert text to vector. See, this was the text data and later on we converted to sequences and then these sequences we padded and converted everything to the same length, but these were given to the word embedding to extract the features. You remember this? We had created the input layer. I had covered this notebook. This input layer is there. Then it is given to the embedding layer for extracting 50 features. And then we had the LSTM, then the hidden layer, activation, dropout, hidden output and activation. So this was the word embedding technique that we discussed, where the words like man, king, etc., they are converted to the vector form by extracting features. In very simple words, if I have to conclude, these techniques were important for converting text to numbers. These techniques were important for converting text to numbers. So the English sentence is first word embedded, that is, it is converted from text to numbers, and then it goes to the encoder LSTM. And what it is going to do, encoder LSTM is going to take this vector and it is going to understand the meaning of part. So always remember, the encoder part is nothing but natural language understanding. Or in simple words, I can say that it is responsible for summarization. Given the first English sentence, it takes that, converts it to vector form, and then summarizes that. And the summarization is what? The summarization is what? It is nothing but these two things, CI and HI, which comes out of the LSTM. So what comes outside is HI and CI. Technically, we call it as the internal state vector or the thought vector or the context vector. You can call it by any name. In simple words, it is the understanding of this, or it is the summarization. Like if I'm speaking something, what is the time right now? Right now, the time is 11:41. Right from 9:05 a.m. till 11:41 a.m., whatever I have spoken, do you remember each and every line of that? No. But did you understand what I teach? Yes. That's kind of the summarization or the natural language understanding. So who are you? You are an encoder. Whatever I'm speaking, you are understanding it and storing kind of a summary in your brain. And that is what is saved in the internal states, HI and CI of the LSTM, which is nothing but called as internal state vector or thought vector, or the context vector. Then this HICI are given to the decoder. Now, what is the decoder going to do? The decoder will take this Marathi sentence. This Marathi sentence is by backslashes. Let me put that. Then after that, this is also word embedded. So obviously Marathi is a natural language. You have to convert it back to a vector form. Done. Then this and this. This is what we do. You understand the relationship between this summarization and the Marathi sentence in the vector form. All of this is happening purely in terms of numbers. The numbers or the image which I shared in the chat box, to which 6 of you gave a thumbs up. So machines are not understanding English. Machines are not understanding Marathi. Machines are just mapping the statistical relationship between the vectors. Don't forget that. So machines are just mapping those relationships. And this completes the training. No output. Obviously, so training is what? Training is just understanding English, Marathi, English, Marathi, English, Marathi, English, Marathi for all the sentences. That's it. That is training. Understanding English and Marathi is nothing but the training. Then what you do? Now we are getting into the inference mode. And all of this is the bird's eye view. This is not the architecture in total. The inference is in the violet coloring. So this first sentence, right? This first sentence is given as input. Then this is also word embedded, yes. So whatever I'm writing in the violet coloring or purple coloring, that is going to be the unseen sentence. So we understood what happens in between all the English Marathi sentences on the trained data set. On the test data set, the first sentence is taken. Training is done. Training is already done. So this unseen sentence is given as input. It is word embedded. And then what does the encoder do? Again, the same job. Encoder is still doing the same job. So what is encoder going to do? I'll write it in my violet ink once again. Is the summarization, which means you again get over here HI and CI, which are over here. Then using this, it is going to predict what? Equivalent Marathi translation. So for this will be the prediction. This will be the actual. In the same way you do it for all the unseen sentence, you get all predictions, all actuals, and then you can compare that and calculate the accuracy. So yes, this is how the training and the inference happens at a very high level. I repeat the entire thing once again for you. During training, you only understand the relationship between English and Marathi. And during inference, because it has already understood, it is time for you to infer. So you focus on the inference over there. So this is what we do. So to repeat once again, we start with English sentence, word embedded during training. Then the summarization is available in HICI, which is passed here at the decoder. Then we take the Marathi sentence, word embedded. That vector and the HICI vectors, they are used for understanding and mapping the statistical relationship between the tokens. This happens in the same way for every English and Marathi sentence. Training done. Then in the testing part, unseen sentence here, word embedded, summarization happened, and using this summary, it starts generating the output. So did you, I don't know, you observed it or not, but One thing I certainly would like to highlight over here is the let's understand what is the encoder doing during training and what is it doing during inference. During training, it was doing summarization. During inference as well, it was still doing the summarization only. On the other side, decoder during the training part was doing what? It was mapping the English to Marathi relationship. And during inference, it was taking that and generating the output. So, generating translations. Yes, this is how the things vary. This is exactly how the things vary. Encoder is doing the same job in both the cases, but decoder is doing different things at different places. Encoder is doing the same job, but decoder is doing the different things. Okay. Now that you understood the bird's eye view of it, remember this is the bird's eye view, summarization. Summarization of what we have understood. Decoder does not do the summarization. No, that's exactly what I did not write. So what I wrote, that only thing happens. Why will decoder do the summarization? Decoder is doing the mapping of English to Marathi understanding, and next time it is doing the generation. It is the encoder's job to understand LSTM. What? Why LSTM? Then what it should be? Why LSTM over there? Why not? Then what it should be? Okay, let me ask it the other way around. What it should be, Ramani, in that case? Haha. What it should be, but I understood it is doing just mapping, not generating HICI. Sorry, I'm not understanding that. What it should be, the decoder. Oh, sorry. By the way, here it is generating HICI, and obviously if this is capable of generating output, this will also be generating output, but we are discarding it. In the same way, here, when it is taking, it is giving HICI. When input is coming, it is giving HICI. We are going to discard it because the purpose is different. It will be there. We will be discarding it. In the encoder part, the output will be discarded. In the same way, in the decoder part, the HICI will be discarded. But don't come to an conclusion so early, Ramani, because this is the bird's eye view of the architecture. This is what we are going to explore now. Okay, we'll be exploring that. Cool. Just give me 1 minute, everyone. Many people have confusions when we get to point number 4. Right? We just discussed the point number 3 to make you understand what is the encoder doing and what is the decoder doing during training and during inference. When we start with the point number 4, I think encoder, LSTM, and I'm talking about the training part. So how does that happen? See, now over here, I want to give you a brief overview of the main components of the encoder-decoder architecture. And I'm going to keep this understanding very intuitive without getting into the mathematical arena to unnecessarily confuse you. The LSTM, the encoder LSTM reads one sequence after other. So if the input is a sequence of length k, then the LSTM reads it in k time steps. Rahul is a good boy. what time it is. I am loving this place because it is awesome. So every sentence has a different length, so that K value is variable. Over here, you have xi. Xi is the input sequence at each time step. Then you have hi and ci. These are the internal states, right? So combined together, we call them as internal states, history state and the cell state, or hidden state and the cell state. And yi is called as the output sequence. Now, technically, your xi, hi, ci, yi, what are these? These technically are nothing but vectors of floating point numbers. Now, let's try to map it all in the context of our problem. Don't forget, our problem is to translate English sentence to its equivalent Marathi sentence. And for this, I'm going to consider a very simple example. Assume the English sentence that I have is Rahul is a good boy. And the equivalent Marathi sentence which I have is Rahul Changla, which means good, Mulga, which means boy, Ahe, which means is. Rahul Changla Mulga Ahe. I have mapped the language so that the confusion is not there. Rahul Changla means good, Mulga means boy, Ahe means is. There is no translation for O. Needed also. So this is what we have. So now just focus on the English sentence. Now can be seen either a sequence of words or a sequence of characters. For example, if I say sequence of words, then Rahul is a word, is a word, 1, 2, 3, 4, 5, 5 words. Or if I'm considering a sentence as a sequence of characters, then this is first character, second, third, fourth, fifth, sixth, seventh, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19 characters. So I can consider this as a sequence of 5 words or 19 characters. If I'm doing character wise, it is called as character level translation. But I am going to do it word wise because breaking the sentence by word is more common in real world applications. So we call this as word level neural machine translation. Word level neural machine translation. So in this case, my x1 is Rahul, x2 is Ace, x3, x4, x5, x1, x2, x3, x4, x5. But one question that we must answer is how do we represent xi as a vector? Because it is right now in English form. Over there, we had studied various word embedding techniques which convert a word into a fixed length vector. I'm assuming all of you are already aware of this concept of word embeddings. We won't be covering this topic in detail. If you have forgotten that, you can watch the recordings. For now, just assume this is more than sufficient to assume that it is a technique to convert English to number. That's it. So that is how it happens. So Rahul will be word embedded and given as input. Then is will be word embedded and given as input. Similarly, this, and this. This is what we are doing. Then what happens? Understand this now. The Rahul is word embedded, so it is now in the vector form. It is given to the LSTM's unit number 1 and it produces H1C1. This H1C1 is added with this and it produces H2C2. By the way, it also produces the output Y1. It produces the output Y2. Using this 2, adding this, it produces Y3 and H3C3. Adding this, it produces Y4, H4, C4. Adding this, it produces Y5 and H5, C5. But now understand this. Before I discuss more on this, I want to tell you that what is H3C3 or what is H1C1 or what is H2C2? Well, let's consider H3C3. H3C3 is the summary of Rahul is a. H4C4 is the summary of Rahul is a good. H2C2 is the summary of Rahul is. H5C5 is the summary of the entire English sentence. So friends, what is HICI in very simple words? Right? HICI is what? What is HICI? HICI basically remember what the LSTM has read or learned till now. They remember what the LSTM has read or learned till now. This is what it is. And then what with Ys? Y1, Y2, Y3. I did say the outputs are discarded. Why are you discarding it? Right? Why are you discarding it? See, what is Yi? See, more specifically in case of a word level language model, each Yi is actually a probability distribution over the entire vocabulary, which is generated by using a softmax activation function. So, depending on the context of the problem, they might sometimes be used and sometimes be discarded. In our case, we have nothing to output unless we have read the entire English sentence. We have nothing to output unless we have read the entire English sentence. Because we will be starting to generate our Marathi sentence only after reading the entire English sentence, we are discarding the YI of the encoder. We are discarding the YI of the encoder. Also, we understood H4C4 is the summary of Rahul is a good. H5C5 is the summary of entire sentence. H1C1 is the summary of Rahul. What is H0C0? What is H0C0? You cannot skip writing H0C0 because this is like running in a for loop. You have to write something. So something means what can I do? I can initialize it to 0 or maybe some random vector because it has to go in a loop and it will not happen for one time. It is a neural network which will run for multiple times. For now, we are just discussing one part of it, which is nothing but our encoder, which is nothing but our encoder. As simple as that. So that is how the training of encoder LSTM occurs. This is how training of encoder LSTM happens. So to summarize what we have learned so far is we'll be reading the input sequence word by word and we'll preserve the internal state of the LSTM network generated after the last time step, which is HKCK, assuming that the sentence has K words. And these vectors are called as the encodings of the same input sequence because they encode or summarize the entire input in the vector form. Since we will be generating, or since we'll start generating the output once we have read the entire sequence, then the output of the encoder at each time step will be discarded. If you are more interested in understanding what are the types of vectors xi, hi, ci, yi, what are their shapes, what are their sizes, then everything has an answer to the same topic, which is LSTM. If you understand LSTM, you understand these things by default. As simple as that. But you don't really need to, because we have understood that this translation job can be done in just 3 lines of code. As simple as so here. Now, after that, yes, here, we skip this. This is the decoder LSTM. Now what happens? Remember from the previous slide, which is this, we got H5C5. H5C5 is nothing but the summary of the entire input sequence. And if you remember from the further previous slide, the summary of the entire English sentence is here, which goes as input to the decoder, and decoder does the understanding. So here our H5C5, which came from the encoder, gets copied into H0C0 as the initial state. So earlier in encoder, H0C0 was randomly initialized, but here we are copying the summary into H0C0. So the initial states of the decoder are the final states of the encoder. Done. Then one thing I want to tell you, for some technical reason, which I don't want to disclose right now, but I add 2 special tokens, start and end over here. Only for Marathi, I add 2 special tokens, which is start and end, for some reason, which we will discuss later. You can see I'm using the red ink, which means I'm still in the training part. When I go for a violet ink or purple ink, I'll be going into the inference part. Right now, we are in the training part. For some technical reason, I am adding start and end. So what happens is this start, because now what are we doing? Decoder is doing what? The decoder is doing nothing but English to Marathi mapping. So the start token is first word embedded, and we concatenate this summary with this, and it generates prediction Y1. Start and H0C0 are responsible for generating prediction. We are still in the training phase. That means the training is not over, and without training is over, you are asking it to generate the prediction, which means the prediction is likely to be wrong. So I get a prediction. The first thing which I actually want, is Rahul. Right? Obviously, Rahul in vector form, by the way, it is not in Marathi, but I'm writing over here in Marathi so that it is easy for us to understand. We want it to ideally predict the vector for Rahul, and what it predicted is Y1. Now, in the very first epoch, the vector inside Y1 and the vector of Rahul, if they are same, then the error would be 0. But if they are not same, then error will be large. And in the very first epoch, obviously the error is likely to be large. It may not understand that the first word to be predicted is actually this. So we calculate that error, and what are we doing is we are sending the actual Rahul here. Now, this is something which is very much contradictory to what you have learned. If you get back to what I said is in the RNNs. What were we doing? What time it is? So what was given x1 is what was given, and it generated O1. This O1 used to go again. O1 used to go again along with x2. X2 and O1 used to give O2. Then x3 and O2 used to give O3. So basically, whatever was the output was going once again into the neural network. I repeat, whatever was the output was once again used to enter the neural network. However, if you observe here, the output is y1 na. The y1 is the output, which is the prediction. Then technically it should send y1 here. Yes or no? Output goes back. This is what we learned in RNN, LSTM, and GRU. So here also y1 should go down. So here, friends, my kid is 7 years old, and in his school, they have asked to recite a poem in the assembly on my grandparents. Now, there are two ways in which I can teach him. I can say that let's say the first way, I say, go and study this poem, and then I'll ask you. So my kid goes, he studies the poem and says, Papa, I'm done. And then I say, okay, now start reciting. And he starts speaking. From early in the morning until I go to sleep, love me in very special way. Sometimes it is tea and crackers, sometimes just a hug when I am scared. I love to hear their stories, the past and where they are, and I know their hearts filled for me with ending love. And then I say, Beta, see, you missed out this, you missed out this, then here you missed out this, then you missed out this, then you missed out this, then you missed out this. Just a 7-year-old kid, huh? And you missed out this and you missed out this. I say, you understood your mistakes? Now go and study once again. I'll take it once again. Hmm? Then he goes again, he studies, and then he comes back and recite. And every time I follow the same approach. That is approach number one. Second approach, I say that go and study this poem, and then he is reciting. Now he is reciting. I say, okay. He says, from early in the morning until I go to sleep day. I say, no, 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 beta, no. Until I go to sleep each day. Okay. Each day. Continue. I know my grandparents love me in a special, I say, no, in a very special way. Sometimes it is tea and crackers, sometimes walk. I say no, sometimes a walk in the park. Sometimes it is just a hug. I say no, no. When I am scared and in the dark. Now you tell me, among the two approaches, way one is where I asked him to study. I asked him to narrate the poem, and then I tell him that, okay, these all are the mistakes. Go and study again. And I followed this approach again and again. Second is where I was correcting my child impromptu while he was reciting the poem. Which approach, as per you, would be more helpful? The first one or the second one? For making a child understand, which approach would be most helpful? Second one, right? Yes. And that is exactly the catch. Because I was correcting my child the moment he was going wrong, the chances of he going off track are much lesser. For example, he starts saying from early in the morning until I go to sleep day. He missed out one word. If I don't interrupt him and correct him, he can say until I go to sleep day. I know way. Sometimes it's tea, and in the dark, I love to hear their past, where they are from, never ending love. What happened is Because he lost the track from here, he lost the further track as well. So, because it's like, imagine this to be like a maze. If you go into a wrong track, then you are permanently trapped. It's something like that. Whereas if you correct the child there and then itself, the chances of the child learning faster are higher. And now here I'm exactly doing the same thing. In the RNN, the prediction was sent again. But what am I doing over here is I give the start, it is word embedded, added with the summary, and it generates the prediction y1. The prediction is likely to be wrong because we are in the very first epoch. So I compare with the actual and I calculate the error, and then I don't send y1 but I send Rahul. So I'm correcting the model there and then itself. But before correcting, I'm also capturing the error so that I know how much to improve. Then this Rahul is again word embedded and it is added with this H1C1 and it predicts Y2. This is the prediction and this is the actual. I again calculate error 2 and this Changla is what I give over here. So basically what is the advantage which we get by giving the prediction is we are avoiding the model to go off track. Because I'm feeding the right words at the right time, the chances of the model going off track are less. That means the learning will be faster. That means the learning will be faster. This is one of the biggest advantage. Now this Changla is added with H2C2 to give Y3 and Mulga. I calculate E3. Then this Mulga is given over here. This Mulga is added with H3C3. So Ramani, we are not purely discarding. We are actually using the internal states. So adding this, you get E4, you calculate the error. This E4, sorry, this AHE is sent down. Obviously, this is also word embedded, added with H4C4, and you get this, and the actual is END. Now, friends, because after calculating the error, it was END which has to be sent again. But what is END? END means khatam, finish. That is the reason we added it. So irrespective of whatever be the length of the sentence, the moment END comes, we know that this loop has to break. That was the end goal. That was the main goal of adding the END. So start was for ensuring we can start it, and END is to know when to stop it. So ideally, whenever you are generating a translation, you will never ever in your life know what will be the first word. So you always start with start and you will never know when to stop. So you end with end. That was the reason we added these tokens. If E is more than what E is more, this E, then it will go on. No? We know the prediction has to end over here because we are in the training phase. We know the translation for Rahul is a good boy is Rahul Changla Mulga Ahe. So obviously after Ahe it will be END only. If the translation is more lengthier, then this will go on. This Y4, Y5, Y6, Y7, Y8, Y9 till the time END comes. Then, I think now I got your question, Raj. What happens after that? Whatever happened was for the very first sentence. Raj, I'm coming to you in a minute. Now this H5, C5, because END is coming, H5, C5 is of no use. So I'm going to discard H5, C5. Then what I do? Then I calculate the total error. E1, 2, 3, 4, 5 ka summation. And you remember neural network, what is the end goal? Our end goal is always to minimize the error. How does that happen? Array, neural network, forward propagation, backward propagation, every time keep on repeating the same process, not for the only sentence Rahul is a good boy, but for all the sentences. This was the translation process for just one sentence. If you come back, what I did was Rahul is a good boy, Rahul changla mulka hai. One sentence done, you calculate total error. You do it for all the 800 sentences in the same way. You do it for all the 800 sentences in the same way. Then the total error that you get, you go for backward propagation and you try to adjust the weights. And then again repeat it for several epochs. If you're training it, let's say for 10 epochs, 15 epochs, you will do that till the error is minimized. You will do that till the error is minimized, and that is exactly what is the significance of training. You keep on doing this. Now, the chances of your error to be minimum faster are higher. The error will become less relatively faster because you are using teacher forcing, which means the input at each time step are the actual output and not the predicted output. This is called as teacher forcing, which helps in faster and efficient training of the network. I said it over here also. These outputs at each step, right? These are the outputs at each step that the decoder will be trained to generate through the process of back propagation, and using the appropriate loss function, you try to minimize this. Clear, Raj? Why did we calculate ease? All these things we are using. Yes, and this completes the training, which is going to now change the color to a violeting because I want to go for inference. Got it, right? Yes. Now, you know what? The most important thing is done. The most important thing is done. Now we are going to get into the inference part. So, by the way, this is the overall thing. Connecting all. So this is training. This is the encoder LSTM. And this is the decoder LSTM. So this Rahul is a good boy, as you can see, is given as input one by one. What you get is H5C5, which is nothing but the thought vector or the context vector or the internal state vector, which goes as input. Start, of course, it's word embedded. Added with that, you get some prediction, and you have the actual. This actually sent here. Added with this, you get y2. The changla is sent here. This keeps on going on and on till you get this. Then you summarize and calculate the total error, which is the end goal to minimize it. And then the final H5C5 over here, we are discarding it. Now, did you notice over here, guys? Here also you are getting Y1, Y2, Y3, Y4, Y5. Just like here you are getting Y1, Y2, Y3, Y4, Y5. Here we discarded that because they were of no use. But here we use Y1, Y2, Y3, Y4, Y5 for calculating the errors and then minimizing it during the back propagation. So encoder is not doing that, but decoder is doing this because decoder's job is to map the things. Yes. That's the holistic view of encoder-decoder. Now we get into inference part. Now, inference. And this is the encoder LSTM. What is it going to do? Array, go back. In both the cases, it is doing the same job of summarization. So I didn't invest a lot of time. It's going to do exactly the same thing what it was doing earlier. Simple. So the input Rahul is a good boy given one by one from H0 C0. One by one, it generated H5 C5. It is not shown, but obviously it happens in 5 time steps. And what you get is the thought vector or the context vector or the internal state vector. It is just that that entire loop, which is kind of this entire thing, is summarized as one single block. But essentially, this is exactly what happens like earlier. So nothing new to explain. So we are good to start with this. Then, after that, now we are getting into inference, and this is the decoder LSTM. So earlier it was encoder, right? Now it is decoder. Now the HKCK. What is HKCK? This is nothing but H5C5, which is coming from the encoder. It is copied into H0 C0. Then what happens? Now training is done. Training is done. That means the machine already knows the relationship of how to map English to Marathi. So it is now capable of generating Marathi translations. So what we do is our first sentence. Now, what is the first sentence? So I am over here assuming. You also please assume I did not get any other sentence. So you also assume that Rahul is a good boy is an unseen sentence. Please assume that the network never saw this sentence. So what will happen during the inference part? Because training is done, it will first of all convert it to the summary form. Then it's time to convert it into Marathi. So now that summary is given into H0 C0 and I just give start. Of course, no doubt about it, word embedding happens. Start is added with H0 C0 to straight away generate prediction. This time, do I have anything actual to compare? No, training is done. So you don't have any actual. Imagine you are actually opening Google Translate and asking it to translate Rahul is a good boy. Does it refer anywhere? No, training is done. It will just translate. So now it is actually in the translation phase. Taking this start in the embedded form and H0 C0, it generates the prediction. No actual available, only prediction generated. This is the time step 1. What will happen in the second time step? The prediction will be given as input exactly how it is to happen in RNN. No teacher forcing during inference. So the prediction is what is given as input at time step 2, and this H1C1 obviously this generates H1C1. So this H1C1 and Rahul, this H1C1 and Rahul are given as input in time step 2 to predict this. Let me call it as the next prediction. This Changla and H2C2. This will be given in the next time step. So at time step 3, H2C2 and Changla, they are given, and this is the next prediction. It gives Mulga and H3C3. At time step 4, H3C3 and Mulga will be given. You can see H3C3 and Mulga are given. And it predicts this and H4. Now I have a very important concern. This process is going to repeat for how long? Tell me, this process will repeat for how long? I'm bored of time step 1, 2, 3, 4 again and again coming into picture. So tell me, according to you, how long will this process keep on repeating? At time step 4, that is awesome. This is another reason for adding END. So the moment it predicts END, translation is over. The moment it predicts END, the translation is over. So at time step 5, it got I and this, and because the next prediction is END, we stop. Now see, this is a very goody scenario where you expected it to predict Rahul Changla Mulka Ahe and it predicted. But let me tell you, friends, that the things are not that straightforward. Yes, you heard it right. The things are not that straightforward every time. I am going to prove this to you now. I'm going to prove this to you that the things are not always so straightforward that we are thinking. This is the example of neural machine translation with attention mechanism. In our code, I have yet not added any attention mechanism. We will look into that after some time. But see, this is with attention mechanism, and I want to tell you all that for running this notebook, it took me total 28 hours. Yes, you heard it right. It took me a total time of 28 hours for creating a neural machine translation, and basically it is translating English to Portuguese. Yes, you heard it right. So you can just look into all of these steps. First thing, I loaded the data set. For.txt is one of the data available over here, which we just loaded it. There are total 1,68,903 records. So pre-processing part is done on English, lower casing, removing punctuations, etc. things. Similarly on Portuguese as well. And then I just generated one sentence pair. Here I added start and end before English and Portuguese both. You can skip that start and end before English, but yes, this is what we did. Then tokenization, padding, done. Then doing the 80-20 split, train test split, done. Then creating GRU, right? So we did it using LSTM. You can also do it using GRUs. So this is done using GRU. So you can see the encoder is created. Decoder is created. There is also attention mechanism used. We will see into this later. Then both of them are called. The optimizer Adam loss function is the sparse softmax categorical cross entropy with logits. Training. This is not 4 hours. And we started training on it. This is the loss. Then this is the function actually to evaluate and predict. So you can see over here the input. He stopped to smoke, and the predicted translation is this, and the actual is this. We don't understand Portuguese. So what I'll do is English to Portuguese. So I say Google Translate. We are doing this. Then he stopped to smoke. He stopped smoking. And the prediction what we got was he stopped to smoke. Let's try once again. Tom won't write. Tom won't try. This is the actual. And the prediction is Tom won't prove it. You can see over here, it is wrong. Tom won't prove it. Similarly, the third one, he is Tom. It looks correct, but let's see. Prediction is what? He is Tom. And the actual is he is Tom. Okay. Try one more. They brush their teeth twice a day. They cut the floss twice a day. You can see the prediction is wrong. And the actual is what? They brush their teeth twice a day. So after training it even for 28 hours, this is the status, right? Therefore, we don't train it from the scratch. It's of no use to us because how many sentences did I use here for training? I use around 1,68,000 sentences, right? 1,68,000. After that, I'm getting these results. If you really want to get good results, then you need millions of sentences. This is far more lesser. The transformer architecture, which already exists, is already trained on millions of sentences. The LLMs that we used on the Hugging Face, they are already trained on so many things. Therefore, the translation, summarization, sentiment analysis was so awesome. And therefore, that is preferred over these all things. Hence, everyone uses Hugging Face, OpenAI API to do whatever they have to without worrying about all these things. Okay. Next, what about the grammar? Example, Rahul is a good boy. Rahul ahe changla mulga. Now, see, you are still thinking about it like a human, Raj. You should think like a machine. Machine is not ideally understanding the relationship between English and Marathi. No, it is understanding the relationship between English vector and Marathi vector. Vector understanding is what it is doing. And let me also tell you that the result that you are seeing on the screen is a magic of training it for 28 hours, which is far lesser than what originally transformer models are. If you look into ChatGPT 3.5, it was trained for 3 months continuously, and it was trained using a total of 6,000 GPUs. We are nowhere. So you need huge data, you need huge processing power, and you need huge memory. Then you start getting decent output, right? So we took the problem of translating English to Marathi. So I remember the English sentence was Rahul is a good boy. And the Marathi sentence was Rahul Changla, which means good, Mulga, which means boy, Ahe, which means is. And for convenience, we added the start and the end tokens over here. Like, then the thing is, the problem was English to Marathi translation. We divided it into two parts, train and test. During training, the job was just to understand the relationship between English to Marathi. And during testing, the job was to take this unseen data and predict on it, and then compare this prediction with the actual and calculate the accuracy. So initially we gave the very first English sentence over here during training, and this was LSTM, which did the job of summarization, and that summary was available in the form of internal states HICI, which are called as context vector or thought vector or internal state vector, which go in over here. And then the corresponding Marathi input was going over here. Of course, it goes without saying that there is word embedding which converts English to vector form. That goes without saying. And then this vector and this vector's statistical token pattern matching happens over here. And that is how training happens for every sentence. Then for inference, I said the first unseen sentence is being sent from here. Of course, there will be a word embedding. Again, summarization happens. What you get is the internal state vector, which is sent over here. And straight away, using this, we get the Y predicted. This was what was happening. And when we dived into the little details of it, this was exactly where we were looking into the training part, where Rahul is a good boy was the input which went step by step, and we got H5C5 as the output, which is nothing but the thought vector or context vector or the internal state vector. And by the way, obviously here also word embedding is there, that goes without saying. So for example, here H0C0 was randomly initialized. H1C1 was summary of Rahul. H2C2 was summary of Rahul is. H3C3 was summary of Rahul is a. H4C4 is summary of Rahul is a good. And H5C5 was summary of the entire sentence. And all the outputs over here, Y1, Y2, Y3, Y4, Y5 were discarded because they are of no use. What will you do with the outputs unless and until the entire English sentence has been understood by the LSTM? It's of no use. That's why we discard it. So don't forget over here, everywhere we are using the LSTM. And then this are given as input, H0C0. This gets copied into this. The start is, of course, word embedded, and these things are concatenated. And after concatenation, what you get over here is going to be the prediction. All right, that is the prediction. And you also get, or you also have the actual over here. Comparing this to, we were calculating error. Similarly, you get H1C1. Then this actually sent down, and that concept is called as teacher forcing. These are concatenated. You get this and you get the prediction. Again, you calculate error, and this process goes on and on till you get Wi-Fi hat, which is expected to be END. Teacher forcing stops. We have E5. We sum up all the errors, and the job is to what? Minimize the error. Just like here also you get H5C5. Earlier this H5C5 was sent to the decoder, but now here H5C5 is discarded and the outputs are used. So depending on the application, sometimes this can be used, sometimes this can be used in the encoder, decoder respectively. Then after that, we went into inference. During inference, our input sentence, which is assumed to be an unseen sentence, is given, and the encoder does exactly the same thing to give H5C5, which is nothing but the thought vector, context vector, or the internal state vector, which gets copied into this. Start vector is word embedded. Both of these are concatenated, and what you get is the prediction. This prediction is sent as it is down, and of course you get H1C1 also. These two are concatenated, and you get this. And this goes on and on till you get END. Because we get END, we understand that it is time to stop generating because the actual translation of Marathi is already available. And the quality of this purely depends on the quality of the training. Here I have taken a very good example or a very good scenario, I would say, where we are getting the best output, but that may not be the scenario in every case. That is one thing. Okay. This is what we have understood. Now, after this, let's talk about something which is a little important over here. Now, what were we doing? We were sending, during the training, we were sending H5C5 to H0C0. Right? This was sent over here. Now, listen to my concern. Consider a scenario where I have, let's say I have a task. So there is a task. What I do is I have a book on machine learning. Okay. And I have two students. The first student is Ram and the second student is Sham. What I do is I give them a book on machine learning and ask them a question. And that question is, what is sparse categorical cross entropy? I'm sure you have heard about this. So what does Ram do? Ram, step one, he takes the book. Step two, he reads the whole book and then gives answer. So he comes back with an answer. Sham does little differently. So what Sham does is Sham takes the book, he goes to the index. On the index, he looks for the chapter on losses. Once he found that, he looks for the page number. Then inside that page number, he looks for the topic of sparse categorical cross entropies, page number specifically. Then he goes to that page number and then gives answer. Now you tell me among these students, you tell me among these students, who according to you is better? Is it Ram or is it Sham? Sham is better. Okay, I agree that Sham is better. And the reason why he is better is because no doubt he will be fast because he takes less time undoubtedly yes. And also one more important thing is his answer or his response will be more coherent. Coherent means as expected to the point. Because number one, when Ram reads the whole book, first of all, he is going to take more than a month to read the complete book and then come back with an answer. And because he has read so much, he might have forgotten some of the earlier parts. Therefore, his response might be scattered. On the other hand, Sham's response will be to the point. Therefore, I say the Sham's response will be more coherent. So, why was Sham able to get this? So, question is, what did Sham do differently? Can I say he focused his attention where needed, and therefore he was able to answer better? Can I say that? He focused his attention where needed, and therefore he was able to answer better. This is an important point. Let's look into this. Now consider a scenario. What am I talking about is I am talking about drawback of encoder-decoder architecture. Imagine you are in a 5-day training. You are in a 5-day training. 5 days training. Now, this is some information which I taught you on the day 1 of the training. This is day 2. So on day 1, whatever I taught you, the summary of that is saved inside H1C1. On day 2, whatever I taught you, the summary of that is saved inside H2C2. But wait a minute, it does not mean that you have forgotten about day 1. H2C2 is summary of day 1 and day 2. On day 3, whatever I taught you, that information along with day 1, day 2 is saved inside H3C3. So basically, H5C5 is the information that you learned on the 5th day along with the earlier information, and only this information was sent here. So, you know what I want to conclude over here is in H5C5, good and boy will have kind of a strong presence, and Rahul and Is will kind of have less presence, because you only admitted that you end up forgetting the things of 11th October as compared to 25th October. So if it's a 5-day training, day 1, 2, 3, 4, 5, then obviously the last few days training will be very strongly available inside H5C5, but the earlier ones is lost. And because of that, when you are going to send this information ahead, the chances of the network to actually start generating the right things are less. And attention mechanism was actually invented to solve this problem. That is the drawback of the encoder-decoder architecture, and hence we need to go for attention mechanism. Are you able to understand why are we going for the attention mechanism and what is the drawback of this? Let's now jump ahead. Now, friends, one major change. So the gist of it is Sham is more focused because he knows where to focus. So here When I was talking about Rahul is a good boy, the information about boy will be very strongly available. Good will be very strongly available, but the information about Rahul and is will be available, but not that strongly. Just like today, you don't remember the 11th content that strongly, 11th and 12th October content, as you remember the last two sessions content, let's say 25th and 26th October. And why are you able to do that? You are able to remember this strongly because this is what you studied recently. Whatever you studied recently is very strongly available in your brain. But whatever you studied long back, you end up forgetting. This is the drawback of the encoder-decoder architecture, because what are we sending to the decoder is H5, C5. We are not sending H1, C1. H1, C1 has very strong information of Rahul. H2, C2 has strong information of is. We are only sending the final summary where good and boy will be having a strong presence and the earlier ones will be having a weak presence. Now, friends, the first and foremost thing, you remember in LSTM, there are two internal states, HI and CI. In GRU, there is only one internal state, which is HI. You don't have two internal states. You only have one internal state, which is HI. So what you see over here is the encoder GRU. So I have the input x1, x2, x3, x4, x5. H0 will be a random vector. Same. Earlier it was LSTM, but now it is GRU. All of these are GRU units. So Rahul is word embedded and the sum, and of course there will be a prediction. And H1. H1 is what? H1 is nothing but the summary of Rahul. Then this and is concatenated. It predicts Y2 hat and H2 is the summary of Rahul is. I'm talking about the training part. So on and so forth, you get Y3, Y4 and Y5. What you do, you discard all the outputs because they are not important and you get H5. So this is exactly same figure like this. The only difference in between this and that figure is this is LSTM. So there are H1, C1, H2, C2 right up to H5, C5. And in that figure, it is GRU. Therefore, C's are not there. So H5, C5 is the summary of Rahul is a good boy. H4, C4 is the summary of Rahul is a good, and so on and so forth. So what were we doing earlier is we were only sending H5, C5, and in this case, we would send only H5 because it's a GRU. But I am talking about attention mechanism. So what does attention mechanism say? Let me tell you, it's not something out of the box, friends. See, this was your earlier block diagram, bird's eye view diagram, where you had an encoder and you also had a decoder. Then you used to give an input, that summary or context vector was sent ahead, and then the things were flowing. Correct. So now, what were we doing earlier is when these things were flowing, we were just sending the H5, C5, but now we will send all the intermediate states is what I'll be sending. But where? Am I sending it to the decoder? The answer is no. I'm not sending it to a decoder. Then where are you sending it? Well, in between these two guys, there will be an attention mechanism, and we will be sending this over here. Yes. And what comes out is going to be a context vector. We don't call this coming out as a context vector. And what are we sending? We are not just sending H5C5 in case of LSTM. In case of GRU, we are sending everything from H1 to H5. Yes. That goes to the attention mechanism, and attention mechanism will be responsible for understanding where should I focus for the generation of the first word. If I want to generate the Marathi wala Rahul, I should focus somewhere on the initial part. If I want to generate Changla, I should focus somewhere in the later part. If I want to generate Mulga, I should focus somewhere in the more later part. Now, this does not apply, or this does not work seamlessly for every possible input. No. So don't be under the impression that this will work seamlessly. So the entire game is not to train on one or two sentences, but to train on several million sentences where most of the cases the pattern is reflected to be true. It is not necessarily true for every sentence. Some sentences are active in nature, some sentences are passive. Therefore, you have to think about the entire thing as a holistic topic. So, number one, what I said is you are not sending only H5, but you are sending H1, 2, 3, 4, 5. Right? That is the very first thing. And now if you look into this topic, friends, yes. If you look carefully, this, you still have an encoder, you still have a decoder, and in between you have the attention mechanism. You still have the encoder and decoder, and in between what you have is the attention mechanism, which is exactly what I explained you here. In between encoder decoder, there is an attention mechanism. Also, if you see this, now if you understand this single slide, then let me tell you there are 4 more slides after that, which will take per slide not more than 10 seconds. So this is the only important slide for you, because see, this is what is happening at time instant 1. If you look at time instant 2, the figure is more or less the same. At time instant 3, the figure is more or less the same. At time instant 4, the figure is more or less the same. And at time instant 5, because it predicted END, it stops, and that is the end of it. So what you need to understand now is only and only this figure. Once you understand this, I think the rest of the things. Now let's understand this in a detailed manner. Now, you know what? I explain this architecture to the people who don't know neural networks as well. I would say you are the most fortunate batch among all of them, because you also know neural networks. And now you have to think about it from the application perspective, because you are not actually training it. We already saw it on Hugging Face that using a transformer model is just a matter of 3 lines. You don't really need all of this. You don't really need all of this. But in the interviews, they will end up asking you questions not related to the technical side. Okay, explain me the math behind it. They will ask you the things, right? Hey, can you explain me the encoder-decoder architecture? How does the machine translation happen? They don't need the math. Whatever I explained to you is still far more technical. They will ask you, that in the encoder-decoder architecture, can you tell me that during the training, how is the input process? So you should say that it is processed sequence by sequence. Every word is converted to a vector. Then we have embedding techniques. Following are the embedding models available. These are the model available by OpenAI. These are the freely available models. We'll be studying that going forward. They are responsible for converting the text to vector form. Once it is extracted, then it is given inside the LSTM. And LSTM has two internal states, which is capable of remembering what the LSTM has read so far. So if I'm processing a sentence, let's say Rahul is a good boy, then when the first word vector Rahul goes inside, H1C1 will be the internal state, which will be the information remembered by the LSTM so far. Outputs we discard. This go on till the final output. And we only send the final output to the decoder. And the decoder uses that start and end are concatenated to predict. Then the while prediction we use teacher forcing, which means what you explain, and till it goes till the END, and then you try to minimize the error. That is how the training happens in 2-3 minutes. If you are able to answer this much, they will not ask you anything more than that. Most of the people don't even know this much. I can guarantee you that. Can guarantee you that. And then they might ask you, what is exactly a context vector? So you should say that encoder is responsible mainly for understanding the sentence. So the understanding of the sentence is nothing but the context vector. For example, right now I am telling you my answer. You are understanding and you are interpreting whether I'm correct or not. That is nothing but what is the information understood by the encoder. So technically, we can also say in simple words, it is like the summary of what we have understood, because every sentence I am speaking, you may not store it in your brain, but you're processing it and evaluating whether I'm correct or not. So that's kind of what is the context vector. You should be able to properly put up the words. This is more important. They will not ask you that, hey, can you write down mathematically how is it calculated? No. Think about it logically. Whenever you're working on any project for a client, are you really going to manually create a concat vector or something? No, you will never ever be needing it. When you need it, if you are here to do a PhD in the transformers, or you are working at Google where you want to tweak the architecture to make it even better, then probably you need all of these things, which I'm sure none of us are here for. So understand. You go to ChatGPT and give a nice prompt. You have studied prompt engineering, give a nice prompt. You are an um, um, generative AI and agentic AI specialist with this many years of experience, and you are here mainly to hire candidate for the top-notch Mang companies. And considering that you have to populate a list of 20 most probable questions which can be asked on the encoder-decoder architecture or attention mechanism, and see what output you get. Those type of questions which are actually asked in the interviews. You will yourself see what is the thing. Now, going ahead. So as I told you, you have encoder, you have decoder, and in between them, you have the attention mechanism. Getting started with this. So the encoder receives the sentence, Rahul is a good boy. And obviously, because it's a GRU, it is going to produce only and only internal states. And what are we doing? We are sending all the internal states, right? All the internal states are being sent over here. Done. So now this was the main idea, right? The idea is to utilize all the local information collectively in order to decide the next sequence while decoding the target sentence. Now imagine you are translating Rahul is a good boy to Rahul Changla Mulga Ahe. Ask yourself, how do you do it in your mind? Listen to me very carefully and look at my ink on the screen very carefully, else you will be lost. Now, I have to translate Rahul is a good boy to Rahul Changla Mulga Ahe. So I told you to ask yourself as a human, how do you do it? See, friends, when you want to predict the word Rahul, when you want to predict the word Rahul in Marathi, right? It is obvious that it is going to be the result of the word Rahul, which is present in the English sentence. I repeat, Marathi wala Rahul is going to be the result of the word English wala Rahul present in the input English sentence, regardless of the rest of the sentence. So, can I say, when I want to predict Marathi wala Rahul, we have to pay more attention to the English word Rahul in the input sentence? Yes. In the same way, when we want to predict Changla, we need to pay more attention to good in the input sentence. Yes. Similarly, when we want to predict Mulga, we need to pay more attention to the word boy in the input sentence. Hence the name attention. See, as humans, we are quickly able to understand these mappings between the different parts of the input sequence and the corresponding parts of the output sequence. However, it is not that straightforward for an artificial neural network to detect these mappings. As humans, we are able to understand it very nicely, but it is not that straightforward for an ANN to detect these mappings. Then what to do? Sit like a loser? No. Therefore, attention mechanism was developed to learn these mappings. How? By creating a artificial neural network whose job is to do forward, backward, again and again to learn these mappings through gradient descent and backpropagation. So let's dive into this now. In this example, let's say we want our decoder to start predicting the first word in the target sentence, which is the Marathi wala Rahul. Ultimately, this is what we are doing at time instant 1. We want it to predict the first word, which is Marathi Rahul. Okay. So now, at time step 1, I have broken this down into following steps. Number 1, we started with decoding, right? Uh, sorry, number 1, before decoding, we started with encoding. So we took this sentence, Rahul is a good boy, and we got H1, 2, 3, 4, 5. Right? Now, the hypothesis is that the next word in the output sequence is dependent on the current state of the decoder as well as the hidden state of the encoder. The hypothesis is that the next word is dependent on the current state of the decoder as well as the hidden state of the encoder. What? Not understanding? No problem. For predicting this, one thing is sure that you need H1, H2, H3, H4, H5. Right? I repeat, for predicting Marathi wala Rahul as the first word, we need H1, H2, H3, H4, H5. And there is one more thing that we need, which is only H5. This is what you will not understand. Why have I written this? This will become clear maybe in 10 minutes from now. So I repeat, the hypothesis is the next word in the output sequence, which is Marathi wala Rahul, is dependent on the hidden states of the encoder, which is H1, H2, H3, H4, H5, and the current state of the decoder, which in this case I have given as H5. So at every step, we will have to consider these two things. For now, you can ignore H5 and only focus on H1, 2, 3, 4, 5. Now, what are we doing? We are predicting the first word itself. The decoder One moment, I was saying that since we are predicting the first word itself, the decoder is not having any kind of internal state. So what to give over here? So for some reason, rather than giving anything random, I said that let me give H5. Why H5? See, I could have given anyone. I could have given a random vector over here, just like I was giving earlier. But instead of random vector, if I give H5, what is H5? H5 is the summary of the entire sentence. That makes more sense. Rather than giving any crap thing or any random vector or a vector of zeros and the network taking a lot of time to understand that it has to predict Rahul, instead of giving anything random over here, because you have to give it, what I gave is H5, which is the summary. You know, later on this H5 will be replaced by whatever is the latest predicted word. Later on this H5 will be replaced by the latest predicted word. So this decoder, just like it outputted Rahul and D1, this D1, this D1 will be coming over here in the next step. So it is time step 1. What will happen, in the time step 2, this Rahul will somehow go here and this D1 will go here. See the next step. D1 went here, Rahul went here in time step 2. But we will come back to this. You don't worry about it. But as I told you, rather than giving any crap to the decoder state, I give H5 because H5 is at least something some information which is useful. So now what we do is using these two components. Which two components? All the encoder states and the decoder state. Using these two components, I am going to train a simple feed forward neural network. Why? Why are we training a simple feed forward neural network? Friends, recall, we are trying to predict the next word in the target sequence, which is right now the Marathi wala Rahul. As per the idea behind the attention, we don't need all the encoder states to predict the word Rahul. But we want those encoder states which store information about the English wala Rahul in the input sentence. So, as I discussed previously, the intermediate encoder states are storing local information of that particular day. So, the information which was stored in your brain on 11th October after my session was very fresh. After 12th October session, the 11th October session was little bit forgotten, but you still remember. After 25th October session, the 11th October and 12th October session were even more forgotten and you remember 25th October more strongly. It is just like me saying, do you remember what you had yesterday for dinner? You do. Do you remember what you had 3 days before for dinner? You don't. So when I want to predict the word Rahul, here, Marathi wala Rahul. When I want to predict the word Rahul, this information of Rahul is mostly available in the initial part. See, I'm just saying that this information is mostly available. This information about Rahul ka English translation is mostly available in the initial part where I don't know, tukka, fluke, luck. It is highly likely that the information about English Rahul will be present in the states H1, H2. Highly likely. I am not certifying anything. I said it is highly likely that it is available over there, right? And I'm assuming it to be H1, H2. I'm assuming it. I'm not certifying anything. Don't come back to me. How do you know it is in H1, H2? It is highly likely. Therefore, it's kind of that we want our decoder. I repeat, we want our decoder to pay more attention to H1, H2, while less attention to H3, H4, H5. It's like if I ask you something that you studied on 11th October, it would be even more awesome somehow if you got an access to the 11th October ka memory as compared to today's memory, where you understood the things, that will be even more strong. So if you had access to go back to 11th October state, going back in time and answer that question, it would be even more awesome. And for this reason, to focus more on H1, H2, and less on H345, we are training a feed-forward neural network, a very simple feed-forward neural network. There will be just one input layer, one hidden layer, and one output layer. You don't have anything else in that, no complicated network. And the fact is, you don't have to do that. Everything is happening on Hugging Face in 3 lines. This is for you to understand the architecture. So in order to predict Marathi wala Rahul, the focus has to be on the English wala Rahul, which is likely to be there in H1, H2. And for that, we are training a neural network to learn to identify the relevant encoder states by generating high scores for which attention is to be paid and low scores for which attention needs to be ignored. So I am assuming that this network is able to generate scores S1, S2, S3, S4, S5. Imagine S1 to be 1000, S2 to be 700, S3 to be 20, this to be 5, and this to be 2. So neural network is going to generate scores. And the thing is, these scores S1, S2, S3, S4, they are generated for the states H1, 2, 3, 4, 5 correspondingly. Since we assumed that more attention needs to be paid to H1, H2, and you need to ignore S3, 4, 5 because I wanted to predict Marathi wala Rahul. We expect this neural network to generate the scores such that S1, S2 are high and S3, 4, 5 are relatively low, and that's exactly what you see over here. This is what is expected to happen. And then the machines are like, oh no, these are very, very big numbers. We don't like big numbers. So what to do? We have our softmax friend. We studied it in deep learning. You give any values to softmax, it is going to shrink it in the range 0 to 1. And the sum of all the values will also be 1. So here, this S1, 2, 3, 4, 5 is converted to E1, E2, E3, E4, E5. Let's say I have E1, which is 0.75, E2, which is 0.20, E3 is 0.02, E4 is 0.02, and E5 is 0.01. Did you see the summation of all the E's is 1? Right? The summation of all the E's is 1. This is what we definitely see. And this is what you see. All the E's ka summation is 1. E1, E2, E3, E4, E5. Right. And you also see that because these two were higher, E1, E2 are higher. See 75%, 20%, and this is just 2, 2, and 1%. So all these weights are also summing up to 1. And by the way, these are called as the attention weights. These are called as the attention weights. So we are getting kind of a nice probabilistic interpretation of the attention weights. In this case, we would expect these values to be something like this 75, 25, 2, 2, 1. What does that mean? This means that while predicting Marathi Rahul, the decoder needs to put more attention on H1 and H2 Why? Because E1 and E2 are high. Because E1 and E2 are high, the decoder has to put more attention on H1 and H2 and ignore H3, 4, 5 since E3, 4 and 5 are very small. Yes. So that is the entire game. Where to focus at what point of time is what is decided over here. And then this is now, this is just computed. This is just computed. Now what you do is you create your context vector. You create your context vector. How? By doing E into H. So E1 into H1 plus E2 into H2 plus E3 into H3 and so on. Now friends, now think about it. If E1, E2 are big numbers and E3, 4, 5 are very small numbers, if these big numbers are getting multiplied with H1 and H2 and the small numbers are getting multiplied with H3, 4, 5, obviously this underlined term will become big and this non-underlined term will automatically become small because they are multiplied by the smaller values. That's exactly the hack is. So the context vector is this, which indirectly is automatically focusing more on H1, H2. So this context vector, this is the context vector. Earlier, this H5, C5 in LSTM was the context vector, but now this entire decoder is working through it. And this is the context vector. What you do, if you remember your basic encoder-decoder architecture, what was happening over there? Your input was going. What you were getting is the context vector. And then this Marathi was going. And then at the start, the start and context vector were added. Now here, also I'm doing the same thing. This context vector, which is this, is added with the start. Same thing. But here we have an attention mechanism. So there was a process of focusing where at what point of time, which we actually implemented. And then using that, I get the two things. One is going to be the output, which is the Rahul, and one is going to be the internal state, which is kind of the history, what it has understood so far. So Rahul and D1. What will happen in time step 2 is this D1 will go here and this Rahul will go in place of start and the process will repeat. So the idea is what? See, next time what we want to predict? Changla. First is Rahul. Next time we want to predict Changla. So while predicting Changla, it has to focus somewhere here. Next time we want to predict Mulga. For predicting Mulga, we have to focus somewhere on the boy wala part. And for predicting Ahe, you have to predict on is wala part, where it is likely to fail or maybe likely to pass. See, even if it fails, it will not fail miserably because H5 is anyways the summary of the entire sentence. It's not that you have forgotten everything of 11 day. Even if I ask you what you studied on 11th October, if I ask this to you today, you will still be able to answer. It's just that not that well. But if I gave you the 11th October memory access, then you will be even in a better position. So it may fail also. This is what I'm saying. But overall, in most of the cases, if it passes, then it is going to do better than our basic encoder-decoder architecture. That's why you see over here D1 and Rahul in time step 2. Same process happened at time step 2. It predicted Sangla and D2. This D2 will take place here. Sangla will go here in the next epoch, next step. So you see D2 and Sangla, Mulga and D3 predicted. See, this prediction may go wrong. I'm not saying that it will become right always, but yeah, I mean, we are considering a goody-goody scenario. Then Ahe and D4 predicted. Next time this D4 will go here. So earlier I had nothing, so I passed H5. But now I have this. So I'm passing this, and this process is going to repeat on and on and on till when? till here END comes. So now, because I got an END, what will I do? I will stop. So the entire game was to somehow create a mechanism where we can understand where to focus at what point of time. But in decoder, this came long time back or now? Now only, okay. Hmm. Right, okay. At every step, score, attention weight, and CV are calculated. Yes, that's correct. So CV need not be calculated every time. CV has to be calculated. H1, H2, H3, H4, H5 will be available. That's correct. At every step, it has to be calculated. That's correct. How different scores are generated by neural network? How they are generated at neural network? Now, when you ask such kind of questions, you break my heart because that's exactly what we have studied in our deep learning. Correct or not? In our deep learning, we have studied the same thing. And the answer to that is absolutely the same, absolute no changes. It is the neural network which is responsible for generating it. Absolute no changes. For better translation, would not this be better? Do word-to-word translation using mapping, then grammatically arrange the word. Why do you think it's required? And how do you know the grammar? Ramani, how do you know the grammar? Don't you think this is going to be more like a manual approach that you are taking? There are hundreds of languages available in the market. This is exactly what was the traditional approach which was followed by Google Translate. And it gave us a lot of bad predictions. But here, because we are understanding the mathematical relationship between the vectors, the translations are even far more better than the approach that you are saying. So this approach also is learning that grammatical relationship by default. See, when you are passing English and Marathi sentences during the training, the actual English and Marathi translations are learned. And when actual are learned, that means it is the grammar also which is taken care of. It knows what to output at what point of time. This is what it has learned during the training. What you are talking about is a traditional approach. Using traditional approach, you may be correct for a few sentences. But if you are talking about the things for 1 million sentences, practically, this is something which is not possible to incorporate. So this approach is far more superior than the traditional approach that you are discussing. Machines are taking care of that. This is exactly like saying that while creating a decision tree model, is it not better that I create the decision tree using this logic? If you leave the decision to the algorithms are smart enough to figure out those internal patterns by itself rather than getting into an approach that you are saying. Okay. Now what is the problem? With the encoder-decoder along with attention mechanism, you can remember 1000 previous words. So, what is the drawback now? What is the drawback now? Well, let's understand a very simple thing. A simple layman's example. Time for lunch. This is chapati and this is sabzi. I repeat, this is chapati, this is sabzi. How do you have your lunch? How do you have your lunch? You take one small piece of chapati, some sabzi, put it into your mouth. So for chewing this one chapati and sabzi, let's say for chewing this one chunk, you take 1 minute and assume that for eating this chapati, total 30 times you need to break and mix it with the sabzi, which means for your entire lunch, it's going to take you 30 minutes. For your entire lunch, it is going to take you 30 minutes. This is you. On the other hand, consider this person. Who is he? He is Ravan. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. He also needs to chew one chunk 1 minute. But he has total of 10 heads, which indirectly means that he has 10 mouths. Therefore, for chewing the 30 chunks, he just need 3 minutes. Wow. So, what did Ravan do differently? Can you tell me in single word or few words, what did Ravan do differently as compared to you? Exactly. Exactly what Nishan said. He did parallel processing. Now, friends, this is the drawback. So the drawback is this encoder-decoder model processes the text sequence to sequence. And when I say sequence to sequence, I literally mean one word at a time. If I have to process Rahul is a good boy, I cannot process this in any order. Think about it logically. If I process the sentence Rahul is a good boy the way I have put it in the chat, do you think the sentence will be grammatically relevant? Boy Rahul good is? No. So the problem is even if you say that Darshan, I am having 100 GPUs connected to my system and I can do parallel processing, I say keep that with you only. I don't need it. Because the issue is I cannot process more than one word at a time. This is the biggest problem. I cannot process more than one word. What will I do with your GPU for processing one word? My CPU is more than sufficient. For processing one word, my CPU is more than sufficient. I don't need your GPU. Take it away. That's a waste of money. Why is this the issue? Because in spite of you saying I have GPU to do parallel processing, I cannot do parallel processing. I cannot send the words to the machine in any order, because if the order is lost, then the grammatical information is lost. And transformers birth actually solve this issue. Transformers solve this issue. So we say transformers can do parallel processing. This is the only advantage that you get. Other than that, there is absolutely no advantage. So, no, it's not BART. We'll be talking about these things later, Manu. Yes. I mean, you are partially correct, but we have to discuss that thing in detail. We'll be talking about it later once we complete with the architecture. So, this is the architecture of transformer. Now, here in this architecture, friends, if you see very carefully, you are still having an encoder and a decoder. So that's the decoder. And this is an encoder. This entire thing is the encoder. This entire thing is the decoder. So here also the encoder's job is to do the summarization and get something which is called as a context vector. So if I'm going for an English to Hindi translation, English sentence is summarized, Hindi sentence goes ahead. If you see, there are a lot of things which are common. Inputs get converted to embedding, outputs get converted to embedding. Position encoding here and here, multi-head attention here and here, add and norm here and here, feed forward here and here, add norm here and here. What is new over here is the masked multi-head attention. We'll be looking into that. And then at the end, you again have the softmax. So this linear is responsible for generating the scores. And this softmax is for getting the scores summarized in the range 0 to 1. Yes, you have the same things. Things have not changed drastically. Small changes is what we need to understand over here. So have a look at every block before we start with this. Getting started with this. Okay, friends, let's get started. Now for this, I'm going to consider the working example of English to Hindi translation. Let's say Rahul is a good boy. Translated to Rahul एक अच्छा लड़का है. Right? Rahul is a good boy. Translated to Rahul एक अच्छा लड़का है. See now, let's start with it. I'm starting with the encoder side. The encoder's job is to take the entire English sentence. I repeat, the entire encoder's job is to take the entire English sentence, understand its structure, meaning, and represent it in a way that the decoder can use to generate a meaningful Hindi translation. Take the entire English sentence, understand the structure, understand the meaning, and represent it in a way to generate a meaningful Hindi translation. So, coming on to the input tokens, the very first stage. What happens in the input tokens? The encoder is now going to take the English sentence, Rahul is a good boy, and will break it down into tokens. Rahul is a good boy, it is tokenized. Then comes the input embeddings. What is it going to do? Every token, so Rahul is, all of these are tokens. All of these will be converted into fixed size vector of real numbers using the embedding matrix. So imagine Rahul is 0.06, 0.93, minus 1.1, comma 3.216. In this way, there will be every word converted into the vector form. And what are these vectors? They capture the semantic meaning of each word. They capture the semantic meaning, or I would say, rather than semantic, let's say they capture the basic meaning of each word. And technically, they are nothing but the numerical encodings of the word's meaning. Then, the problem was parallel processing was not achieved. And for that, they introduced what is called as positional encoding. So what is positional encoding? See, as I told you, transformers do not process the words in sequence like RNNs or LSTMs. So there must be, or there is a need for them to kind of understand a way to know the position of each word in the sentence. Positional encoding creates a unique vector for each position. 0th word position, there will be a positional vector created for the first word. For the first word, the word which is at the first position, there will be a positional vector created. So just like for Rahul, this is the embedding vector. In the same way for Rahul, there will be some other vector created, and this is going to be the positional vector. And then over here, the embedding vector and the positional vector are added together for each of this. So they now know what is the meaning of Rahul, basic meaning of Rahul is captured, and the position of the Rahul is also captured. So later on, when it is about knowing that, okay, where was Rahul, because I'm going to do parallel processing, these all things are captured in this positional encoding. Here, this is the positional encoding 11-page research paper where you will see there is actually a formula for calculating positional embedding. It's not a straightforward thing. Do you really need to get into this white paper? Ideally, no, not at all. Right? Else, I will take the entire session to explain you the architecture without getting into hands-on, which implementation just takes 3 lines, as we all know. So it's not needed ideally. It's not needed ideally. So positional vectors, right? We understood what are they, right? They are nothing but we are going to create a unique vector for each position. And these are nothing but the actual encodings that you get using the sine and the cosine as it was proposed in the original paper, right? So, this gives each position a unique and continuous pattern. So the model can distinguish between the word 0, word 1, and so on, and also their relative positions. It also learns the position of Rahul in the sentence. So if Rahul is at position 0, is it at position 1, then the model will be adding positional vector 0 to the Rahul's embedding, positional vector 1 to the is embedding, and so on. So the final embedding is nothing but the word embedding that we received plus the positional embedding. And now comes the multi-head attention. So what happens in multi-head attention? Now this is little important. Multi-head attention. We are talking about this. Whatever happens over here, same thing happens over here. I will not be explaining it again and again. So in multi-head attention, each word attends to, or I would say it looks at every other word and learns how important they are to each other. I repeat, each word attends to every other word and learns how important they are to each other. So you have over here two things. One is self-attention. Self-attention means a word can look at other words in the same sentence. Self-attention means a word can look at other words in the same sentence. Self-attention means a word can look at other words in the same sentence. And the next is multi-head. What is multi-head? It means that it does this multiple times in parallel. With each head, many heads are there, each head focusing on different relationships. So maybe one of the head is focusing on the grammar, another head is focusing on the meaning, another is focusing on the distance, another is focusing on the structure of the phrase. Because of this only, boy might attend to good to understand that it is being described as good. Is may attend to Rahul to establish the subject-verb relationship. Boy might attend to good to understand that it is being described as good. Is may attend to Rahul to establish subject-verb relationship. So in this way, each word ends up with a new representation that encodes its meaning in context. Then, after that, you have the add and norm. This is the first occurrence of add and norm, but you see it here, 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 here. Everywhere it does the same thing. So I'll just write it in short over here, add and norm. See, here there are two things, add and norm. Technically, add is going to add the original input to the output of the attention. Add will be adding the original input to the output of the attention. And norm is responsible for applying normalization, which is going to rescale the values to keep them within a stable range, just like we were applying normalization on our MNIST dataset to get the pixels converted in the range 0 to 1. In very simple words, if you have to remember, this entire thing helps with training stability. Model should not overfit, right? So this layer is just to ensure that because it is working purely on numbers, the numbers should not drift. It should not get into unstable values. So this is responsible for training stability. So it's like the context-aware representation of the word boy is added to the original embedding and normalized. So this will let the model to keep the original meaning along with the learned context. And then, just like earlier also you had a feed forward neural network, now also you have a simple feed forward neural network which is applied to each word's vector independently. This is applied to each word's vector independently. It will just have one hidden layer which is usually larger than the input size. So if the input is 500, the hidden layer should be more than 500. There will be one activation function, usually ReLU or GALU, and there will be one output layer that brings it back to the original size. So basically, this feed forward neural network, it transforms the input further to help the model learn even more abstract patterns. So basically, to enhance the learning, all happens with respect to pure vectors. This feed forward neural network helps. Like for example, the representation of boy, when it is passed through this feed forward network, hidden layer will be quickly expanding its features. ReLU will be adding non-linearity and the output layer will be compressing it back. In simple words, this feed forward neural network is having one single role, is to refine the word's vector. Its job is to make the current word vector smarter and more contextual. Smarter, more contextual. That is the job of this FFH, feed forward network. Then you again have the add and norm, which applies the residual connection and normalization just like before. And ultimately, you have this. What is this? This is the encoder's output. So for every word, let's say Rahul is a, and so on. For every word, you have now a deep context-rich vector. For every word, you have a deep context-rich vector. And these are sent to the decoder so that it can start to use them to generate the translated sentence. Now let's get into the decoder side. What is the decoder job? The decoder job is to take what the encoder has produced and generate the Hindi sentence one word at a time. So it is going to use two things. The Hindi words which are generated so far, as well as the encoder's ka output, which is this deep context-rich vector. So first, Rahul एक अच्छा लड़का है. It is tokenized, right? And after tokenization, we are shifting the target sentence so that it can learn to predict the next word. So basically what will happen is this Rahul is a good boy will be converted like this. Empty string, Rahul एक अच्छा लड़का है. It's shifted. I repeat, it is shifted. So now basically, what is the learning pattern? See, given this, it should be able to predict Rahul. Just like we were giving start. Then given this and Rahul, it should be able to predict ek. Given this thing, it should be able to predict acha. Given empty Rahul ek acha, it should be able to predict ladka and so on. So then after that, you create the embeddings, you create the positional embeddings, and of course, as usual, you add this too. You add this too. After that. Now, did you see over here? Most of the things in this place you know, except a new thing which you see right now, which is the masked multi-head attention. And by the way, you can also call this as teacher forcing implemented with the help of masked multi-head attention. What was teacher forcing? The network used to predict something. Then the prediction was compared with the actual, and the actual was sent ahead, not the prediction. And this used to go on and on till the END is predicted. So now, coming on to the masked multi-head attention. This is the attention within the decoder, but it is masked. What is masked? See, I can see you. Now I'm masked. I cannot see you. I can see you. I cannot see you. So masking means the model cannot peek at the future words. So basically, when I wanted to predict acha, the sentence is Rahul ek acha ladka hai. When I want it to predict acha, it should be given exposure to only space at the empty Rahul ek. It should not be shown anything after that. So this masked multi-head attention job is to mask the word. One word at a time will be generated. So essentially, you know what happens? We, in the attention mechanism, you remember we gave this along with the start and we asked the network to predict. It predicted. And then once this prediction is done, we say that, okay, I have given you Rahul is a good boy, you generate the translation. So it predicts the first word. Then I say that this word was not shown. So now that I have predicted the corresponding Hindi word, now it shows what has to be the actual Hindi word. Because it was masked earlier, its job was to hide it. Then it unhides and shows. Then you compare this to calculate the error. And then it says, okay, now you predict the next one. So let's say it predicted egg. Then it shows egg, compares it to calculate the error. So this is the same attention mechanism, but incorporated with the help of masked multi-head attention, whose job is what? Its job is to hide the meaning, ask it to generate. Once it generates, then you give the actual, calculate the error, and keep on doing in this manner. So this will allow generation to happen one word at a time. So the reason for masking is we don't want the model to peek at the future words, and therefore we need to mask it. And then you have the multi-head attention whose job is same, add and norm whose job is same, which is residual and the normalization. Then you again have this going ahead. So what is the main job of this multi-head attention? Prediction and actual is being compared over here. So the decoder's job in the multi-head attention is to look at the encoder ka output, which is the English sentence, and find the relevant words. That is exactly how the translation happens. The decoder is saying to generate the next Hindi word, which English word should I look at? Like to generate acha, the decoder may strongly attend to good. To generate ladka, it may strongly attend to boy. This block allows the decoder to align the output with the input. That's exactly what is happening over here. Again, you have add and norm, feed forward neural network, which is same as it was in the encoder. Again, a small neural network which is applied to each vector. For what? To refine its meaning. Again, you have the add and norm for training stability. And then you have a linear layer. What will that do? It will convert the output of each word into logits. What are logits? Logits are nothing but the raw scores for every word. Just like attention scores were there, which were converted to attention weights. So, because we don't like such big words, we pass it through the softmax to get it converted into probabilities, and then we choose the word with the highest probability. Then we choose the word with the highest probability. And finally, Rahul is a good boy is converted to Rahul like acha ladka hai, because the model has used the context, attention, deep representation to correctly match English to Hindi structure, grammar, and meaning. And that is, so we understand the transformer architecture. But there are few things which you actually need to know from the interview perspective. Because no one is going to ask you so much detail of what I explained, but something that you need to know. You know what? Not a good figure. You know, it's blurry. I don't like blur figures, but anyways, no option. We'll continue with this. I want to tell you a few things over here. This is the encoder. This is the decoder. Understand some things very, very carefully. This is our encoder. And this is our decoder. So, see, what is the moral of the story that we have learned so far? Encoder's job is natural language understanding. And decoder's job is natural language generation. Now, little step ahead of this. Yes, thank you for that. I want to tell you, Manu was saying something, right? That's exactly the point which I discuss it at this stage once everything is over. You know this, there are many types of models. There are some large language models which are encoder only. They don't have decoder. There are some large language models which are decoder only. They don't have encoder. There are some large language models which are encoder, decoder both. What are encoder only models? Well, let me tell you who invented this encoder only models. Google. Google invented the encoder only model. Decoder was not even existing. Google invented that. So this was invented by Google, and this architecture was BERT, BERT, and it is the best for natural language understanding. So therefore, you might have seen BERT, which is very, very popularly used for sentiment analysis or summarization, because it can understand the things really, really well. Then who invented decoder only? Anyone knows? Would you like to type in the chat? Decoder only model, not chat GPT. OpenAI. OpenAI. OpenAI invented decoder only models. So all the GPT models are. Wait a minute. So decoder, you said its job is to generate, and OpenAI models, they can also do the summarization, they can also do sentiment analysis. But if they do not have this encoder, then how are they understanding? $1 million question. Because ChatGPT can do everything. Okay. Then came our Meta bhai sahab in place. Meta. They invented the encoder-decoder model where they combined BERT and GPT model together. They called as the BART model with the combined advantages. And let's actually get into understanding the nitty-gritties of this. Right? So I say you are an expert in the generative AI with immense deep understanding of the transformer architecture. What the hell? ChatGPT is down? Got it, but I didn't get you. Encoder is good at natural language understanding, and decoder is good at natural language generation. And here is a breakdown. Encoder's job is to understand the input sequence and create a rich context-aware representation. Decoder job is to generate a new sentence. And so the assessment is spot on. It is correct. Right. List down all the encoder only models in the form of a table, having the column name as the name of the model, second column as the capabilities of the model or the applications, third column with the name of the inventor if it exists. Similarly, create one more table for decoder only models. Similarly, create one more table for encoder-decoder models. So if you see, BERT is by Google, right? So this is an encoder-only model. Its core job is sentiment analysis, text classification, named entity recognition, etc. Roberta is nothing but a version of BERT only, improved BERT performance via optimized training. Distill BERT is also one of it. Alberta is there, Electra is there, etc. Decoder-only models are GPT by OpenAI, Llama, which is open source LLM for wide range, Then you have PALM, which is Pathway Language Model, Mistral, Mixtral, all of these are GPT only models. Falcon, which is trained at UAE, Abu Dhabi specifically, it is there. Encoder-decoder model, the transformer architecture. T5, which is text-to-text transfer transformer. BART, M2M, Pegasus, these are few of the models. And you have some video around it, that's okay. So we understood the applications of it. Now some questions around it, which we would like to address, that if GPT models are decoder only, then how can they do the job of summarization of a text? For summarization, we need to understand the text. And the GPT models are not having encoder to understand. Can you explain in simple words, how are they overcoming this hurdle? These are kind of the questions which are very much asked in the interviews. Now, see, before this chat GPT or BERT answers, let me also answer, else you will be like instructor is teaching using these resources. See, friends, you need to understand a few things over here. When you talk about the decoder only models, what has OpenAI done? OpenAI has put in a lot of efforts in training their GPT model. And that too, how? They have taken a sentence, or not sentence, they have taken a paragraph. So what have they did is, they have taken a paragraph and they have given a prompt. Uh, Here is the paragraph to be summarized, and then that paragraph over here. And then below that, they have given, this is the summary of it. This can be another summary of it. This can be another summary of this. So basically, given this prompt that, okay, summarize this and given a paragraph, they have given three possible summaries. And they have also said that, hey, you know what? This is the one which humans would love. This is the ones which they would love little less. And this is the one which they would love the least. And they have made the decoder a model to understand this pattern. How? See, these decoder models purely understand on the basis of tokens. Like, for example, if I say grass is dash, the very first word which comes to our mind is green. But there can be n number of words. There can be a word like green, tall, dry, so on. Let's say there are 10 possible words. It is going to choose the word with the highest probability rather than the word with the lowest probability, right? And after that, if you ask it to predict the next word, then again from all the words listed, it will choose the word with the highest probability. So OpenAI models learn the entire data in this manner only. They learn the entire data in this manner. Given a word, what is the next word? So these are the ways these GPT models learn. They are not understanding. They are just like, okay, given this, this is the best thing which can come next. That's why your brain also said the grass is green rather than any other word. The things which you have seen most of the times is going to be the next token. So here, in simple words, they achieve this by being brilliantly good at following instructions and predicting the next word in the structured conversation. The power of in context prompt. Input is instruction, document to summarize, and the output is the summary. So model sees the full document and the instruction simultaneously. Then the masked advantage, while attention is being masked, which is causal. During the initial process, the model can still draw connections between the instruction and the document content. And that is how it does. And it does not happen on few words. It happens on trillions of the words. So it has It's implicit knowledge. So through this vast training, the model doesn't just learn the grammar, it learns the facts, logical relationships, and the structure of information. It implicitly learns what a good summary looks like. And it does that in a bidirectional way. Plus, there is reinforcement learning from human feedback where we gave it multiple summaries, right? You train it and then it is fine-tuned. Here is the text, generate the summary for Y. And a lot of summaries are given to it. And that is how it handles. That is how it handles. So the hurdle is overcome by massive instruction tuning. Remember, this process is called as instruction tuning and clever formatting of the instruction prompt, which together, which together simulates understanding of the missing encoder. And that is what is the idea behind it. So I can say list all the encoder only models available on Hugging Face. And BERT uncased. If I go to this, you see, this is encoder only model. Then Roberta base. If I go over here, the first one by Facebook, and so on. In the same way, on the Hugging Face, I have the llama. This is the decoder only model. On the Hugging Face GPT-2, this is the decoder only model. In the same way, you have many others, right? And this is the encoder-decoder model, which is nothing but T5. Go on Hugging Face. See, by default, the first link is Hugging Face only. You have Pegasus. Pegasus, actually, many models are available. Therefore, it is not giving the direct link. Many models are available by Pegasus. Many. All right. So pipeline this Google/Pegasus XM. So we have already done the summarization. No, we have used this Pegasus model. I think so. Then ProfitNet. So Hugging Face transformers we have covered. Now, yes, so many things are left out in this course. Now, after this, we are going on to point number 7, working with the OpenAI SDK. So, yes, how will you go ahead with that? Well, I will straight away start with it here only. So I'm going to create a new notebook, collab notebook. Now, friends, from where do you actually generate the OpenAI key? Well, the place from where you generate the OpenAI key is this platform.openai.com. I'll put this here. This is the place from where you generate the OpenAI key. How? You have to sign up on this, like I have signed up with this. Then you click on your profile. You don't do it, but later on, whenever you have to do it, you can do it this way. You click on your profile. Then you click on API keys. Then I create a new secret key. And this secret key can be given any name. We can select the default project and then create. The moment you create, an API key will be created just like Hugging Face. And what will you do with that is, you will come to the key section where you added the Hugging Face key. You will be adding the key. The name of the key which I did put is the OpenAI API key. And your key will be going here. In the Google Colab, if you have to do that, you will have to do it this way. By the way, your Simplilearn's key is encrypted. If you are using the key from the Simplilearn and pasting it into Google Colab, it does not work. I have already tried it earlier. So the key that you generate using platform.openai.com is universally available, be it in any IDE, even in your lab, Simplilearn's lab. But the Simplilearn's key can be used only and only in the Simplilearn's lab. So this is where you have to do that. Now, before I get started, let's actually look into my profile. I am going to look into my billing. So you can see that my current balance is $15.43. By default, you get a balance of $0. You will have to recharge it with a minimum balance of $5. If you click on add to credit balance, minimum between $5 to $989 is what you can recharge. So I come over here and I also make a note of the current balance. We are going to get started with working with the OpenAI API. No, not through credit card. It can be a debit card as well. So getting started with that. The first thing that we are going to look into is the text completion. How OpenAI model can be used for generating text. So you will have to, first of all, install OpenAI. I did that. On your Simplilearn lab, the OpenAI which is installed is an older one. So the version which we want is this. So in case if you are getting a version older than this, which you will 100% get, in that case, you will have to install that version. That is the code to do that. Let us get started with the text completions. Now, the first and foremost thing, this one. How do you read the API key? This is what we are mainly looking into. Now pay attention, everyone, right? My API key is available in the secret key section. If you have to load the API key, you will have to copy this code. So I'll just paste it here. I'm going to copy this code and paste it here. But which API key you want to read? Let's say I want to read the Anthropic API key because I don't want to show you my OpenAI API key. And this Anthropic API key has become obsolete. So I'll just paste that name here. And if I execute it, this is the direct code to load the API key from the secret key section. In the same way, if I would have copied this thing and pasted it here, then it would, when executed, it would display the OpenAI API key. It's just that I don't want to show it. Okay. So in this way, I'm going to load it. I'm going to delete this. So if you see, importing, loading, and after loading, I don't want to show it to you. Therefore, I'm saving it into a variable. The name of the variable can be anything. I gave it as OpenAI.API underscore key. And then after that, I have just dumped it into the environment variable. Now, why environment variable? I'll tell you. Now, I'll tell you what is the meaning of this line number 7. If you come to this line, if I have to actually start my text completion, I import OpenAI, done. Then I create an instance of the OpenAI class by passing the API key by this name. Now, it is completely okay if I do not type this highlighted portion. Why? Because I have saved the API key into the environment variable. That means every time while creating an instance, I need not give it. But if I skip writing line number 7, then you will have to compulsorily give it every time you are creating an instance. So you are creating a text, you have to give the API key. You are creating an image, you have to give that. You are doing text to speech, you have to give that. But now I can do it just like this. Client is equal to OpenAI and my job is done. Okay. So I repeat, from OpenAI, import the OpenAI class. This is good. Then client is equal to OpenAI. So we are creating an instance of OpenAI. Then I say client.chat.completions.create. This looks very ugly, but this is the only way to work with the OpenAI API. It looks ugly when you see at it for the very first time, but it's easy. You will be, after 20 minutes, you will be used to this. But there is no other way to write it. Client.chat.completions.create. Then model is equal to GPT 3.5 Turbo. From where am I getting this? Just go to Google and search for OpenAI pricing. Open up this link. This shows all the available models. GPT-5, it is good at what all things. 5 mini, it's good at what all things, etc. And then if you scroll down, you have the option to explore detailed pricing. You click on this. And here you have the pricing. So OpenAI is like, we will be charging you for everything. In the sense, if I go to ChatGPT and if I say, hi, I'm Darshan, used as ChatGPT. If I go and say, hi, I'm Darshan. So what do they say? For understanding this, we have to put in energy. We will charge you for this. And then after understanding, generating an output, for that also we will charge you. So as a user, we are charged for understanding our prompt at the same time for generating the output. That also is chargeable. So you are charged at the rate of $1.25 per 1 million token for understanding what prompt you have given. And to generate an output, they charge you at the rate of $10. This cash input is not important right now. Let's not get into this discussion. So which model are you trying to use? You just have to copy paste this name. If you want to use GPT-5, you will just go to this notebook. This name has to be pasted in place of this. And this will be the charges for it, $1.25 and $10 respectively. Now, these are charges per 1 million token. Now, what is a token? You can just go to Google once again and search for OpenAI tokenizer. I am sure I might have shown you this earlier. Did I? Did I take you to this OpenAI tokenizer earlier during the Hugging Face? No? Oh, okay. No problem. No problem. Let's look into this. Tokenizer. See, the smallest indivisible particle that we understand is an atom. In the same way, the smallest thing that a large language model understands is a token. What is token? From NLP sessions, we know a little bit about it, that tokenization. What is tokenization? If you look at this word, I love machine learning. After tokenization, you see I love machine learning exclamation. This is word level tokenization. If you look at this is character level tokenization. And this is sub-word level tokenization. Machine learning. There are various types of tokenization. OpenAI uses its own tokenizer, which one it has not disclosed anywhere publicly. But more or less, no LLMs disclose their tokenization technique. They say that you want to use it. This is our tokenizer class. You can use it. But they will not disclose the tokenization technique. Anyways, let's have a look at this. This is really good. So here, OpenAI's large language models process the text using the tokens, which are the common subsequences of characters found in the text. The model learns to understand the statistical relationship between the tokens and excels at producing the next token in a sequence of tokens. You can use the below tool to understand how a piece of text might be tokenized, no guarantee, might be tokenized by the language model, and the total count of the tokens in that piece of text might be a no guarantee. So I come over here and I say, my name is Dr. Darshan Ingle and I am a data scientist. This consists of 52 characters and 14 tokens. And if I say I am a data scientist, it is 54 characters and 15 tokens. You can see my name also is divided into 2 tokens, surname as well. So every word is not necessarily a token. But why like that? Because this is not word level tokenization. So let's try to understand. So for English, we will be charged for 15 tokens for English language. If I go on to Google Translate, and let's say if I'm converting it to Kannada, see 59 characters. See here also 54, 59, more or less same 60 characters. But English took only 15 tokens, but Kannada has taken 25 tokens, which means Kannada is more expensive to compute. So there has to be some standardization and therefore they convert it to tokens. If I, let's say, convert it to Polish by Poland. Now see, this is not E. This is some other character. We don't understand, but this is not E.
Nazywam się dr Darshan Ingl i jestem naukowcem zajmującym się danymi. Nazywam się dr Darshan Ingl i jestem naukowcem zajmującym się danymi.
Okay, God knows what it is. But 69 characters, 22 tokens. So everything is converted into a standard measure because of this. That's the advantage that you get. And these tokens, when converted to numbers, they look like this. I told you, I had shown this to you earlier. I told you, I remember. Thank you very much for confirming, Anand. Yes, I remember in Hugging Face, when I started with the first notebook of summarization, I had shown this. I told you, all of you said, no, 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 no. See, great. A helpful rule of thumb is one token generally corresponds to 4 characters. 100 tokens is 75 words. And then, so now, understand, you know how you can change the model. I have given the link to all the models. Then coming on to the messages. Now, there are two types of messages. There are total two types of messages. One is the system message and one is the user message. And there is one more assistant message. I repeat, user is me because I am interacting with the GPT 3.5 turbo model. So I am the user. Assistant is the GPT 3.5 turbo. So when I am running this, see, listen to this. When I give the input hello, the GPT 3.5 turbo replies, hello, how can I assist you today? So I am the user. And the reply which I got is coming from GPT 3.5. So we call this as the assistant. So this is the user message. This is the assistant message. And the aura that you want the GPT 3.5 turbo model to adopt, the persona that you want it to adopt is nothing but called as the system message. So what I say to GPT 3.5 turbo that, hey, you are a helpful assistant. So it will always understand that it has to be helpful. For example, if I say you are a misguiding assistant and I say, I need tips on health fitness in 3 bullet points. Stay consistent with your exercise routine by scheduling regular workout and mixing up your activities to prevent boredom. And actually, it is not misguiding. Focus on balanced diet. You are a misguiding assistant who always suggest opposite of what is ideally expected. So I avoid exercising regularly and try to be sedentary as possible. Choose unhealthy, high-calorie food over the nutritious option. Ignore physical activity recommendations and focus on staying inactive as much as you can. On the other hand, the same thing, if I go and say, you are a helpful assistant. So what is going to happen now? It will act as being helpful. So what aura you want the model to adopt, what persona you want the model to adopt is the system message. If I say over here, you are you are Sardar Gabbar Singh, the famous villain from the Bollywood movie Sholay, who is known to speak in his rude and threatening style. And I say, I need 3 tips on this. Listen, you better pay close attention if you don't want to feel my wrath. Don't be lazy. You must exercise regularly to stay fit. Cut out the junk food and no more eating like a pig or else. Get enough sleep. Don't act like a fool and stay up all the night. You better follow these tips if you know what's good for you. And if I want to be a little bit more harsh, Bollywood movie in his threatening style in Hindi. Dialogues. सुन, सन, जल और ऑक्सीजन तीनों की तरह फिट रहना इंपॉर्टेंट है. सुबह उठकर रोज एक्सरसाइज करना, खाना सही टाइम पर खाना और फ्रेश हवा में सांस लेना इंपॉर्टेंट है. जंक फूड से दूर रहो, घर पर बना खाना खाओ, हरी सब्जियां और प्रोटीन से भरा डाइट करो. शराब और तंबाकू से दूर रहो वरना गब्बर आ जाएगा. नींद भी इंपॉर्टेंट है, कम से कम 7 से 8 घंटे की नींद लो। नींद पूरी हो और बॉडी दोनों फिट रहते हैं, पूरी हो तो बॉडी और माइंड दोनों फिट रहते हैं। अगर नींद में कमी आई तो टेंशन लेना पड़ सकता है, टेंशन नहीं तो गब्बर चला आएगा। सो what aura you want the large language model to adopt is nothing but the system message. So there are 3 messages that we learned. Number one, system message, which is the persona, user message, which is what I am giving, and assistant message, which is the one which is the model reply. So model is the assistant. So now if you see this entire cell highlighted portion output is saved into completion. So if I just print completion, what you see is a very lengthy thing. And I don't have time to keep on scrolling and scrolling and scrolling. It is actually going to trouble me. So there is a code which I have, which if I use, because the output comes in the form of JSON, I import JSON and I just use the model dump method and I print it in a beautified way. Chat completion, chat completion. So this is the completion ID. The finish region is stop. You saw that here as well. So basically, finish region stop means everything was fine and therefore it finished. The response is here. So how do I get this? See, logically, completion.choices of 0.message.content. Completion.choices of 0.message.content will exactly give me what I want. So I have to do that. Plus, it is created at this time second, purely in seconds. So model is this. The question which I gave hello, it consumed 19 tokens and the completion took 9 tokens. Sorry, 9 tokens for input and 19 tokens for output. Total 9 plus 19, which is 28. All right, this is what you see. Then coming down. Once I can do that, ideally you need not create an instance of the class again, but I have just kept it for your easy understanding. So basically these 2 lines are not required. We had already created an instance and anyways, I'm going to use this client dot only. So this is not required. Just for better understanding, it's like we are doing it, but it is not required. So I say, you are William Shakespeare. Write a poem on my dog named Tuffy. Oh, Tuffy, though furry friend, so loyal and true, with tail wagging and eyes so sparkling of dew. That's good. If I say, you are helpful assistant, write a poem on my dog named Tuffy. You have it. Now, I say, you are Mogambo, who is famous Bollywood villain from the movie Mr. India. You can speak in his style and tone in Hindi. Right. I realized maybe OpenAI has not seen the Mr. India movie, but yeah, it's good. Today it's awesome. मोगैम्बो खुश हुआ सुन के ये खबर, एक ऐसा कुत्ता जिसका नाम है टफी यार। टफी है वो शेर जैसा पर दिल का साफ है, उसके साथ हर पल खुशियां है साथ है, उसकी वैगिंग टेल और वफादार आंखें दिल जीत लेता है सबका उसके ये गुणवान। सो ऑन एंड सो फोर्थ। मोगैम्बो की दुनिया है, तेरे साथ हर पल खुशियों से भरपूर रहे टफी मेरे यार। मोगैम्बो की दुआएं है। ओके, बट यू अंडरस्टूड इट। If I once again change the system prompt, your Sardar Gabbar Singh, who is known for the famous Bollywood villain from movie Sholay, you speak in his tone and style in Hindi. Write a poem on my dog named Tuffy. Tuffy मेरी शेर से भी भारी, उसकी सयाजी सयाजी से डर से सब होते निहाल and so on, whatever. On the other hand, again, this is not needed, no? You are a helpful assistant, write a poem on my dog named Tuffy. But there is something new over here. Yes, this will take some time. Now, let us talk with respect to these parameters. Now, if you look into this, this is where I see there are some parameters which are being used. Everyone pay attention over here. Temperature, max tokens. Max tokens is how lengthy you want the response to be maximum. I have kept it as 256. If I say that only 20 tokens max, then the output will be incomplete. 20 tokens get exhausted here only. In the same way, for the other things, I don't know if I have it. ChatGPT anyways is today working bad. So it's not there. Anyway, so temperature. You know what is temperature? Let me show it to you quickly. So here, temperature will be taking a value between 0 to 2. More higher, more non-deterministic the output is. For example, if I say explain the process of breathing, everyone on the planet Earth will answer it the same way. But if I have to write a sequel for Three Idiots movie, then I need creativity. So in such cases, for normal answers, we will keep the temperature on a lower side. And for creative outputs, I will keep it on a higher side. The more you make it higher, the more surprising the results would be. For example, if I'm keeping the temperature to 1.4, let's see how does the poem on Tuffy looks like. In the world so chaotic and busy, there's a loyal friend named Tuffy, so busy. You see, the language all of a sudden changed, right? And if I keep the temperature more on a higher side, maybe like 1.9, then you will see mess. You will see mess now. A fluff ball of cuddles, a bundles of joy, Tuffy the dog, furry and coy. With the wag of tail and twinkle in the eye, in the realm of love, Tuffy will forever lie. Boundless and blah 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 blah. In the prisons, human dinner fixes in natter rap and SRC woods yet collab or programs pajama for page string paginated from. So you have to choose the value in a smart way, right? These are hyper parameters with which you have to play around. So they are used for controlling creativity. You have to choose it properly. Top P. So top P is like, if I say the grass is dash, you said green. There are 10 possible words which can come. If I'm setting the top P to 1, it will choose the word with the highest probability. But if there are 10 possible words which can come, the grass is dash and 10 possible words are possible. And if I'm setting the top P as 0.5, then out of the 10 possible words, the top 5 words will be chosen and any one of these top 5 words will be coming in the output, any one. Whereas when you keep the top P value as 1, then it will always choose the word with the highest probability. Frequency penalty is to avoid repetition. So if you don't want the same word to be repeated again and again, like there is a beautiful garden next to my window. The garden has a beautiful grass and there is a beautiful gate and there is beautiful this. If you don't want such kind of repetitions, if the model is repeating the words, you can increase the frequency penalty. Similarly, presence penalty is the capability of the model to take challenging topics. For example, if you are keeping the presence penalty at 0 and you ask, write about Narendra Modi, it will start talking about he being child, becoming chaiwala, becoming the CM, then in the BJP party becoming the PM and etc. etc. If you increase it, let's say to little higher value, it will start speaking about BJP as well. New topic. If you increase it further higher, it may start speaking about Rahul Gandhi being his opponent. So presence penalty is nothing but the capability of the model to take new topics. Positive values penalize the tokens based on whether they appear in the text so far, increasing the model's likelihood to talk about the new topics. So this is the documentation. Basically, 99% of the people only use temperature. But my job was to show you all. I showed you as simple as that. As simple as that. Okay. Now, after this, I want to talk about image generation. Now, image generation does not have this system and user. Let's talk about the image generation. Now, for image generation, how can you generate an image? Well, first of all, the image generation models which are available on the OpenAI pricing page, and these are the only models which are available. The first two models are not available in the organization access, so I will not be able to demonstrate that. But anyways, the state of the art models are these two only, DALL-E 2 and DALL-E 3. DALL-E 2 came first, and after an year, DALL-E 3 came into picture. You can only generate images of the following resolution with DALL-E 2. 256 cross 256, 512 cross 512, 1024 cross 1024. And that too only standard quality image. With DALL-E 3, you can generate standard or HD images of the following resolution. Anything other than that, not possible. So, what I did, I said, I'm creating an instance of OpenAI as usual. Client.chat.completions.create is now client.images.generate. I'm saying the model to be used is DALL-E 3. The prompt given is a white Persian cat. The size of the model, what happened? Your okay, that's not a problem. The size of the model, not the size of the image has to be 1024 cross 1024, and it's a standard image. Number of images to be generated are only one. I would like to see what has it generated. So I'll come down and I'll print the response because the output is saved inside response, right? So this is the response created at this time, background none. And this is the URL. If I click on this, you will see a white Persian cat. Beautiful, beautiful. And by the way, because our prompt was not great, it automatically considered revising the prompt and making it something like this. A fluffy white Persian cat with brilliant emerald eyes. The feline's long, sleek fur is impeccably groomed, giving it an quality of regality. Sunlight filters in from the off-frame casting worm. See, off-frame casting worm. Sunlight is there. Delicate shadows across its form. Yeah, I don't think so, shadows, but yes. Then the animal is comfortably ensconced in a plush velvet cushion. Yes, you see that plush velvet cushion with a sign of alertness, while a hint of playful curiosity shines in the eyes. That's nice. If you just have to extract the URL, where is the URL? It is in the image response, inside data, inside URL. So I say response.data0.url. So it is just extracting the URL. But why did I extract it? Because I want the image to be displayed here only. So using the IPython.display that we did during Hugging Face, I'm displaying the image inside the notebook only for convenience, right? So that I need not go anywhere else. So this was the result by the DALL-E 3. What if I give the same prompt to the DALL-E 2 model? What is the prompt? My prompt says a white Persian cat given to the DALL-E 2 model. Same prompt, white Persian cat given to the DALL-E 2 model. Let's see what it gets. This was DALL-E 3, by the way. We will try to do it for DALL-E 2. It looks like the cat of the poor people. Look at this, so elegant, so rich, nose, and everything is so awesome. And here, nah. Okay, maybe DALL-E 2 is not given a good prompt. So what I did is to DALL-E 2, I gave it a nice prompt, a white Persian cat with long, luxurious fur that gives it some majestic appearance. The eyes are vivid blue, a characteristic trait of this particular breed. The cat's demeanor is calm, poised, as if it is posing for a royal portrait, while it sits comfortably on a soft, plush crimson pillow. Where is the pillow? God knows. And the image is also not that good. I'll try once again. By the way, image generation is very costly. Huh? I mean, if you look at the best resolution image, HD, of the highest resolution, it is charging at $0.12. How much is that? 11 rupees per image? Crazily high. Therefore, do not generate images using your Simplilearn's credit. You will lose the balance very fast. You see crimson pillow, but still, eyes and all, not really very, very great. But if I give the same awesome prompt to DALL-E 3, same awesome prompt I give, a white Persian cat and all this, to a DALL-E 3 model, then DALL-E 3 is known to be awesome. And see, definitely much better image. The quality is altogether different. I gave it another prompt, DALL-E 3, with a prompt, an astronaut in a jungle. And that's nice, na? Astronaut in a jungle. Beautiful image. I gave it one more prompt. An astronaut riding a horse on planet Mars. But it is given to DALL-E 2. So don't expect very great output. But one thing is for sure that DALL-E 3 is far, far better than DALL-E 2 is what we realize. DALL-E 3 is far, far better. Right. So see, DALL-E 2 always generates cartoonist type image. What was the prompt? Astronaut riding on a horse on planet Mars. If I ask it to generate it once again, maybe the first time it didn't generate good. So I asked it to generate once again. Let us see what kind of image does DALL-E 2 generate. Not great. But the same prompt, an astronaut riding a horse on planet Mars, when given to DALL-E 3, whoa, undoubtedly awesome image. Awesome image. To DALL-E 2, I gave it a better prompt. To DALL-E 2, I thought of giving a better prompt. I said, a hyper-realistic image of an astronaut in modern suit riding a muscular brown horse across the red rocky terrain with dramatic Martian sky. You see that? Better prompt, huh? And soft shadows, photorealistic, 8K ultra cinematic lighting. See, DALL-E 2. It came out of its cartoonish style, which clearly indicates that prompt is the key. But if the same prompt is given to DALL-E 3, it's awesome. No doubt. DALL-E 3 is way more better. Come on. Look at this. Look at this. And look at this. Better. Astronaut doesn't have this cap, but we can try generating once again. Another 11 rupees spent. Oh. And this is what doesn't complete this notebook. I will tell you. I'll say to be continued. We have to look into the moderation API. We have to look into text to speech, speech to text, multimodal. All of these things are what we have to see. This completes it for now. And let us actually look into the money which we ended up spending billing. $15.03. 15.03, $0.4. So I ended up spending 35 rupees from my pocket. 35 rupees spent from my pocket. And most of the money was spent on image generation only. Image generation is the one. Text doesn't take any money at all. When doesn't means it's so marginal. Your text model might have taken less than $0.01, less than $0.01 dollar. I can actually, if I get into usage, today spend, see, $0.4. Yesterday's spend was $0.44. This was today's spend, $0.4. And inside that also you can see today for the text generation, only 17 requests were sent. And for image, 13 requests were sent. And this is what we ended up spend categories also. If you want, you can analyze. We completed with the image generations, and today we are going to get started with the moderation API. So I say we will get started with the moderation API over here. Now, if I go to ChatGPT and still loading, yeah. If I ask it, can you tell me the process of suspiciously entering SRK's house to say him a hi without getting obstructed by the security? I can't help you out with any plans that facilitate breaking the law, right? If you actually want its safe legal way to meet is to increase your chances of legitimate interaction, here are the constructive way. Attend public appearances, watch for fans, meet, greets, etc., etc. Okay. What are the 3 ways to hack a bank account ethically? Good question. And there are legitimate ways. One is penetration testing. One is bug bounty, a red team, etc. Okay. Now, if you see over here, this worked, but this did not work because it was having some malicious request. If I say, tell me 2 ways of hacking my friend's bank account, I can't help with hacking breaking info. Why? Any request that we are sending to AI, anything that we are sending to AI, precisely our ChatGPT 5, whatever is the query, it first gets to the moderation API, and if passes, then only it is sent to the ChatGPT, which then replies. And that is exactly what we are trying to understand over here. So let's look into the moderation API. Now, if you look over here, the moderation API will ultimately give me one of the very important thing, which is called as flag, which will be either true or false. If it gives true, that means your query has fall into one of this category, sexual minors till violence. In this case, you can see violence is true. And if you come down, it also has got category scores, and among that, violence is expected to be the highest, 0.85. Don't consider this 2.3 to be highest because this is 2.3 into 10 raised to minus 7, which is not highest. This is 0.00000023413 and so on. This is 0.85. This is the highest. Now, what is sexual? What is sexual minors? Come down. OpenAI has given everything. What's harassment? What is harassment? Threatening? What is hate? Hate, this, right? What is sexual and what is sexual minor? Everything is mentioned over here in this link, right? So I say client.moderations.create, and the model is Omni Moderation latest. And I ask it, tell me 10 ways of hacking someone's bank account without getting caught by cops ever. What comes in the response? Let's try to figure it out. Again, you get that response, which is lengthy enough. So I will like to pretty print it. So I say import JSON response.model dump, and that's what you see. So where is this flagged flag? Now they have shifted it to the bottom. See, flagged is true. And that means one of it is true, illicit. illicit is true. And then among this, illicit is expected to be highest, it is 0.99. There is no value higher than that, as simple as that. If I say, in which direction the sun rises, it's a normal sentence. Flagged as false. If flagged as false, we ideally need not look into this. All of this will be false only. And the scores also, whatever be the scores, they are of no use to us. And that is what we see in over here. Right. Now, we have seen various types of prompting. Few shot prompting was one of the prompting technique which we saw. Now have a look at this. This is just text completion where I say system prompt is you are a helpful assistant. Where I say, as a user, if I ask you, what is photosynthesis and how does it work? As an assistant, you would reply, photosynthesis is the process by which green plants, algae, and some bacteria convert light, usually from the sun, into the chemical energy in the glucose form. And this process is ... And as a user, if I ask you, why is photosynthesis important for life on Earth? You would answer, it is crucial for life on Earth because it provides primary source of energy, etc., etc., ... So now as a user, I ask you, how does photosynthesis differ between terrestrial plants and aquatic animals? So it is expected to understand these two shots. And based on that, you would output essentially few shots. If I say, you are helpful Python programming assistant, how can I write a Python code to check if a number is even or odd? And this is the result. You can check whether it is even or odd by using the modulus operator. If when divided by 2 remainder is 0, it is even, otherwise it is odd. And then I say, here is a simple example. And one more assistant message, I can continue on the same line or I can add it like this. And then I have given this program. Then I say, can you explain how does the modulus operator work in this code? Because I didn't understand this code, so I asked it. And here it has started explaining it. If the remainder is 0, it means the number is divisible by 2 and hence even. If it is not, then this is the scenario, hence odd. Okay. Right, just an example of few shot prompting, and I can have multiple assistant prompts one after other. Maybe if I say this one, land.chat.completions.create model is this, you are a knowledgeable literature expert. If I ask you who was William Shakespeare, you say he was an English playwright, poet, and actor widely recognized for one of his greatest writing in English language and world literature. Born in 1564 at the Stratford, etc., etc. If I ask, why is he considered to be influential in literature, you answer it this way. So now I ask you over here, what are the main themes found in the Shakespeare's play? And then you get this answer with a wide range of themes, including the love, betrayal, ambition, jealousy, and etc. Other common themes include nature of identity, conflict between appearances, etc. Basically, it's an example of few shot prompting. Retrieval augmented generation. Because if you say that the curriculum is ending, then RAG is not there. In this course, it's not there. That is for sure. We have seen that. In fact, we have also populated the flow over here, right? So, oh no, it's there. I don't know. This was Yeah, I guess it was for you only. It's there. We are here. Hugging Face is done. Working with OpenAI and RAG is there, right? RAG, LangChain, fine-tuning, benchmarking. Good. Okay. Now, the next topic which I'm starting with is text embedding. Now, what is text embedding? Tell me, in our NLP, we understood that machines don't understand text. They only understand vectors. We have studied techniques like count vectorizer, TF-IDF, word to vec. All of these are techniques for converting text to numbers. Now, so these all are the techniques for converting text to numbers. I remember I have taught you all of this while I did the text pre-processing and all of the other topics. So now, today you don't have to implement these techniques. For example, so I have imported TensorFlow and I want to take few sentences. Then I will have to do one hot encoding, right? And then I'll supply to the embedding layer of the Keras to form embedding matrix, which is converting text to numbers. And embedding is one of the most powerful technique. And these are the sentences: the glass of milk, the glass of juice, etc. Then I am keeping the vocabulary size as 10,000, which is the hyperparameter that you have to choose. If you give 10,000, then it will assign one number to each of the words. Like, for example, when I ask it to one hot encode, you can see the sentence, the glass of milk, encoded as this, which is 6753860 and so on. Which means the is given 6753, any number between 0 to 9999. Glass is given 8640, off is given this, milk is given this. The second one was the glass of juice. So the glass of and the glass of is common. So these numbers here and here are common. Milk is 7058, juice is 6952. Done. After that, so we understood that one hot encoding has given one values. Now machines don't like such big numbers, and also the length, see, this is lengthier and this is shorter. So what we do is we convert everything to a standard length by padding, right? And then I'm creating a sequential layer and then passing it to the embedding layer by giving the vocabulary size as 10,000. And I say that from this, each of the sentences, extract 10 features. From this, extract 10 features. From this, extract 10 features, and so on. So I'm doing that. And now we get it like this. So the glass of milk is converted like this. This is called as word to wet. We have studied this. It's just a quick run up. The glass of juice is converted like this. This is also called as word to wet. And so on. So now, let's consider an example like this. So what are these? See, these are nothing but words, and someone has found out the embeddings for that. I'm not sure whether they are correct or not, but someone has found it out. Okay. And because there are 7 features which are extracted, living, being, feline up to plural, obviously we cannot represent it on a 7-dimensional data because we cannot see anything more than 2 dimension. So the author has converted it to 2 dimension and represented it. Now, is that correct or not? I don't know. Author has done that. I don't know. And if you see carefully in this 2-dimensional equivalent representation, cat and kitten are very near to each other. Maybe this representation of embedding is trying to say that cat and kitten are very similar to each other. And probably Dog and houses are not. This is what we understand. Now, I'm not sure about it. So how do I confirm it? How does a machine confirm it that the embeddings are same or not? We have a metric called as cosine similarity. So extract the embeddings of cat and kitten and find out the similarity in between them. But before that, explain cosine similarity. What are the various values that it can take with examples and the meaning of those values. Then show the formula for cosine similarity and show in detail step by step how it is computed between cat and kitten. So now, see, cosine similarity is going to compare this vector with this vector. How? Cosine similarity will always give you a result in between -1 to +1. If it is +1, that means two vectors are similar. If it is -1, it means they are opposite. And if it is 0, that means they are orthogonal. Orthogonal means they are neither synonyms nor antonyms. Like if I say spectacles, pen, are they opposites of each other? No. Are they similar words? No. Unrelated words. And if you see cosine similarity, it can take up the values between -1 to +1. +1 means perfectly similar. And two identical words. 0 is unrelated or orthogonal. They don't have meaningful name. Something like table versus justice. They will never co-occur or relate meaningfully. And -1 is perfect opposites. Like good versus terrible. Opposites. Now, real life readings, if you get 0.9, which means they are extremely close in meaning, maybe same topic, same role, same context, could be anything. 0.5 means they are loosely related, same broad area, but not interchangeable. 0 negative means unrelated opposite. So, this is the formula for calculating it. A dot B upon norm of A into norm of B. And it's very simple. This is cat and kitten. You know how is A dot B computed? This is A and this is B. So A dot B is 0.6 into 0.5 plus 0.9 into 0.8 plus 0.1 into -0.1 plus dot 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 till -0.2 into -0.1. That is A dot B. You can see that they have done the same thing. This into this into this, and total of all is A dot B. And then what is magnitude of A or norm of A? That is nothing but 0.6 square plus 0.9 square plus 0.1 square plus 0.4 square plus dot 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 till -0.2 square, whole in big root. The entire answer of the squares in a big root. You can see that this square, this square, this square. So total of this in root. Total of this 1.96 in root. And when you get these three numbers, you just substitute and you get the answer. I'm getting over here 0.96. So cosine similarity in between the two is 0.96, which means the embedding believes cat and kitten are extremely related concepts. They differ in some dimension, like age, young animal, etc., but they are similar. They differ in some magnitude, but have the same semantic neighborhood. So cat is a younger version of this, or kitten is a younger version of this. If I ask it between dog and houses, Can you quickly calculate it between dog and houses? You can see it came out to be minus 0.37, which means the vectors point in roughly opposite direction, which means the model considers dog and houses semantically unrelated and even slightly opposite in the embedding space. And this is what we understand. I will add on to this. So the thing is, friends, today, if you have to calculate embedding, you don't have to really put in a lot of effort. You have all of this ready-made available. You already have pre-trained embedding models which can be straight away used for solving your purposes. And this is exactly what we are going to look into right now. So I say from OpenAI, import OpenAI and create an instance of it. And then I'm giving an input sentence. I am learning OpenAI SDK. And I'm giving the model as text embedding 3 small. And response is what I'm printing. And I'm also printing the length of the response. So it gave me in the response a vector of this sentence. I'm learning OpenAI SDK. And the vector is of length 1536 because the text embedding 3 small will always load it and extract 1536 features out of it. This is how it has been trained to. This is how it has been trained to. This is text embedding 3 small. If you go for text embedding 3 large, it will extract around 3072 features. It will extract around 3072 features. If you have multiple sentences, now this is optional, but if you have multiple sentences, let's say, I love playing football. Playing soccer makes me happy. The quick brown fox jumped over the lazy dog. And AI is transforming technology. So what it did, it calculated the similarity in between each of the sentences. How? See, these 4 sentences are here. First row, second row, third row, fourth row. And these 4 sentences are in the columns also. First, second, third, fourth. So I love playing football versus I love playing football is having the cosine similarity 1. This is between second sentence number 2, playing soccer makes me happy versus sentence number 1, which is I love playing football. This is between sentence 3 and sentence 1, sentence 4 and sentence 1. This is sentence 1, sentence 2, sentence 1, sentence 2, sentence 2, sentence 3, sentence 2, sentence 4, sentence 2, and so on. So I didn't do anything new in the code. Inputted this model. And then I iterated over each of the response because 4 responses would be there. And I'm calculating the embedding and storing it into NumPy array. And that embeddings which I got, I've given it a cosine similarity. And I just iterated over it and printed it. That's it. Now, if you, I'll share with you some optional code which I generated using ChatGPT to plot it. This is optional. Huh? Just like here, we saw that this 7-dimensional data was represented into 2-dimensional. In our case, we have got 1536 dimension data, and I want to convert it to 2-dimensional. Right? Using the same OpenAI model. So if you see over here, sentence 1 and 2 are similar. I love playing football and playing soccer makes me happy. They are close to each other. Sentence 3 and 4 are apart. Quick brown fox and AI is transforming. And that makes sense. Now I actually converted this to the Plotly code. To, when I hover over it, I don't see anything. Na? So Plotly is little dynamic. This is again optional. So with Plotly, the advantage that you get is when I hover over it, I see the values. I love playing football. Playing soccer makes me happy. So I get these values. Optional. What double? This completes it. Now we get into the next one, which is text to speech. Now we are going to get into the text to speech. Now, if I have some text and if I want it to be converted to speech. So I have some text which says, today is a wonderful day to build something people love. We'll look into the code later, but today is a wonderful day to build something people love. I ran it. And this is just a warning. That's not a problem. The output is saved into a file by the name output.mp3 in the local path. I'll just go over here and check it. You see that? If you don't see it for some reason, just refresh it. It will come. Okay. Now, if I click on this three dots, I have to download and play it on my maybe Windows Media Player. I don't have that much time. So I will add player here only. And let's hear to it then.
Today is a wonderful day to build something people love.
Exactly what we wanted.
Today is a wonderful day to build something people love. Today is a wonderful day to build something people love.
Let's look into the code. From pathlib import path. Ideally, in this code, we don't need it, right? It helps in managing the file paths easily. It can make the working with the files more reliable. Even though path is not used directly in this block, it is commonly included when we want to save the outputs like an MP3 file. But when we have to save it into a particular location at those points, we need this path. Here in this code, we are not actually using it. So the first line is kind of optional. Then I say, this is known. Client.audio.speech.create. Model is TTS1, text to speech 1. Voice is Alloy. Now, who is Alloy and from where are you getting it? Let me click on this. Here is Alloy.
The sun rises in the east and sets in the west. This simple fact has been observed by humans for thousands of years.
Yes. There are some more models like GPT-4o Mini. I'll be using it. It comes with 11 built-in voices and tones. And if you see carefully, following are the tones that the model can take: accent, emotional range, intonation, etc. Other models are this. We use TTS1. You have TTS1 HD also. This is having a lower latency. That is, it is faster, but lower quality than our HD model. And if you want to see what all other voices are available other than Alloy, so many are available. And you can hear and play these voices at this. I want to hear Ballot as a fitness instructor. Play.
All right, team, let's bring the energy. Time to move, sweat, and feel amazing. We're starting with a dynamic warm-up. So roll those shoulders, stretch it out, and get that body ready.
So it is also giving the code over here where I can run it. If you want to hear Coral as a mad scientist.
The stars tremble before my genius. The rift is open, the energy surging. Unstable? Perhaps. Dangerous? Most certainly. Captain Ryland's.
Let's try to hear Coral as a cowboy.
Well, now, partner, you've made it to tech support. Let's see if we can't get you fixed up. If your internet's giving
One last. Sage as Santa. Sage as Santa.
Oh, Merry Christmas. You've reached Santa's workshop. How can I help you today? For toy requests, press 1. If you're on the nice list, press 2. If you're on the naughty list, press 3. To speak to an elf, press 4.
Right, you saw that, right? So now, coming over here. So we can give any name over here, what we saw, and this is our input. This response which comes, I am saving it to the output.mp3. And then for displaying, I'm importing the audio class from the ipython.display, which creates a player here only. We also have one more, right? With client.audio.speech dot with streaming response create. The model is GPT-4 mini, which they just said in the link. Voice Coral. And I said, today is a wonderful day to build something people love. And I have instructions parameter as well, which I can give over here, which says, speak in a cheerful and positive tone. And that is what you see. I already ran it. So the file is saved in this path, which is speech.mp3. You can see that here. If you don't see it, refresh it. I have to play this. Same thing.
Today is a wonderful day to build something people love.
You see, cheerful and positive tone.
Today is a wonderful day to build something people love. Today is a wonderful day to build something people love.
And if I give the same thing and I ask it to speak in a sad and demotivated tone.
Today is a wonderful day to build something people love. Today is a wonderful day to build something people love. Today is a wonderful day to build something people love.
Right. If I rerun it again, little bit changes are expected.
Today is a wonderful day to build something people love. Today is a wonderful day to build something people love.
And that is how this topic comes to an end. Then that was text to speech. And now, fortunately, I have 2 speech files ready. Let's get into speech to text. Now, I need some speech file for that. I'm going to use this only. It will be easy and convenient for me. Now, I am importing OpenAI, creating an instance. The file path is this, speech.mp3. And I'm opening it in the read binary format. And I say client.audio.transcriptions.create. And that's it. I'll be getting the transcription. And that's correct. Even if I rerun it, it's correct. The next thing, describe an image. And let's see. The image shows a wooden boardwalk or a pathway through a lush green field with all the tall grasses on either side. Right? Boardwalk, tall grasses on either side. In the background, there are some trees and bushes. That's correct. Trees and bushes. Bushes. While the sky above is blue with scattering of the white clouds. The scene appears to be during the daylight with soft sunlight illuminating the landscape, giving it a serene and playful, peaceful atmosphere. Image type is URL, and this is an image on the internet. And that is what we are asking it to work on. Right. Now, I gave this code to ChatGPT and I asked it to accept an image from me rather than a URL. So this is the first image that I have, which is parrot.png. You can see this image. I'll just go and give which I copied. And I'm asking it to describe this image in detail. Image is black and white photograph featuring two macaws in close-up. Both the birds have prominent curved beak and characteristic facial markings. This one, around their eyes. The macaw on the left is lighter beak with pronounced black black tip, while the macaw on the right has a larger, more uniformly colored beak. Their feathers show intricate details, with the bird on the left appearing more in profile and the bird on the right slightly facing forward. The background is blurred with soft circular bouquet highlights. Yeah, you can see that. While emphasizing the macaw as the main subjects, the details in their feathers and eyes are sharp. The photo giving the photograph a striking and vivid quality despite being monochrome. That's good. Just like I gave earlier, I don't remember whether I gave it for your batch or not, but there is one more photograph which I have. This is me. I'm copying the path of this. And I asked the model, what is in this image? And which location is this photo taken? So if the location is prominent, then you will find the information, else it will say it's not capable of judging it. Let's check it out. The image shows a man standing by a river looking at the chapel bridge. Okay, so it is able to figure it out here only. A famous covered wooden footbridge with flowers. The bridge spans through the Reuss River and features a tall tower known as Wasserturm, which is the water tower. The photo was taken in Lucerne, Switzerland. The chapel bridge is one of the city's most iconic landmarks. If I paste it and maybe if I try it with some other random photo, which is this one, I'm asking it the same question. What is in this image and which location is this photo taken? Now, this is a little difficult, right? It is a normal photo, but it is generic. No one can exactly figure out. It could be Manali, it could be Kodaikanal, it could be Ooty, it could be Mahabaleshwar, it could be anything. So we ask it. We can see there are two cars in this image, one kid in this image. The background is overlook, mountains and trees in the background. There is a manhole over here and tiles over here. I ask it. The image shows a young boy standing next to a red SUV on a rainy day. The area appears to be paved parking lot or driveway with some greenery and hills in the background. The sky is overcast with the clouds, suggesting the photo was taken in the hilly or the mountain areas during or after rainfall. However, based on just this image, I cannot accurately determine the specific location where the photo was taken. The scene looks like it could be in a variety of places with similar weather and geography. If I ask it over here, let's say, how many animals do you see in this image? Now, there are no animals. There are no animals. There are no animals. It shows a child standing near a red car in the outdoor setting. I'll take this dd.jpg and I'll try asking the same questions. Are there any animal? And it says, I see one animal in the photo, which is a duck swimming. Can anyone see a duck swimming? Just answer with a yes or no. I'm sure earlier you didn't see that. But earlier you didn't see that. Now you can see this here, right? You are referring it here, right? Those of you who are able to see it, it's here, right? Yes. So model has taken care of it so nicely. Duck skimming in the water near the left side of the image. And that's absolutely correct. So it's looking into the things very minutely. And that is something which is really very nice. I knew that, and hence I tried it. I say, list down all the objects that you see in this photo along with their count. One person, bridge with wooden roof and flower pots, one. Flowers in the pot, estimated clusters, numerous, too many to count individual, water body or river canal, one. Metal railing, one. Stone pavement, one. Two ducks in water. Acha? I'm not sure where. Crane, which is orange construction crane. Where is that? Oh, this one. Beautiful. Buildings in the background, multiple, around 3 distinct buildings. 1, 2, 3. Yeah, that's very nice. What more do you expect? It's doing it very nicely. If I ask it to do it for this triple D, which was this one. One red car, one black car partially visible. One child, trees, plants, multiple, too many to count. Pavement tiles, numerous. One manhole cover. And road or walkway made up of different material, which is this paving material. And this is something which is interesting. So with that interesting thing, we complete with the OpenAI API. I save it, go to runtime, disconnect, delete runtime. Now we are done with point number 7. Now we get started with the GANs and the VAEs. And then LangChain, RAG, fine-tuning. More than GANs, these are the important topics. I don't remember whether I discussed it with you, but I think I should have when I did show you the deck. This person does not exist.com. Did we visit this link earlier? Yes. Right? So when I introduced to you generative adversarial networks, no, not generative adversarial network, your generative AI. At that time, we might have discussed it. Now let us get started with this. Generative adversarial networks, or GANs, which is the short form for this. And the GANs were discovered by Ian Goodfellow in its Montreal Research Lab. And the main idea is to generate images. So it was considered as one of the great advancements in the machine learning, and they have numerous applications. And perhaps one of the fanciest one is this, what you see on the screen. This person does not exist.com, right? Where it can generate so nice looking images if you see carefully. Right? So these are the people who does not exist, and they have been fully generated by using neural networks. And if you see how detailed the expressions in this are, we are very happy to see how this looks like. Now, Let me explain, or let me get started with the idea behind the generative adversarial networks. So the general idea of the GANs, it consists of a pair of the neural networks that are going to fight with each other. So one is called as a generator and another is called as a discriminator. These are the pair of neural networks which are going to fight between each other. As you see, two neural networks, generator and discriminator, and they behave more like a counterfeiter and a cop. For example, let's say, how will you identify this image? Real or fake? You have to identify it as real or fake. How will you identify if you are not knowing? If you say fake, you have to justify why. So look carefully before you, because you have to justify it. Or will you identify it as real? Real, yeah, I mean, there can be a tall person over here. Looks real only. That's correct. Looks real only. This also looks real. This one as well. This one also looks real. This one as well. This one as well. This one as well. Real. 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 Well, I am also identifying this image as fake. I am on the fake side for this image. Ah, yes, exactly. Exactly. If you see over here, don't you think this is some problem in the image? In fact, if you look over here also, what can this part be of the skin? Yeah. This part, what can this be? In a bad photo means how can this come at least? See, then it is fake only. Then it is fake. Real is real, na? Anything other than that, even if it is edited, it is fake only. Right? So you have to identify whether it is real or non-real. Rather than saying fake, you have to identify whether it is real or non-real. Again, if you see, we are not exactly understanding what is over here, and see here. And how about this? Real or fake? I think this is, how can this shoulder have this kind of shape? And if this is some other person, then where is this girl's shoulder? Tell me, what do you think about this? Real or fake? A pair of neural networks, generator whose job is to generate fake images, and discriminator whose job is to catch the fake images. So you are the discriminator. You are catching whether the images is real or fake. So you are the discriminator. Or more nicely, I can say, consider this to be like a counterfeiter and a cop. So you are the cop whose job is to catch whether the generated image is real or fake. And there is a generator whose job is to generate fake images. So the counterfeiter is constantly trying to generate fake paintings. And the cop is constantly trying to catch the counterfeiter. So the counterfeiter is the generator and the cop is the discriminator. So as he gets caught by the cop, the counterfeiter keeps on improving. And he keeps on improving and improving his painting unless he learns to finally paint a perfect one. Like the counterfeiter generated the first painting. And we say, we are the cop, right? We say it's a fake image. No. Then we generated a little better painting. We say, no. Generated little better. We say, no, it's a fake one. Generated little better. We say, no, it's a fake one. And then we generated this. And everyone will say, oh, this is a perfect Mona Lisa painting, right? So we are finally able to create a painting. The generator was finally able to create a painting that completely fools the cop. So a neural network, in neural network language, what was happening over here is we are having a network something like this. A generator and then discriminator, right? So the generator and the discriminator, both of this, and we are training them with a set of real images and fake images, both. So one real image will be sent, one fake image will be sent. One more real image will be sent, one more fake image will be sent. So what will happen is, somehow I'm going to tie this thing together. So when it is generating a fake image, it catches. When it is giving a real image, it says that it is good. So this generator is observing. So generator is observing that, I am at the police station and me and someone else is there. That person came and submitted a photo and the police says that, yes, this is a good photo. And when I am submitting a photo, he's saying, no, it is fake. He's submitting one more photo and the police says it's good. And when I submitted that, he's saying fake. So what is good exactly? It is continuously observing and it is going to improve over the time. So we give this, generator gives this, fake. Then we give this real image, generator gives this image, fake. This keeps on improving over the time. I give this, it says fake. I give this, it says fake. So I'm giving real, fake, real, fake, real, fake, real, fake, one by one. I give this, and wow, I was able to create an image. It is just like you are creating, you have seen that Fuzzy web series by Shahid Kapoor? Have you seen that Fuzzy web series by Shahid Kapoor where he was engaged in creating fake notes, right? Learning over the time to create a fake note which looks so real that it is accepted in the market universally. Yes. That is what is the USP of this. So we are learning from what is real available. That is what the generator is doing over here. And that is how it is able to do that. So now, let's start our technical journey, right? So we will be building a very simple pair of GANs, so simple that we will be able to code it straight in Python without even using any deep learning packages. Now, our setting is something like this, friends. We live in a world called as slanted land, where everybody looks slightly elongated and walks at 45-degree angle. This world has a technology, but not as developed as ours. So they have a computer screen which displays images, but the best resolution they have been able to work on is 2x2. So they have a black and white 2 pixel cross 2 pixel screen. Also, they have developed a neural network, but that is also very, very simple. As a matter of fact, they only know neural networks of one layer. But I'll show you that in this simple world as well, we can still create a pair of GANs that will generate faces of the people who live in this slanted land. So here are some of the faces that we have. So I was saying that people who are living in this slanted land. So that's our setting over here. Everybody is elongated. So everybody is elongated, right? So, and it is tilted 45 degrees to the left. Now, since the screen is only 2 cross 2 pixels, this is something how you are likely to see their pictures in the screen, where you can see they are just small people, which are kind of in this diagonal, which looks like a backslash. If you see, the prominent colors are here only. This is the prominent pixel. Darker ones are here. Darker, darker. All right. And if you look at these ones, these are noisy images. If you notice, these are not faces because they don't look like backslash. They are mostly generated randomly. So the goal for our network is to able to distinguish faces like this from the non-faces or the noisy images like this. Okay. So let me attach some numbers with it to have a scale. As you can see, 0 to 1 is the values. You can see faces, higher values on the diagonal, and non-faces are having any pattern. Now, if you see over here, a white pixel has a value 0 and a black pixel has a value 1. I know I taught you this the other way. We have seen the opposite way, but we will do it this way only just for clarity, right? So this way we can attach values to each and every pixel in our 2 cross 2 screens. And now let us go ahead and build our cop, which is nothing but our discriminator. Let's go and build our discriminator. Now, discriminator is something which we already know. Have we not worked with MNIST image classifier? What are we doing over here? Same thing is the discriminator. So now let us see, and let us actually start by building our discriminator. So the first question is, how are we going to tell the faces apart from the non-faces? And that is very simple. If you notice that in the faces, the top left and the bottom right corners are having larger values, and that's because the pixels are dark, whereas the other two have a smaller value because their pixels are light. On the other hand, if you look into the noisy images, then anything can happen over there. Therefore, the way to tell faces apart from non-faces is by building, is by adding the values on the top left and the bottom right, which is, consider this to be +1, +1, +1, +1, and this to be -1, -1, -1, -1. So what are we going to essentially do is a very simple thing. This is 1, 1, 1, 1. So this is +1, -1, +1, -1. 1 into 1, 0 into -1, 0 into -1, 1 into 1. Total is 2. Similarly, over here, 1 into 0.25 plus -1 into 1 plus -1 into 0.5 plus 1 into 0.75. You get it like this. And then we add a cutoff or we add a threshold. Let's say we are adding a threshold of 1. And we say that any image that is having the value 1 or higher is a face, and anything which is not a face, which means this is a face and this is not a face. As simple as that. Or a noisy image, whatever you can call it. So now, in neural network lingo, how is this going to work? This was a layman explanation. In neural network lingo, you have a neural network like this. How do you supply it to a layer? This is the image, and this is how we look at it. The values of our 4 pixel get multiplied by either plus or minus 1 depending on what diagonal they are on, and then we subtract the total value of 1 or the bias, right? So we add these 4 numbers, and if the score is 1 or more than 1, then it is classified as an image. So here 1 into 1 plus 0 into minus 1 plus 0 into minus 1 plus 1 into 1 plus bias, which is W into X plus B. We are just doing W into X plus B, which we do over here. And we look at this value. If this value is less than 1, then it is classified as a face, else as a non-face. Now, in this case, this answer comes out to be 1. And because it gets a score of 1, we are going to put the probability that something is a face using the sigmoid function. Just like we do that, activation function is applied over the output of W into X plus B. So I am going to calculate sigmoid of 1. And we know how sigmoid of 1 looks like. Sigmoid is going to give a value between 0 to 1. And this gives a value of sigmoid of 1 is 0.73. And this is the final answer. And then because 0.73, right, because 0.73 over here is the probability, and it's greater than 0.5, we say that it is the probability of it being a face is higher because it is greater than 50%, and we conclude that the discriminator thinks that the image is a face. Have you studied something new? Don't say that. You are not studied anything new. This is exactly what our A and N used to be. Absolutely the same thing. This is exactly what our A and N used to be. Nothing new. Then. And this is absolutely correct. So if you notice over here in this figure, wherever I have written +1, see the lines are thick. And wherever it's -1, they are thin, just for convenience. Right? Okay. Then. So I'll be using the same conventions throughout this deck. Whenever you say thick line, it is +1. I may not write the number, but you need to remember that thick line is +1. So now, if we, this was a face. Now, if I come over here and I try this non-face, what is going to happen with this? We do the multiplication, W into X plus B. You get this, and sigmoid of -0.5 comes out to be 0.37. Therefore, the discriminator thinks that this is not a face. All right. That's absolutely correct. Now, actually, we'll get started with building a generator. Right? Now, this is going to be the most interesting thing, right? So What is generator, right? This is going to be a neural network that will be outputting faces. And for building it, we will have to take into account again the two corners, right? So what does the generator want? What does the generator want? It wants to generate faces, that is high corner values at the top left and the bottom right, and the low values on the other side. And what it does not want is it does not want to generate noisy images or the non-faces where anything can happen. So how is the generator going to work? Now, honestly speaking, it has no idea. Neither it is a human that it can think, observe, and do anything. It starts with random. Random means random. It will say, Darshan, I will choose a number in the range 0 to 1. How does that help? So it will start by picking up inputs between the number 0 to 1, between the range 0 to 1. And in this case, I'm assuming that, let's say, it ends up choosing this number as 0.7. So in general, the input will be a vector that comes from some fixed distribution, right? It will not be a single number, but when you have to actually generate a big image, it will be a vector, a random vector or a random array of values that it will be improving step by step over the time. But here, because we are building a 2x2 network for our easy understanding, we are taking a single number. So that is going to be a scalable version of that. If I explain you with that, the big one, you will never understand the architecture. So this is the best way to understand. Trust me. So let's build our neural network. So what we really want is to have some large values and some small ones. What we really want is to have some large values and some small ones. The larger ones are represented by the thick edges and the smaller ones are represented by the thin edges. Because remember that we want large values where? We want the large values here and here. And in the other two places, we want the small values. So, how do we get this? We have selected just one number. Now, I'll be having values. So this first one, this is +1 over here, right? So this is 0.7 into 1 plus this bias. You get 1.7. Then this is 0.7 into -1 plus this bias, which is -1.7. Similarly, you do it for this, and similarly, you do it for this. You get 4 values. You find the sigmoid of this 4 values. And this gives you the following values. I am going to put it over here. This gives you the following values, which I'm going to put it over here. Now, if you notice that our image looks like a diagonal, which is how we define our faces noticed, right? And by the way, our neural network will always generate large values for the top left and the bottom right this way, and small values for the top right and the bottom left. So no matter what values we input, because remember that, the value is always going to be between 0 to 1. So this neural network will generate a face. That means it's a good generator if it generates a face. But that is not so easy. That is not so easy. Here I explained you with the help of certain weights, but that is not always so easy or so straightforward. So, of course, we need to build a neural network by eyeballing the weights, but that is not how it normally happens. In general, we know we have to train the neural network to get the best possible values of the weight. This was just an assumption for better understanding. So for that, we need to understand a little bit about the error function or the cost function, which is the way to tell the neural network how it is doing in order to improve. And if the error is large, then the neural network is not doing well and needs to reduce the error in order to improve the error function. So we'll be using this to train the things, and the log and the loss function, which I'll be using, is the log loss. I'm using the log loss error function over here, which is nothing but the natural logarithm to the base e. And to be very honest, there are many log functions. This is not the only one. There are many loss functions, but log loss, it is more popular for the GANs for many deeper reasons. I'm not getting into that, but log loss is something which is very popular. And for now, we'll just get started with this. So that's one of the most convenient functions. Now I see, let's get into this. This is something which is very, 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 very important. This is something which is very, very important. So I will need your inputs as well over here. So let's first say that we are having a label of 1 and our neural network predicted 0.1. See, label means the actual is 1 and the prediction is 0.1. On a scale of 0 to 1, I repeat, on a scale of 0 to 1, when the actual is 1 and the predicted is 0.1, tell me it is a good scenario or a bad scenario. Is it a good scenario or a bad scenario? Bad scenario, right? Yes. So obviously error is going to be large and it is a bad scenario. On the other hand, can I say over here the error is small and this is a good scenario? Of course, yes. Because actual is 1 and predicted is 0.9. Right? So this is something which is good. So there should be a small error. Now, then we have to find a formula for this error function. If this is what we are trying to achieve, then we need to find a formula for our error function. So, as I told you, the formula that we are going to use is the negative natural logarithm of 0.1, which is 2.3, which is large. The reason I say large is because if you take the negative logarithm value of the 0.9, which is the next one, it turns out to be just 0.1, which is low. And as a matter of fact, the closer the number to the 1, the smaller the negative logarithm gets. I repeat, closer the number to 1, the smaller the negative logarithm gets. Yes, so this is what we understand. The closer the number gets to 1, the smaller the negative logarithm is going to be. Right. Therefore, when the label is 1, I can say the error function which I'll be using is going to be minus ln of the prediction, minus ln of the prediction, which is minus ln of prediction. One of the very important things that you have to remember when you want 1 as the actual output, then this is the error function. I'm sharing it as a screenshot in the chat box because this is something which we'll be needing. Now, friends, what are we having the actual as 1? Let's look into the next one. When the actual is 0 and the prediction is 0.1, tell me, is it good or bad? Just a thumbs up. Good or bad? Actually 0 and prediction is 0.1. Good, na? Yes, because we wanted it 0 and it is very close to that. Absolutely correct. So for this, the error function must give it a small value. And when it is 0, but the prediction is 0.9, then the error function should give it a large value. So over here, we will be using the same log loss function, but with a slight difference. And that difference is going to be minus ln of 1 minus prediction. Jugaad. This is called a jugaad. So if you do, instead of 0.1, minus ln of 1 minus 0.1, which is 0.9, it is 0.1. And if it is 0.9, you will do 1 minus 0.9, which is 2.3. And that is what we see. So I can say whenever the actual is 0, the error function is minus ln of 1 minus prediction. Another important image which is shared in the chat box because they are needed. Now, what do we understand? We understand over here, if I have to summarize, listen to this very carefully. If the label is 1, which is our earlier scenario, 2 images are shared in the chat box. If the label is 1, it means that we want the prediction to be 1. So we define the log loss to be negative logarithm of prediction. If you notice in the graph of the negative logarithm on the x-axis on the right, this is big when the prediction is close to 0 and it is small when the prediction is close to 1. Right? It is big when the prediction is close to 0 and it is small when the prediction is close to 1. And then if you look over here, right? When you look, the label is expected to be 0. I want the prediction to be close to 0. In that particular case, we are using an error function, which is negative logarithm of 1 minus the prediction. And from the graph, again, we can see on the negative logarithm of 1 minus x in the right, we can see that when the prediction is close to 0, there is a low error. Whereas when the prediction is close to 1, there is a high error. So these two are the error functions that we are now going to use for training our generator and the discriminator based on if we want the prediction to be 0 or we want the prediction to be 1. Important thing. So those 2 screenshots which I shared are the most important thing. So now we have our error functions ready. Now we get to the meat of the training process, which is back propagation. So I'll be explaining it in in a very brief way. The way we train our neural network, what we have learned so far is we first take the data points and we perform a forward propagation, right? This, then this, then this. You perform the forward propagation. Then the prediction is there. From the prediction, you calculate the error, right? You're calculating the error based on the log loss function that we decided previously. And then we proceed to take the derivative of the error function based on all the weights used in the chain rule. Right? All of these are updated. And this will tell us how much to obtain each weight in order to best decrease the error function. And the way we do that is we do that using the derivative process, which is called as the gradient descent. Long story short, what you do is you plot the arrows back, then calculate the gradient in the descending order of slope, as you see over here. Then it will come here, then it will come here, then it will come here, here, till it reaches here. That is done by calculating the derivative at the various points and finding out the loss function. Right? This is how the overall thing works in the direction of the greatest growth is where it works. So we move by taking tiny steps in the direction of the negative of this gradient in order to find the new parameters that decrease this error function as much as possible. Now we are ready to train the generator and the discriminator together. We understood discriminator individually. We understood generator individually. Now we are going to do that. So now, after this, we'll go on a break. After this training is over, we'll go on a break. So let us now get into training the generator and the discriminator. So we have the generator and we have the discriminator, both of them in place. And if you notice that the weights are not yet defined. So actually in real life, we start by normally go with the random weights. Same thing is going to happen. I was using +1, -1. That was for your easy understanding of the concept. In real life, these weights are learned as it happened every time in the past. So now we are going to do something where I'm going to select one random number, which is being selected. Any number between 0 to 1, which is going to serve as the input to the generator. And we do the forward pass of the generator to obtain some image. So it will do the same multiplication and all the biases, and it will generate an image after applying the sigmoid. And then once you get that image, what we'll do, so this is an image. Now it is probably a face looking at that, but it may not be a face also. You never know, right? Honestly speaking, it started with a random value, output will be random, and slowly, steadily it is going to improve. We want it to be a face. So basically, instead of saying we want it to be a face, the generator says, I wish this is a face. And the discriminator says, no, I will ensure that this is caught as a fake image because you generated it. So now this is going to be our important point over here. Now we pass this generated image through the discriminator as I explained you earlier. And it will tell whether it is a fake image or not. So pass the generated image to the discriminator. And because it got a value 0.68, now whether it will generate it as a real or a fake image. See, we got a probability, let's say over here, it is 0.68. Now let us pay close attention because this is exactly where the rubber meets the rope. This is where we define the correct error functions. We have discovered two error functions, minus ln of prediction and minus ln of 1 minus prediction. So that is what we are trying to understand over here. So now we'll have to define the error functions. Learning rate, how is it defined? We never talked about this, Sandeep. We can put this question on hold. There is nothing called as learning rate. Over there in the loss function, it's not defined. You have to choose any value over there. It's a hyperparameter. So you don't have to define anything. These are small hyperparameters. We are looking into the training process. So learning rate is just one of the hyperparameter which can be tweaked anytime, which will be defining how the back propagation happens. But for now, it's not important. Okay. Right. Cool. Thank you. So now let us think. See, what does the discriminator want? What does it want to do over here? See, if the discriminator was great, then what it should output? Well, it should output that this is not a face. If the discriminator was awesome, then because the image is generated by the generator, the discriminator must actually say it's a fake image. If the discriminator was awesome, it should say it's a fake image. And therefore, I can say that fake image means that the discriminator should definitely be outputting a 0. Because if you remember the error function, we measure an error function when we want the neural network output a 0, is we use the negative logarithm of 1 minus this. Because we want the discriminator to output a 0, the error function is 1 minus prediction, as you see in the chat box. So I use that, and when I look into what generator wants, generator is praying, God, please, somehow this image be accepted by the discriminator. Please, 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 let this image get accepted by the discriminator. Let it say that this is a real image. Let it say that it's a real image. So it wants 1. Generator, red color, wants 1. So the one who wants 1 uses the error function minus ln of prediction. And this is what we are having, right? Now, this is what it wants, right? One of the wildest dream, right? And it says, it does that. So whatever the generator wants, let us better shift it to the generator side only, right? So this is the error function of both of them. And now this will help us to train the weights. So now in other words, I can say if G of Z is the output of the generator, G of Z, so Z is the thing, right? So if I say the output of this is Z passed to the generator, then what is the output of the discriminator? This G of Z passed to the discriminator. This G of Z passed to the discriminator. Therefore, I said if G of Z is the output of the generator and D of G of Z is the output of the discriminator, then the error function for the generator is going to be negative logarithm of D of G of Z, which is something like this. And for the discriminator, it is 1 minus, so it is negative logarithm of 1 minus D of G of Z. This is what we see over here. Very, very important. And then the derivatives of these two are what we will be using to update the weights of both the neural networks. So these two neural networks are fighting with each other, one trying to achieve the error function, this another trying to achieve the error function, which is this. And if you notice that these two error functions are fighting against each other, but that is okay because the red error function only changes the generator weights and the blue error function will only change the discriminator weights, and therefore they will never collide with each other. In fact, they will simply improve and improve and improve, just as similar to giving different outputs every time. And this is something which is really fascinating. See, a time comes when you are giving so many images and it learns to minimize this loss function. Now you will be like, but the loss function is also minimized by this. So if this is improving, then this is also improving. And that is exactly where I will like to come to you. In the start of this deck, I explained you, in the start of this deck, you remember I explained you, or I asked you to tell me from the website, this person does not exist.com. I asked you whether this is real or fake images. We generated around 10 to 15 images, and for almost 13 of them, we were able to identify that they are real in spite of they being fake. And for two of them, one was for this and one was for something else, I don't recollect. We were able to identify that it is fake. That means in spite of us being very awesome, in spite of us having the loss function very minimum, because this time the generator itself generated so nice images that I was forced to say that it is real. That is exactly what is happening. So though both of them are becoming better and better, but generator is going to become relatively more better over the period of time, and therefore it is expected to generate more human-like faces, and therefore the error function of the discriminator will also be getting fooled at a certain point of time. But that doesn't happen in just one epoch, but it happens when you repeat it for many times. When you repeat it for many times, it happens. So you choose a value between 0 and 1, pass it through this, calculate the sigmoid and get an image, get it through the discriminator, get an output. Then you pass a real image as well, you get an output, and this process you keep on repeating many times, and after many iterations, what you get is the perfect values of the weights and biases, which is able to generate real images, fake images which looks real, right? So we are giving this, it is generating because I have found out the right values. A time will come where it generates an image and discriminator will say that yes, this is exactly a face. The only difference in between a real GAN versus this smaller version of GAN, this is also real, but it is smaller version, is you are not generating just one number, you will be generating a array of numbers, because you are going to generate 28 cross 28 image, or maybe 254 cross 254 image. So it's not from one image you generate a matrix, but from an image matrix. So now this is the thing that we have. So we are generating fake images using the generative adversarial network. If you see, following are the steps that we are going to follow. Importing the necessary libraries, which is loading and pre-processing the data. And then after that, building a generator, building the discriminator, then compiling it, the loss function used, maybe same, maybe different. I think it's different on the Simplilearn's notebook. And then we are training the models, and then we are executing it, right? So let us get into the imports. The first thing that we see, so what is this? We are talking about building a generative adversarial networks, right? So I want to generate fake but realistic images, and to use that, we are using GANs, which is having generator for creating fake images and discriminator to detect whether the image generated is real or fake. And I'm going to train this using TensorFlow. So as you can see, I have imported TensorFlow library. Then I'm going to import the MNIST data set. We know, right? Just to recall, it is a data set of handwritten digits. 70,000 handwritten digit images are there. Each image is 28 cross 28 pixel. It's grayscale images only. So what are we going to do? So over here, the idea is something like this. We will be training the data set as real images to train the GAN. So we'll use this data set as real images because we have to give real and fake images both. So generator will learn to create fake images looking at the MNIST data set. And the discriminator will learn to distinguish between real and fake. As simple as that. This is how the overall process is going to be. So we have defined the input layer for the input shape, dense layer, which is the fully connected feed forward layer for between the generator and the discriminator. You have the reshape, which is going to reshape the data, converting the 1D data to the 28 cross 28 images, right? It will convert to 1D from 28 cross 28 and flatten. Sequential, we know, right? It is a sequential API, which is the basic way to build a neural network. So for creating both generator and discriminator, I'll be using the sequential layer, and NumPy though is needed only. We know that very well. Okay. So then we finally go to load and pre-process our data. So what happens? The loading part is more or less the same. First, I'm saying mnist.load data. Now, if you see over here, one thing interesting, when I say mnist.load data, it loads 4 parts: xtrain, ytrain, xtest, ytest, right? Ideally, we know that it is expected to return 4 parts, right? Ideally, we know that it is expected to return 4 parts. But the thing is, you might have seen I have written underscores over here. So underscores means I don't want to use them, but I cannot skip writing them. Underscore means I don't want to use them. I don't care about them. But of course, you cannot leave it empty. So we use underscores in Python. So they will be loaded, but we cannot call it. So now what do we have at the end? Xtrain will be having 60,000 images for sure, right? And we don't need anything else. Therefore, I said we will ignore the labels because GANs are unsupervised. They don't need to know which number it is. They will only learn the pattern of the images. So in our case, this xtrain is going to act as the real data set that the discriminator will see, and the generator will try to create similar looking fake images to fool it. Simple. Then the next one, if you see, xtrain.as type to np.float32. Now, what are we doing over here is, if you ask me, np.as float32, which will just, it will take the integers and convert it to floating point format, which is required by the TensorFlow. And then you see over here, pixel minus 127.5 upon 127.5. You know what does that do? It scales the values. It scales the values between -1 to +1. Last time we scaled it between 0 to 1, right? Here we are doing it between -1 to +1. Why not scale between 0 to 1? And the thing is, -1 to 1 is symmetric around 0, which helps the activation functions like tan h to work better, because sigmoid predicts in the range 0 to 1 and tan h predicts in the range -1 to 1. And because we are going to use that, we are doing it this way. As simple as that. Now, this is what we do. Then the next one is, I say np.expand dimensions xtrain axis equal to 3. So expand dimension, what is that going to do? It will add one more dimension, which is a channel. So basically, what is the current shape? The current shape is this, whereas the new shape would be this. So that is the one dimension which we are adding. So if the images were RGB, then the dimension would be like this. So basically it has to be color image, right? So this into this, height into width into color channel, because this is something which is needed. Black and white images are not supported. So we have to do that. So this is what we are going to do. Now, why are we actually doing it? The only reason that we are doing this, is because TensorFlow expects the image in the 4D tensor format. And when I say 4D tensor format, I mean to say this format: batch size, height, width, and channel. And our MNIST is what? Our MNIST is grayscale images. And therefore, we have to compulsorily do this. Okay. Done. Now we finally get into building our generator and building our discriminator. And if you look over here carefully, I don't think so we are doing anything really out of the box over here. We are building a generator, and it is nothing but a normal neural network. See over here, no? Each and every line is what you very well know, right? Yes. So let us recall, what are we expected in the problem statement to do? So what we expect in GANs is we have two models. The first one is the generator, which takes the random noise and creates a fake image that looks real, and discriminator, which is going to take both real and fake images and try to decide whether the image is real or fake, and both of them are going to be trained together. Both of them get better and better, but generator ultimately becomes as good as the discriminator. So discriminator has to catch it as the real one. Then we have the create generator function started, right? So we have added a sequential layer, then the dense layer. See, this input dimension is equal to 100. Now, what is this? This is something new for us. So friends, this input dimension equal to 100 is exactly the number or the random vector that we have to see. I was generating just a single value between 0 to 1, but I told you we will be generating a 100-dimensional vector, right? And we know we always start with the random noise, and then with time it will be getting converted into the realistic images. Then we are adding two hidden layers, right? So it may happen, layer one may learn random edges, and layer 2 may learn the curves, and layer 3 may learn the digit shapes. And then we are adding one more hidden layer of 784. Now, why is this 784? Right? Because we know that 28 into 28 is 784, right? We know that very well. So here at the last, I compulsorily say dense of 784. Now, this is exactly what we call as the output layer. And we know that each of the MNIST image has to be of 28 cross 28, right? So the generator is expected now to compulsorily give an output of 784 values. And then I'm reshaping that to 28 cross 28 cross 1. That 1 is nothing but the channel for the grayscale, right? So this is what we are doing. Then coming on to the discriminator. Sequential layer created. Now, what is the job of the discriminator? The job of the discriminator is to take the real and the fake image and tell the probability of being real. So it is like unfolding the image, right? So the dense layers can process it. So I am adding layers progressively, 1024, then 512, and then 256. 56. And at the end, I'm adding 1 because there should be only one neuron that will give a single probability, right? So sigmoid has to give an output which is interpretable. 1 means real, 0 means fake. So this is the judge of the GAN, right? So just in short, if I look at the generator summary in the architecture, this is what we understand. You can read through this. And if you look at the discriminator summary, this is what we did. Just a quick read through of this. Now that we have gone through it, it's time for us to compile the model. See the compilation process, it's not really different, right? If you look into the compilation process from TensorFlow, I'm importing sequential and model once again. Create discriminator, which is nothing but this function. We have yet not called it, and similarly create generator. So first we are creating a discriminator, right? Then the discriminator, the loss and for this is already being set. And then we are also creating a generator where I say model.compile with this. Then if you see, one interesting thing that I am making is discriminator.trainable is equal to false. So what am I doing initially? This line is important. So before we build our full GANs, we freeze the discriminator weights temporarily. And the reason why we do it is, see, we want to train the generator to make better fakes. So the discriminator should act as a fixed evaluator. Its parameters should not change during the combined training step. So the idea is like this. Then I say input shape is equal to 100 comma. Why 100 comma? Because we only asked it to generate a random vector of 100 size, right? Same dimension as the input dimension. And then that is what is going to the generator, which is inside X. And the generator ka output is going to the discriminator. And as you can see in the models, the input is the generator wala thing and the output is the discriminator wala thing. And we say GAN.compile. And we say GAN.compile. So this is the main idea behind this. So in this combined model, we will only train the generator weights and the discriminator remains frozen. Therefore, I wrote trainable equal to false. This will tell us how successfully the generator fooled the discriminator. So following are the things that we understand. Meanwhile, why to reshape in the generator, flatten in discriminator? Can we not? No, you cannot skip them because we need to do that because ultimately in the generator, we wanted to generate images of 28 cross 28 from a 100 cross 100 size random vector. And in the discriminator, we want it to be converted into 28 cross 28 because we want to see the images. So you have to do that. Without that, the output will be completely meaningless to you, Ramani. So that comes like a compulsory step. You cannot skip reshaping it. Else the output is something which we will never be able to interpret. Now it is the time for us to actually train the model. See, this is the main code. You can read these 2 lines, right? We are training the model over here. Train the model, which involves feeding the data into the models, adjusting the weights of the models based on the output. Primary aim for the generator is to create images indistinguishable from the real images by the discriminator. So there is a function, as you can see, over here, which has been created. We have yet not called it, but let's try to understand how many number of epochs I have to train for I'll be supplying over here. And the batch size also, we have learned all of this, right? So epochs is how many times the model has to go through the entire data set. And batch size is how many samples will be processed at a time. Then again, we are loading the data set, right? Just to show, putting everything into a single cell. Then after that, you do the same thing, dimensions. Then here, why train once? So what am I doing basically is I am creating the label. So essentially, I'll just write down what I am trying to do in this scenario, right? So why train once, which you have over here, which is np.once batch size, comma this. So batch size, whatever we supply. So label 1 for real images. That's what I'm saying. And y train 0 is label 0 for the 0 images. And therefore I said that the function is zeros. And y train once, as you can see once again, 100 comma 1. So label 1 for testing the generator, where we want to check if the fake image can fool the discriminator. Yes or no. See, why do we need these labels? Discriminator is a binary classifier, right? So it needs to know what is real and what is fake. Generators don't use labels directly, but they learn through the GANs feedback. Therefore, I say over here, we are iterating through the epochs. As you can see, we have for E in range of this, which is for running the epochs, complete pass over the data set. And the inner loop is for running over the batches. Extend.shape of 0. Then you have the floor division batch size, which gives the total number of batches. Discriminator.trainable is equal to false. You understand it. Then in every batch, if you see, X batch is equal to extend.batch. So what is it doing? It is taking one batch of the real things from the MNIST data set. Nothing other than that. It will take one batch of the real images from the MNIST. And then after that, when I say discriminator.train on batch, so it will be training on that particular batch, which is saying X is equal to X batch and Y is equal to the target labels. Now the target labels, I do one for real, and for noise, I'm using this formula 1 minus 0.1 into np.random. See, it will make the labels a bit less than 1, maybe 0.93, 0.88, something like that instead of perfect 1. So, this is called as label smoothing. It will prevent the discriminator from overfitting, being too confident. So it's basically I am ensuring that the output is not 1, but somewhere close to 1. Right? The output is not 1, but somewhere close to 1. Then, again, if at this point of time, if you are finding this code overwhelming, you can completely ignore. You can completely ignore, and I say that so confidently is because the code will never ever change. I repeat, the code will never ever change. It is dirty, as I told you sometime back, Manu. It is dirty. So I'll explain it once again. No, we're not trying to distort the image. You are unnecessarily investing a lot of energy in understanding. I will tell you in short once again what I did. X is equal to X batch is where we are training the discriminator on the input images which are real. And the target labels for the real images are expected to be 1. But I have added slight noise over there because anyways the output is going to be sigmoid. So instead of 1, it will make it little bit less than 1. Because what am I saying? Logically, if you see, what am I saying? 1 minus some small number. 1 minus some small number. So the output is going to be somewhat bit less than 1. It can be 0.99, it can be 0.82, it can be 0.89, could be something like that. And this is what we call as label smoothing, which will prevent the discriminator from being too confident and overpowering the generator. So basically, it's a way to balance the training and stabilize it. Simple. Right? Yes. Good. Then fake samples. So when I say Z noise, Z noise is where I am generating a batch of a random noise vector of size 100. Right? So you can see over here, it's just a random vector which is getting generated using NumPy's random.normal function. Scaling is 1, mean is to be 0, and the size of the data set would be batch size, 100. Then generator.predict on Z noise. So I'm using the generator to turn that into a fake image. And then discriminator.train. So it will train the discriminator. So input to the discriminator is a fake image and the label is 0 because they are fake. So discriminator is basically seeing both, right? It is seeing the real images in every iteration and also the fake image in every iteration, just like I explained you in the architecture. So the discriminator is learning to differentiate in between the two. And then they have not used the loss function as the negative logarithm log loss, but that is more popular. This is Simplilearn's notebook. I didn't change it. So what are we doing? So if you see carefully, if you look into this formula, D loss is equal to, it is doing nothing but A plus B upon 2. Loss of real plus loss of fake upon 2. That is what multiplied by 0.5 is. So I'm averaging the real and the fake losses to get the discriminator loss for each batch. And this will give a fair measure of how the discriminator performed overall. So the idea is very simple. If the discriminator is performing well, if the discriminator is having the D loss low, then it is performing well. Else, the discriminator is getting fooled more often. Then after that, Manu, I'm straight away using the Simplilearn's notebook. I have told you a couple of times, it's not important. And let me tell you, if you go to Google, you will find that notebook as well very easily. According to me, this is not a very important topic. Therefore, we are doing it. Also, I'd like to tell you one more thing. Still, the depth to which I am covering this topic, you can actually cross-check with the resources available in the Simplilearn deck and the notebook. What we have gone into is far more detailed than that, Manu, right? I would also like to tell you that in GANs, there are around 4 to 5 types of GANs as well. You have the style GANs, you have the convolutional GANs, you have the cyclic GANs. So basically, GAN in itself can be a 20-hour course. You're getting my point? GAN in itself can be a 20-hour course. That's the reason. And after that also, the code is going to be standard and it will be like that only. Code in all the cases, you go to Kaggle and you search for style GANs. You go to Kaggle and you search for DC GANs. You go to Kaggle and you search for convolutional GANs. You go to Kaggle and you search for CYCLI, cyclical GANs. Everything is available. You can just execute the code and see. All the codes will be dirty. This is still relatively more simpler. Trust me. This is relatively more simpler. So I decided, let me go ahead with that. I have 7 to 8 representations of it. And to be very honest, not required. I mean, I'm not saying it's not an important topic, but it is a standard topic is what I am saying. So in the interviews as well, logically, now you're working for Adobe, you know that, right? How much of the images are really relevant for you to be understanding this architecture from this development perspective, because images can be generated directly using Adobe Firefly, using OpenAI model, using Midjourney. And if you ever have to create your own architecture, let's say you are using the GANs only. So the code is standard. That is what is my thing. So you'll find the log loss implementation as well easily on the internet. Right? You'll easily find it. Specifically, you go to Kaggle, you'll find it in the very first place. Right? So then, after that, what are we doing then? I'm computing the D-loss. And then I say discriminator dot trainable is equal to false. And then GAN dot train on batch. So I am freezing the discriminator weight so that the generator only is learning. And then when I say GAN dot train on batch, the input will be a noise vector. Target label will be kind of the real ones, right? Pretending at least to be the real, because the generator should produce images so good so that the discriminator outputs it as being real. So we are tricking the GAN. The generator creates the fake images. Discriminator predicts the probabilities. And we force the GAN to think that these labels are real by passing label equal to 1 over here. And then I'm going to print which epoch is going on. And that's exactly where I start with it. I train it for a total of 50 epochs. Right. This is what we see. So if you see inside the decoder where we have computed D-loss real, we have computed D-loss fake, and then we have calculated the D-loss. So what did we do over here? The train on batch function will be automatically doing forward pass and calculating predictions. There will be a backward pass which will compute the gradients and update the weights, right? This is what is going to happen. So both these lines are already updating the discriminator's weight internally. So the discriminator has already learned both the real and fake images. And when I say D-loss is equal to the average of real and fake, we are calculating an average number value just for display. It does not influence the training anymore. It is going to be just like a report card that, hey, we were doing like this before and we are doing like this now, just for our understanding. Right? So just to see. Then we are executing it. I trained it for 50 and you can see the D-loss and the G-loss. Right. This is going to happen for all the 50 epochs. And then it is the time for us to actually generate an image and look at what are the images that we are able to see from this. See, this is how the output looks like. Now you might say that, oh my God, this is so bad, Darshan. You trained it only for 50 epochs, no? That is the reason you are able to see it so ugly. GANs really need to be trained for thousands of epochs with millions of images. 60,000 is too less. Let's see. What are we doing here? Generate new images and evaluate the performance of the GAN. So I'm going to generate a random noise vector and feed it into the trained generator or create new images. So let's do it quickly. So here. Now at this stage, what are we doing? The discriminator and the generator, they have been trained through the adversarial learning. Now I'll be taking a random noise vector, giving it to the trained generator, and we'll try to visualize the output. Essentially, this is what we are trying to do. So importing matplotlib, and then we are generating 100 cross 100 is the shape. So I'm going to generate 100 random vectors because the length of it was set as 100 by us. We can play around with that. And that too, I'm doing it using the normal distribution. That's why I'm saying random.normal, which means the mean will be 0 and the standard deviation would be 1. Mean would be 0 and the standard deviation would be 1. I say generator, go and predict, right? So it will be taking the random noise and it will be transforming it into a 28 cross 28 grayscale image. And this is going to be the fake image generation step. Noise in goes to the generator and you have the fake handwritten digit out. And each fake will now look like a digit, ideally resembling one of the MNIST digit. And then I am setting the figure size. I am going through this lot of things that you have. And I'm creating a 10 cross 10 subplot and I'm generating the images and plotting it over here, right? And this is what you see over here. So this is the quality of the output that I have received after 50 epochs of training. So looking at this, what do we understand? If you look at these outputs, there is one thing definitely that we can figure out from here. All the images, all the images, we have 100 generated images which are looking almost identical. So they all seem to represent a similar pattern. Maybe something which is resembling a single digit. Hopefully a number like 9 or 3 is what I understand from this pattern. We understand that there is no variation in the fake digits. Every image is nearly the same with a very slight difference. Maybe in the brightness. Right. So, variety of the digits? No, there is a poor variety. Generator has collapsed to one output mode, which is probably 9 or 3. Coming on to the sharpness and the clarity of the images, sorry. Images are blurry and they are not crisp like real MNIST digits, which means it probably needs longer training or better architecture, right? So if I say each image is looking very vaguely like a digit, but not distinctly human readable, which means the generator so far has only learned the basic structure, but not the fine details. Or maybe the discriminator has likely overpowered the generator or vice versa, which means it needs tuning. So what are the common reasons for this to happen? Number one, our training steps are too few. You only trained for several epochs. Number two could be the discriminator learned too fast. It became so powerful that it started rejecting all the samples from the generator. Third could be, as Sandeep was saying, the learning rate imbalance could be one of the factor. So both of them use the same optimizer, add them with default. So if one learns faster and other cannot catch up, that might have led to imbalance. Fourth could be lack of noise variety. So I always gave noise of 100, which is fine. But if the training never exposes diverse noise properly, then the generator will not be able to generalize. Another reason could be my architecture, which I use, right? You saw the sequential layer and dense layer and the output, right? Maybe it's too simple. They're fully connected dense model. We didn't use any convolution over there, which is the heart of the image processing. Nahi use kiya na. For image data, we know that CNN layers help the model to understand the spatial features, edges, curves, shapes, and without them, the generator will just struggle to learn the distinct features. So what you can do as a recommendation in order to improve the quality of the generated image, number one is train longer. Where I said start with 5 to 10 epochs, gradually increase. You'll begin to see a variety after 10 to 20 epochs. Number two is use different learning rates. So I would say it's better that you try a slightly slower discriminator. Something like this, right? Import Adam, learning rate, you reduce it. That could be one of the thing. So this will keep the training balanced and the generator can get enough time. The third is what I said is use convolutional layers for better image structure. So as I told you some time back, you can actually upgrade your architecture to the DC GAN. You can replace the dense layer with the convolution 2D transpose in the generator. You can replace the flatten with convolution 2D in the discriminator, and this will help to capture the edge patterns to be more realistic. We added some noise to flatten out. You can play more around with the label smoothing. So we already did that, right? We already did that. But what you can do is you can further add more dropout layers in the discriminator, or we can shuffle the batch during training. This will help to stabilize faster. And another important reason is you should always visualize the intermediate result, which means that after every several epochs, ask it to show the progress. And how do you make that possible? That you make that possible by writing after every epochs, right? You just say after every 100 epochs, display the images. So if you don't see improvement, you can stop the training, right? This is what I can say over here in order to improve the results. So one of the thing which I did, you will not believe I did that by mistake. This same notebook, this is the same notebook. I just gave name as new. And if you see this was our output. Sorry, this was our output. All right. What I did is by mistake, it happened. We trained it for 50 epochs. No, it happened by mistake from me. I tried for 150 epochs and then it was almost 2 hours and it was still running. And I was like, what the hell is happening? Why is my fan on? It is running, battery is draining. Then I saw by mistakenly I wrote 1500 epochs, but I didn't stop it. I said, let me see what happens. It took me total 367 minutes, 37 seconds, which means I started at morning 9:30 a.m. 9:30 or 9:15 is what I started with, and I completed it at around 4 p.m. my laptop was continuously running. Right. And after that, see, this is what we were able to achieve. So not a straightforward thing as well. Look into it. So this is the demo for the variational autoencoders. If I just say, wait, I'll do one thing. I'll just create a copy of this. And if I just say run all. So VAEs, which is the next topic, variational autoencoders, they are also used for generating images. You can see I'm getting a tick in each and every cell. We are designing this. This is the VAE, and the training is going to happen for 100 epochs. Obviously, if the training started, it's quite obvious that it is going to end. Let us see what we get inside this. So here you can see the training is started and it is going to go on for 100 epochs. And then I'm asking it to generate digits and see VAs. This is the result of VAs, which we have got. You can clearly see little better, right? VA's results are little better. Okay. You see that over here. Now, if I get into the flow, now after this, we have to get into LangChain, RAG, and fine tuning. Now, I'll be focusing on the RAG because LangChain and RAG will be covered side by side. Right. So let me try to explain you today. In the next session, I'll start with the proper concept of a RAG as well and the VAs as well. Okay. Have a look at this then. I come over here. You don't have the access to that. You know that. And I see over here, I get into the dashboard. And here I am clicking on assistants. And I'm going to create an assistant. How did I create it? It's very simple. I clicked on create button. I clicked on this create button without using any code. I clicked on this create button. Then it will ask me for a name. It will ask me for system instructions. You know very well what is the system instruction. Cuff stuck up. And then it will ask you which model you want. And then here we'll be adding a file. We'll be adding a file search. So I'll be uploading a file. Basically, what is RAG? Look into the PDF. I tell a LLM that, hey, look into the PDF and give me the answer. Look into the PDF and give me the answer. That is RAG. So if I ask to the large language model that how many leaves are allowed for an Adobe employee working in the Bangalore office at Marathalli, do you think the ChatGPT 5 would be knowing this? Adobe employee working at Bangalore office in Marathalli specifically, do you think this information will be available anywhere on the internet? Will this be available, Manu? Are the HR policies available specifically for Bangalore office? Ideally, not really, that's correct. Or if I say over here that what was the profit obtained in the second quarter of 2025 for Adobe Office at Bangalore location. India. Not Bangalore, India location. Do you think, sorry, I mean, there was some text to speech mistake, speech to text, but what was the profit obtained for Adobe Office at India location? This will not be available. See, ChatGPT has studied the entire internet data, but has Adobe published these all information publicly? What is the office? If yes, maybe ChatGPT studied it. But if no, ChatGPT has not studied it. And that is exactly what we are talking about over here. So we do that, and then you don't change anything over here, and you have a RAG assistant. I'll show you one of it, which I already created. So if you see over here, I created this by this name. The system instruction which I gave was this: you are a professional HR policy assistant for the Circa Paints India Limited. This is one of the PDF which I have appended, and you respond strictly and accurately based on the SPIL corporate policies. You always initiate by greeting the employee in a polite way. Then your help is to provide employees with the HR staff or other related things. You don't provide generic HR advice, assumptions, personal opinions, or legal interpretations. If the user asks a question that is unrelated to SPL policies, out of the scope, or humorous, sarcastic, speculative, inappropriate, then politely reply, this assistant is designed for only answering questions on the official SPIL HR policy. SPIL is the name of the company name, called as Circa Paints India Limited. That PDF only I have uploaded. Always maintain respectful tone, and the topics which are covered are this. Act strictly as a policy assistant. Do not respond to personal questions, hypothetical scenarios, etc. And then file search added. I have already added. And if I want to communicate with it, I'll just click on edit, and here I have it. So if I say hi and I say run, if you want, I'll show you the document as well, what is there. So, and it says this assistant is designed to only answer HR related questions. Okay. I have just passed my 12th standard. Will I get any job at this organization? And let's see. It says this is not for that. Okay. What salary will I get if I join as an intern? It should say 7,000. We just saw it. And the policy does not contain, maybe I didn't upload it, or I don't know why it happened. I can add it once again just to be on a safer side. So, and I ask this question. What salary will I get if I join? See, running retrieval. It is 7,000. Okay. Is there some work flexibility in this organization? Policy does not talk about that. CC, it is not able to retrieve. I'll try asking it once again. Not there. Failed. Okay. I say, what will be the salary that I will get if I join as a management trainee? Running retrieval. So this is the idea behind RAG. You see, we get the answer, right? If I say, is there any reward that my children will get if they score better percentage in the schools? Actually, there is information like that in that PDF. So if your child is in 5th standard and he scores more than 85%, he gets around 2,500 rupees of cash. See, this is there in the PDF, right? Plus his name will also be published on the HR newsletter, etc., etc. So it's there, and the source for this is also given. This is RAG at a higher level. Let us get started with the concept of the retrieval augmented generation. Yesterday, I gave you a little heads up. What is RAG? RAG is mainly about how you can instruct a large language model to get out some information from the external source, maybe like a PDF file or a CSV file. This is essentially what we have understood so far. Now let's try to understand these things in a little bit more detail. And I'm creating another notebook. Right. Let's get started with it. So, starting with the question, how many of you have seen or have used ChatGPT, Gemini, or Copilot and realized that sometimes it gives beautifully structured answer, but they are confidently wrong. But they are confidently wrong. Many times, many times. Yes, it had happened, right? Yes. You might have seen that it sounds perfect, but it is factually incorrect. And the reason for that is very simple. Large language models are very knowledgeable storytellers. They are like very knowledgeable storytellers because we know that they are being trained on massive text data from the internet. So they have mugged up everything from the internet. And once their training is complete, they stop learning. So if ChatGPT 3.5 was trained till the data of October 2023, it has no idea about what happened in November 2023. So other than that, they also don't know your private data or anything that had happened after their cutoff date. So what happens when you ask them question beyond their memory? They do exactly what humans do under pressure. They guess elegantly. I repeat, they guess elegantly. And this guessing problem is what we call as hallucination in the large language model. This guessing problem is called as hallucination in the large language model. So now, in simple words, hallucination is when the large language model makes up the information that sounds correct, but is actually false or not based on the real data. So it is like when someone confidently gives an answer, but they are actually guessing. Let me give you an example of it. Example 1 of factual hallucination. So when I say factual hallucination, imagine I ask a question, who invented light bulb? And it says Nikola Tesla invented the light bulb. But the reality is it was Thomas Edison, though it was contributed by others as well. So what did we see? The model has hallucinated Tesla's name because it is a famous inventor, right? Because it is a famous inventor, it has done that. Let me give you another example. If you ask it, give me the scientific paper proving that humans can photosynthesize, and it answers, according to Smith et al. 2018 Journal of Human Biology, humans can photosynthesize. Now, that paper doesn't exist. The model made it up to sound credible. The model made it up to sound credible. Let me give you one more example of detailed hallucination. So over here, if I just summarize this article about climate change, the model is talking about, the model will be adding details that were not there in the article at all. Something new statistics or maybe codes. So, this is what we call as filling the gaps using some pattern such that it looks plausible to the user. Now coming on to why is this all happening, right? One thing is for sure that LLMs don't have an understanding of their own generated content. They are trained in a way, given a word, what is the most probable next word? Given a word, what is the most probable next word? This is exactly how they are trained. So they don't know the facts. They predict the word based on the patterns from the training data. So therefore we say when they don't know enough context or see confusing inputs, what do they do? The first thing which they try to do is they try to fill in the blanks. The second thing what they do is they try to sound confident because that's how human text often looks like. And because of that, they can easily invent the things. So now we will have to look into the ways to reduce the hallucination. Number one, grounding or retrieval. Connect the model to the real data. That's what RAG is. So real data can come from a database, which is like PDF, CSV, or maybe internet search. So the model will fetch the real facts instead of guessing. Asking for the sources. Make the model verify or cite the references. Can you provide a link or source for that? Use updated content. So always give your model your text article before asking. So here is the report, summarize it. Do it that way. Fact check the output. Humans or automated tools verify the key facts, which is using the high quality reviewed databases. And encourage, train or, this is about comparing to the trusted site. Sorry for that. Train or fine tune on verified data, which will reduce the chance of making up the things up. Use high quality and reviewed database and encourage uncertainty. So ask the model to say, I don't know when unsure. In the prompt only you write it. If you're unsure, say so. That's fine, but don't cook up the story. So essentially, hallucination is confidently giving the wrong output. And the cause is guessing the pattern instead of retrieving the facts. And the fixes to connect to the real data, verify design prompts carefully. Coming on to this problem of hallucination. It is not acceptable in the domains like banking, healthcare, or legal, where accuracy matters more than eloquence. And this is exactly where our RAG comes into picture. So in simple words, we understand RAG is like giving your large language model a search engine for truth before it starts speaking. Let me start with a question for you again. So I say over here, imagine you are an interviewer who is about to take a technical interview. You haven't prepared in months. Would you trust your memory for the last year's preparation or quickly Google the latest concepts before answering? Say to this that the answer would be option B. And let me tell you, this is exactly what the RAG does. This is exactly what the RAG does. So instead of relying on the model's old memory, RAG is going to let the model retrieve the most recent and the most relevant information. And then it is going to use that to generate the answer using both, what it already knows about and what it has fetched. So in simple words, I always think of, what is RAG in layman terms? You can think of RAG as giving your large language model an open book exam. I'll ask you something and you can refer this book and answer. So it will not recall just from its own knowledge, but it will also recall from the external sources like PDFs, databases, enterprise knowledge bases before responding. Okay. Now, let's connect to some real world problem. Now, imagine you are working in a large organization and you want to ask a chatbot, what's our leave policy after maternity leave? Or summarize the last quarter's performance. Or do you think ChatGPT as it is can answer that? That's the question. The question is, this information, do you think ChatGPT can answer it as it is? No. Yes. And the reason is it does not have access to your internal information. It does not have access to your internal data, but a RAG-based chatbot can. It can connect your company's document, retrieve the relevant chunks from it, and then use the LLM to compose a human-like, contextually accurate answer. So, in simple words, if you talk about it, your large language model knows the language pattern. Coming on to your RAG, it knows or it adds your data. And therefore, I say together, both of this help you to get accurate, context aware, and the grounded answer. Right. So this is what we understand. So our RAG, in simple words, consists of the following things. Two worlds are there inside RAG. The first is the retrieval, which is responsible for finding out the information from the external sources, and generation, which is using those facts to craft fluent natural language. Therefore, in very, very simple words, we can say RAG is equal to search, which is retrieval, and speak, which is equal to generation. Right. And this is not the only scenario. This is not the only scenario. Let me ask you one more interesting question. This is the last but the most important thing. Suppose your company wants to build a chatbot that understands your documents, policies, and reports. Now, the thing is, would you rather train or fine-tune your LLM with all the company data, or plug your answer into ChatGPT or any other open source model that already exists and just let it refer it? Tell me, which option do you support? Wait. Don't type anything into the chat box. Just a moment. Just give a thumbs up now. right? So that will be easy. Which option will you prefer, Connor? It's a personal choice. It's a personal choice. So I will not say there is any right or wrong answer to that. But whatever answer you are giving, have some mental justification for it. Why I'm going for option A or why I'm going for option B. You should have at least one reason for you choosing option A or not choosing option A. When you talk about fine-tuning a large language model, even if you're considering 13 billion parameter model, ChatGPT is 175 billion parameter, 175. This is just 13. So if you're even fine-tuning a 13 billion parameter model, fine-tuning it on your data could cost you thousands of dollars. And this is not just one-time training. And along with that, you also are charged for the storage, GPU, and retraining every time your data is going to change. Just to give you a little bit more justifications around it, if you look at the cost, fine-tuning is very high. You have to train the model, and if your data changes, you are having your own company data, documents, policies, reports. If any data changes or if anything updates, your model will have no idea about it because you trained it last month. Now it has changed, which means you have to retrain it. In RAG, there is no model training happening. It is just accessing it like an open book exam. Always remember that the time for fine tuning can be weeks or months, whereas RAG is hours or days. Data updates. Fine tuning will need retraining when the data updates. Whereas in RAG, it is almost instantly reflected. Now, almost instantly, that means, of course, you have to chunk it with the new data, but it is still way more faster. Flexibility wise, it is fixed to the trained data, and this is dynamic and updatable. Here, there is a risk of overfitting, and here the data stays external, so there is no such risk over here. So if your HR policy or customer data changes next week, in fine tuning, you will have to train again, costing you time and the GPU cycles. But with RAG, you will be just updating your so-called vector database. Right. The model stays the same, but it fetches new facts before the answer. Now, therefore, I always prefer this to be defined something like this. Fine tuning is like engraving information on a stone. It is costly and hard to change. And RAG is like reading a dynamic library, cheaper, flexible, and always current. Right. So I'll take a real example and close this topic. Let's say you have 1000 internal documents and you want a chatbot to learn from it. Just 1000 internal documents and you want the chatbot to learn from it. Let us actually convert it into a perfect table. So I say, over here, in this scenario, I will talk about three things approximately. I'll be talking about the first option would be the step. Then I will talk about the approximate cost for fine tuning and the approximate cost for RAG. Okay, so over here, let's talk about this. If you talk about training a model, then let me tell you that if you're fine tuning, the costing goes to around $3,000 to $10,000 for fine tuning. And in RAG, the costing is $0. You would also have to host your GPU. So for fine tuning, that will cost you somewhere around $1,000, and your RAG will cost you somewhere around $100 to $200, and this costing is for this vector store because your documents are stored inside this. The third one is when your data updates, then you need to retrain the model, which will again cost you around $3,000. Whereas in fine tuning, you are just re-embedding, which will cost you somewhere between $50 to $100. So effectively, the total yearly expenditure, if you are going for fine tuning, goes to around $20,000 or more than that, roughly. And in RAG, it is just $1,000 to $2,000. That's why companies like Walmart, Salesforce, Deloitte, they use this, right? So this is what is one of the important point I would like to address. Okay, now there was a question in the chat box. Do we have to consider data security? I hope you are talking with respect to the RAG, right? Data security definitely matters in RAG. One of the key security concern is you are exposing your sensitive data. So if the retrieval database is containing private or proprietary data, then the model might leak or reproduce the data in the output. It could be their customer records, proprietary data, that all things, or confidential research notes, could be anything. Plus, there must be access control, right? So who should be allowed to query the system? So RAG pipelines, ideally, these all are something which we do in any software development project, not only in RAG. So the same thing applies here as well. So the pipeline of the RAG must ideally enforce authorization and authentication both. So it's not only about retrieving the information, but also checking whether the user has the permission to see that information. Another thing is you can, data storage. Data storage, where your embeddings, your metadata, they are stored into the vector database, and that may contain the sensitive patterns. So you can use the encryption at rest and in transit, or for documents as well as for embeddings. Also, at times, there is something which we learned as prompt injection. So attackers can craft they can craft meticulous prompts to trick the retriever or LLM into retrieving the hidden data or executing harmful instructions. Plus, there can be third-party dependencies if you are using some external APIs like OpenAI endpoints, or if your vector database is not internal, but it is external like Pinecone or VV8, then you will have to check not only OpenAI, but also the vector databases, data retention and compliance policies. So are they following the GDPR and the HIPAA regulations? Then, hey, below. And The next important that we always follow as a standard practice in the industry is the logging, right? Audit and logging, so that we can actually store everything, right? So all of this must be protected. So best practice, as a best practice over here, I can say that when it comes to data classification, it is important to identify initially what data is confidential and restrict it in the retrieval source. Coming on to the access control, you should always implement on the top of the rack pipeline user level filtering. So per user or per role level indexes. Then, so there will be a different system message for each type of user. Encryption is also very important. You can encrypt your documents and then store it. And there must be secure hosting. So when you run your vector stores and the LLM, it must be run in a secure and private environment. Data security is definitely integral to your RAG system, and therefore you have to secure the data you retrieve, the pipeline that is going to retrieve the data, as well as the model. Otherwise, even if you are having a well-designed RAG system, it can unintentionally leak or misuse sensitive information. This thing is something which can definitely happen. Right, good. That is enough. I come over here. I close it. Now we get into the RAG architecture. Now, what are we basically over here doing, right? Yesterday, I think I had given you a glimpse of this particular file, Circa Paints India Limited. Just to quickly take you through it again, if in case anyone was not there in the yesterday's class. So it is about the corporate HR policies and the manuals. So here, the sales vision. They have their own full form for respect, as I told you yesterday. For growth also have their own full form. Then as I told you, for interns, you have a stipend of 7,000 rupees to boost the morale. If you are placed through campus as a management trainee, graduate trainee, junior executive, you will be placed into the slab of this. HR representative will give you proper induction training to the candidate and assign a HR buddy for 3 months only. So attendance wise, you can see working days, Monday to Saturday. These are the flexible timings, this or this. 15 minutes will be the grace period. Beyond that, leave will be deducted. You are eligible for 2 leaves in a month. If you get a compensatory leave, you will get a lunch of ₹100. And for availing compensatory leave, employee has to complete minimum 6 hours of work and has to inform at least 3 days in advance before you're going to take your planned leave. If you are on probation, your notice period to serve is 10 days. And for the confirmed employee, it is 30 days. After verbal discussion with the employee, department heads will accept or reject the resignation within 5 working days from the date of resignation. Then procedure for grievance addressal, again in the form of a table or a flow chart. Welfare and enhanced programs, they are there. We're talking about all of those things. Then employee children merit award. If your child is in 5th standard, scores above 85%, cash reward of 2,500, for 8 standard 3,500, 5,000 and 10,000 for 10 and 12. Plus the name will be published on the website as well as in the HR newsletter. For salary advance also you have some things, etc., etc. So now the first and foremost thing that we do inside RAG is you have one PDF or you have multiple PDFs. Any number of things could be there. What you will have to do, you will have to load the data. I just straight away go to ChatGPT and I asked ChatGPT that what are the Python packages available to read a PDF data, extract the data from a PDF file. Put it in the form of a table where the first column will be the name of the library. Next column, what it can extract like text or image or table or scanned PDF OCR. Third column, the advantages of that library. Fourth column are the limitations of that library. Fifth column is the practical real-time use of it in the industry. For which type of use cases? Large PDF or small PDF? Let it come out now. If you see, so many packages are available. So once you have a PDF like the Sirca Pens India Limited, and I have to read the data from the PDF, the first library which it has recommended is this Pipe PDF 2. So it can extract text, metadata, merge or split PDFs. Advantages, it is pure Python, it is lightweight, easy to use and support PDF splitting and merging. Limitations, it cannot extract images or tables well, poor layout preservation and no OCR. So it is good for small PDF with structured text like reports, invoices, etc. If you talk about PDF Miner.6, it is useful for text, layout or metadata. It can extract text within position. It also supports complex layout. It is good for NLP pre-processing, but limitation is it is slower and it is again not for images or tables. So if your PDF is having images or table, you cannot use this. Real-time use, text analytics, data extraction from the structured PDF. You have FITS, which is available via PyMU PDF. You have to install this pip install FITS to get this. Text, images, metadata, annotations. It is fast, powerful, extract images accurately, and also supports OCR. Very good. It is slightly complex API and not ideal for large-scale batch OCR. So medium to large PDFs requiring text and image extraction is where you can use it. PDF Plumber is available. You know why am I going through ChatGPT? Because these things are available through the LangChain document loaders. And that website is down right now. It's in the update stage, you see. So it was all mentioned over here very clearly, but now it's not available. And this has started, I guess, 4 days back. 4 days back only I realized. So that's the reason we are going through ChatGPT. Right. But if I just go for LangChain document loaders, even if you go over here, you'll find it. So if you have a CSV file, you can see from LangChain community.documentloader.csv, import the CSV loader, create an instance of it by passing the file name and loader.load. If you're having a HTML file, external information, then import it, create an instance, pass the URL, and loader.load. If you're having a markdown file, you have this unstructured markdown loader, create an instance, loader.load. For JSON, import it, create an instance, loader.load. And everywhere it's like that only. For docs, import it, create an instance, loader.load. That's why we are doing it here. So first, then you have the PDF plumber, which is good for extracting text, tables, coordinates, metadata. Excellent table extraction, integrates with pandas, easy to parse structured layout. But the disadvantage is it is memory heavy for large PDFs and limited OCR. It's good for financial reports, scientific papers, etc. Camelot is only for extracting the tables, right? It is great for digital, not scan tables. It fails on scan PDF, does not extract text. Tabular PY is there, which is for only the tables. It is Java based. Similarly, PyPDF is there for text and this. Your PDF query is there, which is for text. And there are so many things which are listed over here, right? So, because this is the good information, I am just going to put it over here. Plus, summary recommendations. These are also good. I'm going to put it. So for text extraction, digital PDFs, these are good. For table extraction, these are good. For scan PDF, these are summary, right? Good. For large or enterprise scale use, PyME PDF or PDFEM or Tika is good. And for lightweight, these are good. So this is for the PDF, but your data can be in any format. So I say, in the same way, tell me what if the data is in the form of Microsoft Doc. So we're talking about Microsoft Doc. So you have the Python docx for extracting text tables, etc. You can read about it now. Of course, they are really good information. Doc to text is there for text and images. Then text track, which will be helpful for OCR, I guess. So yeah, because tesseract and so on. So first, now this is all, you can find it in real time anywhere. I just put it because I found something meaningful. Summary recommendations is something which is more helpful for us. So right, you can see if you want to just extract text and tables, this too. Only text, this too. Text from old doc, this. Then after that, convert to HTML or Markdown. You have Mammoth and PyPandas and so on. So we'll put this also because that's good information, right? Then after that, I think that is too much of information. But because it is good, I think we will put it industry use case scenarios where we simply say for HR or resume parsing, these are good. For legal compliance, Win32 Python is good because they can extract metadata, comments, and structure content. This may not be immediately helpful to you, but in a long run, it will be helpful. Of course, you can understand for what kind of things, what is useful. So this is what we got. In the same way, I'm asking it for Microsoft Excel files. So For Microsoft Excel, you have pandas. Yes, we have studied that. OpenPy Excel, XLRD, and many. I am just going to put it now. I'm not going to go through it, but yes, you understand the importance of it. Then in the same way, we will also go through the summary recommendation so that you know in real life where, in what case you'll use what. So that's good. And real-time industry applications, where for financial and reporting analysis, pandas, OpenPy, Excel. For data engineering, you use this, and so on. Right. Now, what if the data is in the form of JSON? These are the very popular sources. Now, for JSON also, you have multiple libraries. One is JSON only. We have used it a couple of times in the pack, and some more are also available. Right. So I'll just take it. Then summary recommendations. The best one that we are always using is JSON, simple and universal. For high performance JSON processing, very fast and efficient is OR.json or UJSON. For UJSON files, for streaming, iJSON, JSON lines. There we have it. Now, after JSON, we have HTML or a web page. Now, where we'll need it? See, sometimes your data is sometimes you will see your data is available on the web page, maybe for even the FAQs which are available on your website, and you want to create a chatbot so that user doesn't have to go through all the FAQs listed. So this is where this can be helpful. So Beautiful Soup, I think we use it in our NLP, LXML, HTML5, all of this I have used. Request is something which we use popularly. Selenium, I think it's difficult and I have never used it because Selenium in itself is a framework. Right. And then Scrapy might be there, one of it, I think. Scrapy. Scrapy is also a very large scale one and good. So you may not need it in this use case, of course, but in a long run, this can be helpful for you is what we understand. Right. For what to use in which kind of scenarios. In the same way, see, you have it for YouTube as well. So that website is not working, else entire code is available over here. Wikipedia information can also be loaded, etc. So you know from where to get it. I will not get into too much more details of it. So starting with our use case, what I do is first I enable the OpenAI key. Done. Then come over here, right click. I'm creating a new folder because whatever PDFs you have, you can put it inside this. So docs, you can create a folder, you can directly upload it. That's okay. In this, I have done it this way. Right click and upload. And I'm uploading the company policy doc. It will get uploaded inside this. Now, kindly go through the problem statement. I have given you the exact library names which have to be installed. Because earlier it was all working fine. Since last 3-4 days only, it started giving issues. So these are the exact packages that you need to install. Okay, I'm running it. Then these are the set of the what do you call? These are the set of the packages that you need, right? So I want to read the data using I want to read the PDF data. So I'm going to use the PyPDF loader. So I say from langchain underscore community dot document loaders, import this. Then from langchain underscore text splitters, import recursive character text splitter, which is for dividing the data. I will explain this thing later. Then which embedding model are you using for converting text to numbers? So for that, I need the OpenAI embedding package. Which large language model are you going to use? For that, you need the chat OpenAI package. Which vector database are you going to use? For that, you need the FAISS. And which retrieval QA are we going to use? For that, we need the retrieval QA. So for now, you don't have to worry if you don't understand all the imports, because I have not explained you, but at least I will have to execute it, right? I don't have a choice. Then whenever we need it, I will come back and give you an idea about it. Okay. My API key is saved inside the collab, so I will have to do this extra steps, which you know it very well why. I will install the PyPDF extractor. And looking into this, see, this is the file. I click on this 3 dots, copy. And essentially, this is the same path. If I just delete this and paste it, same path. So that is exactly the path which we will give here. And I say, we have imported the PyPDF loader. We are creating an instance of it. And after creating an instance, I'm going to say loader.load. This PyPDF only extracts the text from the PDF. As we discussed it some time back, it will only extract the text from the PDF. I will load it. The PDF consists of 24 pages, right? I load it. And if I try to run it, see, this is the text. This is the first page data. You can see document, metadata, producer of this PDF is I love PDF, creator is Microsoft, creation date of this PDF, author, modification date, source of the document. There are total 24 pages. This is 0th page. 24 page means it will go from 0 to 23 in the index number. And this page number is the actual number of the page. Page 1, page 2, page 3. And this is the content of the page. From SPIL policies till policies and manuals. Till policies and manuals. Done. Yeah, sorry guys. So you can say, and the last page, what is the last page? Approved by MD Sanjay Agarwal. Come over here. I'll comment it out because see, this is first, this is the second page. This is the third page and so on. But come on, that will be crazy. What I will see, I'll just see how many documents are loaded. 24 should be there ideally, right? Let's check it out. Length of documents is 24. Let me see the 0th document. Yeah, this is the same one. And -1 means the last document. And see, ending with Sanjay Agarwal. That means text data has been extracted successfully. Okay. Page-wise data has been extracted successfully. Now tell me, did we understand earlier that LLMs have a context window? Did I discuss this earlier in the past that all the large language models have a context window? Yes or no? If you don't recollect, you still give a thumbs up to no only. That's fine. Basically, I want to decide whether I should explain or not explain. Did we understand something which is called as a context window? Okay, even if there is one single no, then it's better I explain. See, LLMs do have a context window. That is the maximum amount of information that it can see at a time. Let us go over here only to ChatGPT and I say, create a table. Create a table of LLM and their context window. First column will be the name of the large language model for all the GPT models from GPT. Second column will be the context window of that LLM. Third column will be the number of the words or the total number of characters which that context window can accommodate. Fourth column will be real-time example of what can actually get accommodated in that context window, like a small paragraph or a research paper or a PhD thesis or anything else. Right? So most of you say no, 3 of you say yes. So now it is 50-50. Great. Abhi yaad aa gaya. Very nice. So now, if you talk about the GPT model evaluation, so after this, yeah, coming over here. So if you talk about GPT-1, it has a context window of 512, which accommodates around 350 to 400 words, can fit a single paragraph, short email, small code snippet. GPT-2, 1024 tokens, can fit 700 to 800 words, 4,000 characters. GPT-3, a short blog, 1 page of the text, or a small poem. GPT-3 is this, and GPT-4 is a research paper of around 20 to 25 pages. Then you have GPT-5, which can hold a complete book because it can hold around 750,000 words. Okay. Now tell me, the PDF extractor, right? The PDF extractor has extracted total 24 pages. Ideally, GPT-5 can see the can at the same time can read all the 24 pages because it can hold almost the entire corpus of the Wikipedia domain for a particular topic. It can hold a big technical document. GPT-4 Turbo only can hold the entire PhD thesis, which is somewhere like this, so many of this thickness, A4 size paper, this thickness. So GPT-5 or GPT-4 can easily hold our PDF. So can we pass the entire PDF to the GPT-4? Yes. Yes, we can definitely pass it, but we don't do that. So if you see over here, we chunk it. We chunk it means that one single page, that single page of the PDF, right? So if I just go over here and if I talk about any PDF, right? So let's say this page of the PDF, you can see this is one set of information. It is extracted entire page by page. So this is one set of information. Then this is one set of information continued, but this is another set of information and then another set of information. Then this is one set of information till here. This is another set and then this is another set. So what do we see? That inside page also we divide the data into paragraphs so that it is meaningful for us to understand. We don't just keep on writing it like a story without any paragraphs because there is a change of context. So even if GPT-4 can read the entire PDF. We don't do that. We chunk it. Why chunk it? One reason is they have limited context window. If you're using a smaller model, that could be the problem. Another thing is chunking allows semantic search over the smaller pieces of information. So you get better matching with the user's query. So it's like, if you are saying that, if I say that, hey, this is a book on machine learning, and in this book, I want you to find out the logistic regression concept. Find out the logistic regression concept in this book. And I say that, acha, logistic regression concept. You refer page number 50 to page number 62. You refer from page number 50 till page number 62. Now, this is something which I don't like. So, I mean, I will go and search the answer in right from 50 to 62. Even if someone says that, hey, the answer is there in between page number 50 to 53, it is still difficult for me. Every time a question is asked, it is going to return a couple of pages and you have to search from that couple of pages. I want it to be even more concrete. How to make it even more concrete? Don't make that chunk so big. Divide that. So that single page content that we have, that is also what we are going to break it into small parts. That will help us in faster retrieval and better accuracy. Right. So that's what we are doing. So this is what is called as chunking. So we have extracted the data. Now we chunk it. Now, if you see carefully, this is chunking. The entire data is divided into chunks. One of the most important, this chunk one is there. Then I say, NT things I didn't this is second chunk. So there is an overlap of two characters. Overlap of two characters, overlap, 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 overlap. Why are we having this overlap? It is very much possible that if you look over here, the returns for performance are, if this is one chunk, my answer is ideally super linear. But if it returns this chunk, then how does it understand this is continued? Therefore, we keep some overlap also so that it understands whether it has to refer to the next chunk or not. So now what we go and do is we do the chunking. For chunking, you have various types of chunkers. So at this point of time, from the document, we extracted the text. From the text, we are chunking. This step is not shown over here, but we chunk it. So one of the very popular type of the loader is called as recursive character text splitter. So what are we doing over here is I say you take the text and divide it into chunk of size 500 and 100. Why only 500 and 100? Why not anything else? Why did I choose this? I'll talk about it in some time. But if you look into this platform, when we created a RAG assistant yesterday, when you're uploading the file search, I just uploaded it and then I said attach. But let me tell you, here also you have the advanced options to decide the chunk size and chunk token. You can see what is chunk size. Parsed text extracted from the uploaded file will be split into chunks of size defined here. Default value is 800 tokens, minimum 100, maximum 4096. You can learn more about it. So this is just the code version of it. Then this chunk overlap. Adding an overlap of the tokens between the consecutive chunks can increase the chances of the model contextualizing the information it retrieves properly. It can be any non-negative number, but must be lesser than or equal to half of what is the defined chunk. Default is 400. So we are doing that here as well. So I am giving this. Create an instance of recursive character text splitter. Then I say text splitter dot split documents. So it's going to take the 24 pages one by one and it is going to split it. So it will return a list of chunks representing a smaller part of the document. And then I'm just printing the number of chunks created. So 24 pages were there and they are divided into 122 chunks. You can see clearly 24 pages were there divided into 122 chunks. Okay, that is one thing. So the page content and everything is what you see over here very clearly. And I just displayed the second chunk. So second chunk, basically it's the third chunk. Indexing starts from 0, therefore it's chunk of 2, but it is the third chunk. And these are the contents of it. Okay. So it's a small page, 500 characters only. If you print the third and the fourth chunk, you will see an overlap as well. And if I print the last chunk, it should show me that Sanjay Agarwal at the end, and it is. Okay. Now, why recursive character text splitter? See, there are various types of text splitter. The common chunking strategy is the recursive character text splitter. It will split at paragraphs, sentences, or words or characters logically. For example, see if it realizes that the chunk, this highlighted portion is one chunk. If recursive character text splitter realizes that this highlighted portion is one chunk, how much? 500 characters. Then the next part is going to, let's say, start from here to here. This is the next chunk. So the first chunk, let's say, goes from line number 9 to 24. And the second goes from 18 to 34. Now it realizes that, oh, this is one set of information and then there is a paragraph change and this is another set of information, but 500 is getting over here. It will automatically split it less than 500. So basically it is little smarter. It is little smarter. So it tries to split at logical boundaries based on paragraphs, sentences, words, characters, and hence we call it as recursive character text splitter, which is one of the best text splitters available. One of the best text splitter available is this. So that is one thing. There is also character text splitter. It's not that it is bad. Character text splitter is you give it a number of characters and it will exactly split that number of characters. It is naive, but it is very helpful for log files. If you have always ensured that your log files will be exactly 200 characters in length, then every log is going to be unique. So that can be helpful over here. Or in case of structured text. We have token text splitter, which OpenAI was also using. You might have seen that it is splitting by the token count. Sentence transformer token text splitter, which is going to be sentence aware splitting. Markdown text splitter, if you have the data in the form of markdown, basically you're reading technical documents, blogs, posts, or notebooks, you have it. You have HTML text splitter for HTML tags. And you have language splitter. If you're reading a Python code, JavaScript code, etc., they are very good because it will be splitting by the functions, classes, and it is great for the code topic. How do you choose it? Well, how big each chunk should be, because I did choose 500 and 100. Is that the correct value? Well, in my case, it was, but in all cases, it may not be. So these are some scenarios where I have discussed it. So for your short emails or chat transcripts, 300 to 500 is good to get started with. Policies, contracts, PDFs, 500 to 1000 characters. Technical manuals or FAQs, 800 to 1500, and so on. Tomorrow, if it does not work, don't come back to me and say that Darshan sir, you taught us wrong. I repeat, these are good educated guesses to start with. It purely depends on the business context. No guarantee. But at least it's better to start with something. We did the same thing in machine learning for hyperparameter tuning, in deep learning as well. So you have to play around with it till you get good results. Then for chunk overlap also, you can refer this table. Well, one golden rule or guru mantra would be 10% to 20% of whatever is the chunk size that you give. If chunk size is 1000, you keep this between 100 to 200. That's good in almost all the cases, in my opinion. And the way to do that is very simple. Pass this to for contract documents, because they have often long clauses. For FAQs, 700, 100, and for code files, you can use this 30 and 10. Simple. Done. So I remember I did say that OpenAI's embedding model extract around 1536 dimension. And if you are using the all mini LM L6 V2, they extract 384 dimension. And this is what I remember. If I just try to look somewhere in the past just to cross check. And cosine similarity is what we looked at. And then we talked about how do you extract the embeddings of dog and cat. Very nice. My life is so simple now. And we also figured out this. Okay. Life was awesome and great. Perfect. So now it is the time for us to give these chunks, 122 chunks. So 24 pages were there. We have got it divided into 122 chunks. And now these chunks have to be converted to vectors. Now this chunk have to be converted to vectors. So for that, we'll be using the embedding model, which we just studied yesterday. So here we are not using the OpenAI API, we are using LangChain. So if you remember here, from LangChain OpenAI, import the OpenAI embeddings, right? Because this is the way you do it. We are not working on chat.completions.create or chat.embeddings.create. No, it's LangChain. So this is the place where I'm creating an instance of OpenAI embeddings and I'm passing the API key, and which is the embedding model. I didn't pass it. So what will happen? It will pick up the default embedding model. If I run it, and then I'm checking the embedding model by using embeddings.model. This is embeddings.model. So it is using the text embedding ADA002. If you want to be specific, you can also do it this way. Embeddings is equal to, instead of line number 3, you can write embedding is equal to supply the model and the API key. In case if you want to give a specific model of your choice, you do it this way. Okay. So we give that. Then after this, so embedding are there. So embeddings are there. Now what? Where do you store the embeddings? Embeddings are ready. Where will you store those embeddings? So for every sentence, it has generated an embedding. For every chunk, it has generated an embedding, and each chunk is of 1536 size. So where to store it? I can store it locally in my computer. Point number one. I can also store it to my Google Drive. I can store it anywhere, but I store it into a specialized database, which is called as a vector database. Why vector database? Because vector databases store it in a very nice and structured way, and they also create an index for that. So if I say that I am having a book without an index, it is useless or it is meaningless. So it is very important that you write down or create an index for the book. So vector database does that. There are various types of vector database. Let's first look into this. So the vector database which I am using is FAISS CPU. Actually, it is only FAISS. CPU is because there are two versions of it. One is GPU, one is CPU. Because I am connected to CPU, I'm using FAISS CPU. And then I have to import it as well. And let